Hi guys, welcome to the most comprehensive Git and GitHub tutorial here at YouTube. This tutorial has more than 10 hours of content, and I'll explain you everything you need to know about Git and GitHub. But most importantly, I'll explain you how Git works under the hood, and you'll learn what is blob, tree, and how to use such low-level commands as git hash object, git cut file, and git mk3. Well, who am I? My name is Bogdan Stasiuk and I am software developer with multiple years of experience, and I use Git on a day-by-day basis at work. I have also more than 15 years of teaching experience and I really love to teach. And I would be more than happy to transfer all my knowledge about Git and GitHub to you. This course also includes tons of practice activities and you will be able to follow me along from beginning till end. This tutorial is part of my large course called Complete Git and GitHub Guide. In the description under this video you'll find a link to this course. Also in the description I have included all timestamps for all sections and lessons in this large tutorial. Let's get right into it, and don't forget to smash a like button, to share this video and to leave a comment if you have something to say. Let's get right into it. Hi. Welcome to the introduction section of the Complete Git and GitHub course. In this short section, I'll explain you what is Git, why it is so useful, and what is the difference between Git and GitHub. But what is actually Git? Let me tell you a story. When I was a student, I was very often working on text documents in Microsoft Word. And sometimes I wanted to save all historical versions of the same document. And for that I have simply renamed the file and added suffixes like version 1, version 2 and so on. And using those different versions of the file, I was able to get back to specific version and, let's say, travel in time. With Git you don't need to care about that. Git takes care about it itself. It stores all historical versions of every file, and you are able to get back to specific version pretty easily and fast. That's why Git is very popular in developer community, and in every development project, independent of programming language you use, you usually create multiple folders and multiple files. And Git allows you pretty easily and actually automated track all versions of every file in your project. Okay, let's talk about Git in more details and let's compare Git and GitHub. Hi, I would like to start this course by explaining difference between Git and GitHub. Many people, especially beginners, may think that Git and GitHub represent same thing. But in fact, Git and GitHub are two completely different things. Let me quickly explain what is Git and what is GitHub and how they are actually related. Most popular definition of Git is following. Git is distributed version control system. But this definition is actually too complicated, especially for beginners. Let me explain you what is Git in more simple words. Git allows you to track files in any folder called repository. And Git preserves history of all changes that you make with files in this repository. But how Git does that? How it stores all changes of all files in the folder? Under the hood, Git has its own, let's say, file structure. And every file is stored in a separate document. And every file has special hash. And that's why we can say that Git is simply persistent hash map. And it stores keys and values, nothing else. Key is a hash and value is content of every file. And in the first part of the course, I will be primarily focused on internals of Git. I want to make you fully understand how Git works under the hood. And if you will understand it, you will be able much more easier use Git and Git commands. Another important notice regarding Git. You can use it locally on your computer even without internet. And locally, you will have full access to entire history of all changes that you made in your repository. Git doesn't depend on internet connection. It stores all data locally on your computer. And that is a great benefit of Git. But why is it called distributed version control system? That's because you may collaborate with other people and work on the same project. And that's where GitHub comes in. GitHub helps to manage your Git repositories. And usually GitHub is used when different people work on the same project. But of course, you may use GitHub even if you don't have any other collaborators. You may simply use GitHub as a backup service for your repositories. And even if you will delete your local repository, remote repository at GitHub will still be available, and you will be able anytime download your remote repositories from GitHub again locally to your computer and continue working on them. But of course, distributed teams of people that want to work on the same projects will benefit from GitHub the most. Okay, let's quickly summarize. Git is distributed version control system. If you want to use Git, you must install it on your local computer. And after installation of Git, you can start tracking any changes in any of your folders on your local computer. And again, for that you don't require any internet connection. And under the hood, Git in fact is special file system that allows you to store changes that you make in any folder. Git is very simple under the hood, and in the next sections I'll explain it to you. GitHub is a repository hosting service, and it allows you to create remote copies of your local Git repositories. And more than that, it allows other people to collaborate on your repositories, download them, change, and so on. Of course, GitHub has many other features. For example, with GitHub, you are able to create website with hosting with a domain. It will be subdomain of github.io, and you will also get free SSL encryption. That is a GitHub. Okay, now when you understand difference between Git and GitHub, we are ready to move on and install Git on your computer. Git is available for different operating systems, for macOS, Windows, and Linux Unix. And in the next lectures, I'll guide you through the process of Git setup for different platforms. And after that, we will dive deeper into the Git and I'll explain you how it works under the hood. I'll see you in the next lectures. Bye bye. Hey, did you see my new YouTube video about Git? What? This piece of what? You didn't like it? What? Hi, in this section we will start by installation of Git, and if you have Git already installed on your computer, you can simply skip it and move on to the next one. But please note that for Windows you need to use Git Bash, that is actually Unix-like emulator where you will use same commands as I will do during the course. And for Mac users I recommend to install Z Shell and iTerm2. I'll use them during this course and they actually simplify process of working with Git. Okay, let's get started and let's talk about installation of Git in this section. See you! In this lecture, I'll show you how to set up Git on macOS. And you should navigate to this website, git-scm.com, and go here to Download section. And click here on macOS. Your download should start automatically. If it doesn't start, you can click here on this link. Wait several seconds and your download should be started. Okay, let's wait until it will be completed. Installation file was downloaded, let's open it up. Let's double click on pkg file. Now I need to modify my security settings, go to Settings, System Preferences, security and privacy here, and open anyway button here. Open. Close this window and go back to installation. Click here continue, click install, type my password, install software, and installation was successful. Let's close this window, move to trash installer, and now I can open terminal and verify whether Git was installed or not. I can open up terminal here, type terminal, enter, and I can verify whether Git was installed or not by entering command git version. And I got result git version 2.22.0, and it means that Git was installed correctly. What this version actually means? 2 here means that it is a major version number 2, then after dot comes minor version 22, and after second dot comes patch version, it is 0. Of course, in your case, this version may be higher than mine, but it's not a problem. In this course, we will be focused on core features of Git, and all of them will be available in all next versions. Okay, that's all for installation of Git on a Mac, and next let's install Git on Windows. I'll see you next. Bye bye. Are you already a subscriber? If no, please subscribe. I publish a lot of tutorials like this one. In this lecture, I'll show you how to install Git on Windows. You should also navigate to git-scm.com and go here to download section. In my case, I see that the latest source release version is 2.22.0. In your case, it may be higher. Let's click here on Windows and the download of installer will be started automatically. In my case, 64-bit version will be downloaded, but you may notice here that you are able to download 32-bit version. Also below you will find links to portable versions of Git, also either 32 or 64-bit versions. Okay, file was downloaded and now we can click on it and start installation process. Let's click yes here. Here is license, Git is free. Let's click next. Click next again. And here you'll see list of installation options. Let's leave all of them unchanged. Important notice here. Git installation for Windows comes with Git Bash. Git Bash is a separate application that allows you to use Unix-like commands on Windows. Also, it has pretty nice color theme out of the box, and for example, you will be able to see in which Git branch you are currently in. You should use Git Bash instead of built-in Windows terminal. Okay, let's click next. Select Start Menu folder, let's click next again. And here you may choose which editor will be used by default for Git projects. Here you see that Vim is chosen as default Git's editor, but I suggest you to use Visual Studio Code. That is editor that I will use through entire course. That's why let's choose here Use Visual Studio Code in the drop-down list. But after choosing this option, we won't be able to proceed until we will install Visual Studio Code. If it is not yet installed on your computer, please install it now. In order to install Visual Studio Code, let's click on this link. And here, let's click Download for Windows. No worries, Visual Studio Code is completely free. Okay, installer was downloaded, let's open it up. Click here Next. I accept agreement. Again Next. Next is default path. Name of application Next. Here let me check checkbox register code as default editor for supported file types. And click Install. Installation will start. Let's wait a bit. Okay, installation was completed, but for now I don't want to launch Visual Studio Code, so let's uncheck this checkbox and click Finish. Okay, VS Code was installed. Let's close this tab. Now let's go back to installation of Git and again choose Visual Studio Code, and it seems that I should click here Back button and click Next again. And here you see that VS Code is still chosen as default editor and Next button is active. Let's click on it, and here you see several options related to path environment. And default option is this one. If you choose this option, you will be able to use Git either in standard command prompt on Windows that utilizes PowerShell, or you will be able to use Git in third-party applications like Git Bash. And I have told you before that Git Bash is included in this package. There is also an option to use Git from Git Bash only, and for that your path will not be modified at all. There is also last option that will also install some optional Unix tools, but it will alter behavior of built-in Windows tools like find or sort. That's why let's leave second option selected and click Next. Here you should choose which SSL TLS library you would like to use with Git for HTTPS connections. And the default option is OpenSSL library. If you'll choose second option, native Windows Secure Channel library will be used. Let's go on with OpenSSL library. Click Next, and here you should choose how Git will treat line endings in text files. And I recommend you to leave first option unchanged, and in this case you'll check out Windows style line endings but commit Unix style line endings. This option is the best for cross-platform projects where different developers use different operating systems. Let's click Next, and here you can choose which terminal emulator will be used with Git Bash. And there are two options, either MinTTI or Windows default console window. It is actually CMD application, but it is not convenient for use. That's why by default MinTTI option is chosen, and I recommend you to proceed with it. MinTTI is another terminal emulator, and it has much more features than built-in Windows console. So let's click Next here. Extra options. Let's enable file system caching and enable Git credential manager. Click Next. Here we can enable experimental interactive add feature. I don't want to enable it, and let's simply click Install. Let's wait. Okay, install was completed, and here I'll uncheck View Release Notes checkbox and check Launch Git Bash. And let's click Finish. And Git Bash will be opened automatically. You see that it has different colors out of the box, and you can increase font size by pressing Ctrl and scrolling up. Let's also resize window, and let's try something here. For example, let's change directory to desktop, cd desktop. And here you see that I am located on desktop. Let's now create here a new folder using make directory command, shortly mkdir. Just type mkdir my project. And on a desktop you'll see that this folder was created. Let's go into this folder, cd my project, and you will see this change here in this path. Now let's create a file using touch command, touch and name of the file, for example file.txt. And if I'll open this folder, you'll see new file here. Let's make it larger and let's resize this window. Let's now create one more file, for example file2.txt. And you'll see this new file here as well. Now let's list files in this folder, ls-la. Again, all those commands are Unix-like commands, and normally they are not available on Windows. But I will use Mac during this course, that's why you will be able pretty easily follow me along if you are on Windows. Okay, ls-la shows you list of the files in the folder. And here you see file.txt and file2.txt. Okay, let's clear terminal using clear command. If you want to open current folder, in my case my project folder in Explorer, you can either use command start and dot, and here you will see that this folder will be opened, or you can use, let's clear terminal, you can use explorer dot command, explorer and dot. And same will happen in this case. Folder with two files will be opened. Okay, let's clear terminal. Now let's verify whether Git was installed or not. We can, for example, quickly initialize Git in this project. Git init. And you'll see that empty Git repository was initialized for this project. And if I list files in this folder now, ls-la, you'll see newly created folder .git. And that means that Git works correctly. But please notice that such folder .git isn't visible in Explorer. And that is default behavior. You're not able to view hidden folders. And all folders that start with dot are considered as hidden. Let's enable hidden folder view on Windows, and for that let's click on View here, choose here Options, and go here to View tab. And here let's select Show Hidden Files, Folders and Drives, and let's uncheck checkbox Hide Extensions for known file types. And let's click Apply and OK. And now hidden folder.git has appeared in Explorer. We can explore it, let's double click on it, and here inside you'll see a bunch of folders and files. No worries, in the next sections we will explore this folder in details. Okay, that's all for Git setup on Windows. And please note that during entire course you should use Git bash instead of built-in console emulator on Windows. Okay, let's proceed, and next I'll show you how to set up Git on Linux. I'll see you in a moment. Bye bye. Do you want more tutorials like this? If so, please subscribe and ring a bell to get them. Now I want to show you how to install Git on Linux, Unix-like operating systems, for example Ubuntu. And it's a pretty common case when you need to use Git there. For example, if you host a website and source files for this website are located at GitHub, and you need to clone a remote repository from GitHub and use it locally on your web server. And of course, for that you need to use Git. In this lecture I'll show you how to install Git, but first I'll show you how to create a new virtual private server. And for that I'll use DigitalOcean. Of course, you can spin up virtual private server on any other hosting provider, for example Amazon EC2 or Google Cloud or something else. But I'll use here DigitalOcean for simplicity. Okay, here on the same website gitscm.com, if you'll go to Downloads and click Linux Unix, you'll find instructions on how to install Git on Linux-like operating systems. And I'll install in this lecture Git on Ubuntu. For that I require Ubuntu server, and I will use the service from DigitalOcean, and here I am able to pretty fast and easy create a virtual private server with different operating systems like Ubuntu. I already have account here. If you don't, please create one. I'll click Login and log in here with my credentials. After logging into DigitalOcean, I'll see here my default project. In my case, it is called My Project. If you have just created a new account here, you'll be prompted to create new project from scratch. And project may contain droplets. Droplet is actually virtual private server. And now I'll create new droplet here. Let's click on Create button and choose here Droplets. I'll create droplet with Ubuntu operating system, and Ubuntu version will be 18.04. If I'll scroll down, I can choose a plan, and I'll choose smallest plan possible. It costs just $5 per month, and such virtual private server will have 1 gig of RAM, 25 gigs of SSD disk storage, and up to 1 terabyte of data transfer. Also, you may add some options, for example, enable backup. I will not do that. Also below you may choose data center region, and by default DigitalOcean will choose data center closest to your physical location. Also you may add such options as private networking, IPv6 and so on. Next, in the authentication section, you may choose how you will be authenticated at your server. You can use either SSH key or one-time password. I'll choose this option, one-time password, and in such case you will receive root password via email. Let me scroll down, and here you may choose how many droplets of this specific configuration will be created. I actually need only one server, one droplet, and here you may set up hostname for your new droplet. And I'll set up hostname simply Git, like that. Here you may add tags and select project where your droplet will be located. In my case, I have only one default project. And here let's finally click Create. Creation of droplet takes usually some time, up to 30 or 40 seconds, so let's wait a bit. Okay, my server was successfully created, and here you see IP address of my new server, and now I am able to connect to my server directly. Per email you should receive your root password. Let me check my email, and here I see message from DigitalOcean, and here are credentials for my new droplet. Username is root and password is here. After initial connection, you will be prompted to change this password. It is actually one-time password. You need to connect to your server via SSH. Such operating systems as MacOS or Linux have SSH built in. Windows does not, and with such applications as PuTTY, you are able to use SSH on Windows. Okay, I'll simply use terminal, and I'll open up new terminal window. And I'll use SSH, simply type SSH, then root, add, and here I need to enter IP address of my droplet. Here it is. Let me copy it and paste here. Then press enter. Here with the prompt whether I want to trust fingerprint of remote server, I'll type yes. And now I should enter password. And I need to enter this password. Let me copy it and paste here. Enter. Now, as I have told you before, I should change password for root user. I'll paste current password, one-time password, and I'll enter new password. Repeat. And here we are, I have successfully logged to console of my virtual private server. Here you can check version of operating system by typing following command: lsb release-a. Enter. And here you see that distributor ID is Ubuntu and the version is 18.04.2. And again, here you see 18 as major version, 04 is minor version, and 2 is patch version. And release is just 18.04. Now let's install Git on this server. In order to do that, let's go back to gitscm.com. And here, if you'll click on download for Linux and Unix, you'll find instructions on how to install Git on Linux-like operating systems. In our case, we use Ubuntu, and I can use this command, apt-get install git. Let's go back to terminal and type this command, apt-get install git. Enter. And it seems that this version of operating system already ships with Git pre-installed, and Git version is 2.17. Actually, let's check that. Let's clear terminal and type git version, enter, and here I'll see Git version 2.17.1. I'm not sure whether this Git version is latest stable release for Ubuntu. That's why let's quickly update list of apt packages, and after that let's try to install Git again. Let's type apt get update and wait a bit. Okay, packages were updated, let's clear terminal, and now let's try to install Git again. apt get install Git. And it seems that we have most current version for Ubuntu, and its version is now 2.17.1. Okay, I have shown you how to install Git on different operating systems like macOS, Windows and Ubuntu. You may have noticed that built-in terminal on a Mac doesn't really look good and does not offer different color options, different formatting options and so on. That's why in the next lecture I'll install custom terminal called iterm2 and custom shell. I'll see you in the next lecture. Bye. In this and in the next lecture, I'll show you how to install custom terminal on a Mac and how to install custom shell. But what is terminal and what is shell? If you use Mac, you know that there is default built-in application called terminal. And I have used it in previous lectures. Let's actually open up terminal. Okay, terminal was opened and here actually you see terminal window. And terminal is just graphical user interface. Inside of the terminal you actually use shell. And by default we use built-in shell on a Mac called bash. That's why here in the header of this window you see bash. What you can do with terminal? You can change size of the text by pressing Command plus or Command minus. But personally I like to expand the application windows to full screen. Of course I can use this arrow and make it full screen like that, but usually I like to double click on a header of application and make it full screen like that. But in case with terminal you see that it wasn't expanded to full screen and you see here this space. If I make window larger, you will see that the size of the window is adjusted as well. And that's what I don't like personally in terminal. Also you see that when font size is really large, there is no padding between letters and the upper edge of this window. Of course, there are some preferences that you can adjust. For example, you can change default font size and default font. You can do that here. Go to Terminal, Preferences, and go to Text. You can choose, for example, custom theme here. Let's choose, for example, Pro theme. And after choosing, you need to click Default button, this one. And now I need to close Terminal application and open it up again. Choose here Terminal, Enter, and here you'll see again this small window, but in other colors, because we have adjusted our color theme. We can also try to change font size and font. Let's go back to Terminal Preferences, again Text, and here default font is Monaco with size 10, and I can change font size here. Let me choose, for example, 24 instead of 10. Let me close this window and close these settings. Again, I need to restart terminal, close this window, open it up again, and now I see increased font size. But again, if I'll double click on the header, you'll see that the window itself will not be full screen, and here you see this gap. There are also other things that I personally don't like in terminal. That's why many developers choose to use another terminal application called iterm2. But please note that terminal and iterm2 are just graphical user interfaces for shell. And in order to change look of the shell itself inside of this window, we will install custom shell as well. And we will install shell called Z-shell or shortly ZH. And we will use it in iterm2 instead of built-in bash shell. Okay, let's close this terminal window and go to web browser. And let's start by installing iterm2. And after that, we will install custom shell called zshell, or shortly zh. In a web browser, please navigate to iterm2.com. Of course, if you use Mac, same as I do. And here you'll see download page for iterm2 application. iterm2 is actually terminal emulator. It is replacement for built-in terminal on a Mac. Here below you'll find download link. Let's click on it. Let's unzip downloaded archive, and here you'll see iterm.app file. And I'll simply drag it to my applications like that. And now I'm able to open it up. And here in a spotlight, just type iterm and select application from applications folder, this one. Enter. And new terminal window was opened. I can make it full screen by double-clicking here on a header, and I can increase font size by pressing Command and plus, like that. And notice that in a header you see bash, and that means that inside of this terminal window, bash shell was automatically opened, and bash is built-in default shell on a Mac. And now it's time to install custom shell called zh, and we will run this custom shell inside of the iterm2 application. Let's install zh in the next lecture. I'll see you in a moment. Bye-bye. In the previous lecture, we have successfully installed iterm2. iterm2 is a terminal emulator, and inside of the terminal emulator, we run shell. And by default, we run bash shell, that is a built-in shell on a Mac. Now it's time to install custom shell that will give us much more features than built-in bash shell. Let's go back to web browser, and here in the search bar, let's type simply zh, like that. And let's open up this first link and second link. Installing zh and oh my zh. Let me open up this tab, and here you'll see information about oh my zh. So what is oh my zh and what is zh? zh, as I have told you before, is custom shell. And oh my zh is a framework for management of zh configuration. And with oh my zh you will be able to get such amazing look of zh shell, like you see here on those screenshots. That's why first we need to install zh, and after that we will install oh my zh on top of that. And after that we will try to use zh with custom configuration inside of the iterm2 application here. Okay, let's start by installing zh. You can install zh on different platforms. I use Mac, that's why I can use, for example, Brew Package Manager in order to install zh. I need to install zh and zh completions packages. Let me copy this command and go to terminal. I can already use iterm2 with built-in bash shell. Let me paste this command here and press enter. And installation process of zh will be started. Let's wait a bit. Okay, it seems that zh was successfully installed. Let's get back to the guide here. And now I need to change my default shell to zh. And for that I can use this command, change shell -s bin zh. I can copy this command here and paste here. Let me actually first clear terminal, clear, and paste copied command. Enter, enter my password. And my default shell was successfully changed to zh. And now we need to install oh my zh. That is a framework for management of zh configuration. Please go to ohmyzh.sh, and in order to install it, we could use this command below. And I'll copy this part without dollar and go to terminal back. Let's clear it first and paste copied command, this one. Press enter. And after entering this command, omizh will be installed on your computer. And under the hood, we actually will clone remote repository from GitHub, and we will clone it to new folder called .omizh, and it will be located in your user folder. And after cloning remote repository to our local folder, zhconfig will be replaced with omizh template file. And here you see that zhconfig will be found, and it will be backed up and renamed to this file, and new config zhrc will be created instead. And now you see prompt to change our default shell to zh. Actually, we have already changed it before manually, but to be sure, let me type here yes and press enter. Changing shell, and let me type here my password. And if I'll clear terminal now, you see that we are located in brand new shell, zh shell, instead of built-in bash shell. And this command prompt was changed as well. For example, let's try changing directory to desktop, cd desktop, enter. Let's create new folder, mkdir new folder, like that, enter. And let's cd to this new folder, cd new folder, enter. And now we are in new folder. We can print current directory using command pwd, enter, and you'll see that I am located in users Bogdan desktop new folder. Okay, we are all set. We have installed custom terminal application iterm2, we have installed custom shell zh, and we have installed configuration framework for zh called omizh. Now we are all set and we are ready to move on. In the next lecture, I'll show you basic shell commands that I'll use during this course. And if you're not familiar with shell, please don't skip next lecture. I'll see you in a moment. Bye-bye. Are you still here, enjoying this tutorial? Then smash a like button and leave a comment. And don't forget to share this video with your friends and coworkers. Let's go on. Now you should have Git installed on your computer. And in this section I'll tell you about basic shell commands. And you'll learn how to create files, how to edit files, how to list files and so on. Some basic management stuff. If you know all of that, feel free to skip to next section. If not, please dive in. You can actually manage Git using either shell or any graphical user interfaces that support Git, like GitHub Desktop or Source Tree. We will use them as well in this course, but the best way to start learning Git is by using shell. So let's talk about basic shell management commands in this section. In this and in the next lecture, I would like to show you most popular shell commands that you and I will use during this course. If you're not familiar with shell, please follow me along and please try to remember those commands. There are not many of them. If you are familiar with such commands as ls, cd, nano, clear, echo and man, you can skip those lectures and move on to next section. For those that are not familiar with those commands, let's start with commands that allow you to list files and directories, change directories, make directories and so on. And for that, on Mac I will use iterm application, and recap that in the previous lectures I have installed zh shell. It is a custom shell, and this custom shell zh or zshell has replaced built-in default bash shell. On Windows you should use git bash that was installed during installation of Git. Okay, let's start by reviewing those commands here in this list. mkdir will create new directory. ls or list will list files and directories in a specific folder where you are currently in. cd will change your current directory or folder. Dot is an alias of current directory, and two dots represent parent directory. And for example, using cd and two dots, you can move to parent directory. There is also one command that is missing here in this list, and this command is pwd. And with this command, you'll find out current directory. And let's start with this command. You should open new terminal window. On a Mac, I'll use again iterm2. On Windows, you should use git bash. And here you can find out which directory you are currently in by typing command pwd and press enter. And here you see that I am located in directory users/Bogdan. It is my user directory, and now I can list files and folders in this directory. Let me first actually clear terminal, clear, and list files, ls. Enter, and here you'll see bunch of folders actually. I can also use another option that will list files and directories in table format. I can use option L and just type ls-l. Press enter, and here you'll see folders in table format. Here you see owner of directory, here is a group of users, stuff, here is size and date, and here is name of directory. Here at the beginning of each line you see permissions for each directory. Also you can add another option, A, and list files in following way, ls-la. Enter, and now you see much more files, and with A option you'll also see hidden folders and files. Hidden folders and files start usually with dot. And without option A, you will not see those hidden folders and files. Here above, we didn't see those hidden folders and files. For example, we see here such a file as .dsstore. It is system file on a Mac. Also, you see here trash folder, again it is hidden folder, and so on. Your list of files, of course, will be different from my list. Notice that here in your root directory you see file called omyzh, and this file is actually configuration of omyzh. Also, you see such a file as .ssh, .vscode, and so on. Okay. That is my root directory where my root folders and files are located. Let me clear terminal, and now let's try to change directory to another. And let's change directory to desktop. And for that we can simply type cd and desktop with capital D. Enter, and now I am located on desktop. I can print current directory by using command pwd again, enter, and now path is here, and I am located on desktop. On the desktop I don't have any files at the moment, that's why if I list files here, ls-la, enter, I will not see any folders and files except two system files that are actually hidden. Now let's create new directory here on desktop. And for that I can use command mkdir. mkdir, make directory, and here let's type name of new folder, and let's name it new-folder. Enter. And now let's list files here again, ls-la. Enter, and here you'll see brand new folder. We can change directory to this folder, cd new-folder, enter, and now I am located in new folder. Let's again print current directory, pwd, enter, and now you see that my path is here. I am located now in new folder. And in this folder I can also create new folders, new files, and so on. Let's now try to get back to desktop. And for that I can use alias. Recap that alias for parent directory is 2 dots. And I can simply type cd and 2 dots. Enter. And now my current directory is again desktop, pwd, and here you see this path. Okay, let's go back again to new folder, cd new folder. Enter. And now let's simply type cd without anything, just cd, and press enter. And now with cd I have moved to my root folder, pwd, and here you'll see my root folder. So just cd without any options will move you to your root folder. Now let's clear terminal and get back to desktop. Cd desktop. Enter. And if I'll type cd and dot and press enter, nothing will happen. I will still remain in desktop directory, because dot represents current folder, current directory. But I can use, for example, open command. On Windows, you should use either explorer command or start command. Let me type open and dot. Enter. And this will open current directory in default application. And default application for opening folders is actually Finder on the Mac. On Windows, it will be Explorer. Same we can do, for example, in new folder. Let's get back to terminal and change directory to new folder. Like that. Enter. And type open and dot here. Enter. And now contents of new folder will be opened. That's how you can very fast open contents of any folder. Same commands open on Mac or Explorer or Start on Windows you can use to open any files. There is one more thing left that I wanted to show you here in this lecture, and for that let's change directory to our root directory, cd, enter, and here we can use cd with long path. What I mean? I can type cd desktop / new folder, enter, and I will immediately go into new folder located on desktop. It means that with cd you can use any path you want, and if this path exists in current directory, you will be moved to new directory according to this path. Okay, let's summarize. In this lecture we have talked about such commands as mkdir, ls with options L and A. Option L will list files in table format, and option A will show hidden files and folders. Cd command is used for directory change, and cd without any options will change directory to root directory. In my case, it is users/Bogdan. cd pwd users/Bogdan. And dot is alias of current directory, and two dots is alias of parent directory. Okay, that's all for directory management, and in the next lecture let's talk about other commands that are also very useful, and those commands I also recommend you to remember and use. I'll see you in the next lecture. Bye. Are you still watching? If so, please leave a like, make me happy. If you don't like video, also leave a like. Let's go on talking about shell commands. In the previous lecture, we have talked about directory management commands like mkdir, ls, and cd. You also know that dot represents current directory and two dots is an alias of parent directory. And in this lecture, let's proceed and talk about other commands. And we will talk primarily about file management commands that are listed here and here on this list. With touch command, you can create new file. With cut command, you can list contents of the file. This greater than sign is used to write contents to the file. Two such signs are used to append contents to the file that already exists. You can also edit any file, and for that you can use any editor. And I usually use Nano editor. There are also other editors like Vim and so on. But Nano is most convenient for use, and I recommend you to use it as well. Of course, you can use any other graphical user interface editor like VS Code, Atom, or something else. But Nano is actually editor that is used inside of the shell, and you don't need to open any other application for that. Clear command is already familiar to you, and this command clears current terminal. Tab, it is not actually a command, it is a button on keyboard, and pressing this button you can autocomplete any command. And if there is only single option, then tab will autocomplete current command. But if there are multiple options, you can press tab twice and you'll see all options available. Echo will print something to terminal, and man is used to get help on specific command. And let's actually start by using man command. Let's go back to terminal and let's actually clear it first. Clear, enter, and let's get help, for example, on command clear. Man clear, enter, and here you'll see description of clear command. Clear command clears terminal screen. Here description. Here you also see suggestions of other commands like tput and term info, and that's all. This command is very simple and it doesn't have any options. In order to close this view, I can press key combination Ctrl Z, and I'll get back to terminal. Okay, that is help on clear command. Let's clear terminal and let's get help on another command, for example, touch command. Recap that this command is used for creation of new file. Let's press enter, and here you'll see description of touch command. With this command, you can not just create new file, you can also change, for example, file permissions. And here you'll find entire description of this command, including different options like -f, -h, -m, and so on. This description is much larger than description for clear command. Okay, let's go out of this, Ctrl Z, and now let's actually try to use touch command and let's create new file. And let's create it in new folder that we have created on desktop. For that, let's change directory to new folder located on desktop. cd, desktop, and here let me show you how tab works. Now, after typing just 3 letters, let me press tab. Tab, and here you'll see that terminal has auto-completed this word, desktop. Here I can also try to press tab. Tab, and here you'll see that new folder was appeared. That's because there is only one folder on desktop. If I had more than one folder, then tab will not work and I will need to press tab twice in order to get list of all folders and files on desktop. Let's actually try that. Let me go to desktop, like so. And let me create new folder here. mkdir, another folder. Enter. Now let's list files here, ls-la, enter. And here we see 2 folders, another folder and new folder. Let's get back to root, cd, enter. And now let's try to change directory using auto-completion. Let's type simply cd and capital D. And now let's press tab. Tab. And here you'll see all folders that start with D. Let's type E and let's press tab again. Tab. And now auto-completion has added desktop. That's because now there is only single option that starts with DE. Okay, let's try to press tab now. Tab. And here we see another 2 options. Another folder and new folder. And if I'll type simply A and press tab, then name of the folder will be auto-completed to another folder. That's because there is only single folder that starts with A. Okay, we wanted to go actually to new folder. Let's type here N and press tab and press enter. Now we are located in new folder. Let's clear terminal here and let's create new file. Let's use touch command for that. Touch, and here we need to type name of new file. New file.txt. txt will be extension of this file. Enter, and file was created. I can list contents here in this directory, ls-la, enter, and here you'll see this brand new file. Here are again permissions for this file, here is owner, here is group of users, and here is size of this file. Okay, let's now create another file, but in another way. But before doing that, let me show you how echo command works. Echo, and here let me type hello world, like that. Enter, and I'll see hello world here in a terminal. It means that echo command will output everything that I write here to terminal. Or we can direct this output to file. And for that, we can use this sign, this one. Let me go to this slide here. And if I'll use this sign after echo command, then I could write something to the file. Let's check this out. Let's write again echo command. I can actually use history, and for that I can use up arrow like that. And here you'll see all commands that you have used before. And I want to use echo command, and here I'll use greater than sign, and here I'll write name of the file. Another file.txt. Enter. And now I didn't see anything here in terminal, and it means that result of this command was printed to another file.txt. And now it's a good time to list files again, ls-la, enter, and here you see two files, new file.txt and another file.txt. And here you see that this file is not empty. That's because we have written this string to this file. And now we can actually try to read this file. And for that we can use cut command. Cut and type name of the file. Another file.txt. Actually, I can use auto-completion here as well. For example, I can type just beginning of the file, just A, and press tab. And here you'll see that name of the file will be auto-completed. Cut another file.txt. Enter, and here you'll see contents of the file. In the same way, we can read contents of new file. Cut, again use tab, enter, and here I'll see nothing because new file.txt is actually empty. Let's make a quick break now and go on after small pause. Still watching? Please leave a like and don't forget to subscribe and leave a comment. Now let's try to append something to this file, another file. Let me actually clear terminal and type echo, another line, and here I'll use two greater than signs, and here write name of the file, another file. And I have used tab for auto-completion again. Let's press enter, list files again, ls-la, and now you see that the size of another file.txt was increased and now it is 26. Before it was 13. Let's now again use cut command, cut another file, enter, and now you see that this file contains two lines, hello world and another line. Okay, let's go back to list of commands, and we have explored all those commands. We have explored commands clear, echo, man, and one command left, it's nano. And nano is editor for editing files. Let's try to use it here in a terminal. Let's clear terminal and type nano. Let's try actually read description of this command first. Man nano, enter. And here you'll see that nano is another editor. And it has bunch of options that are listed here below. Okay, let's close this help, Ctrl Z, and let's clear terminal. Okay. Now let's try to edit a new file. Let's actually list files again, ls-la. Notice that I always use LA options, and I recommend you to use them as well, because in table format it's much more easier to read information, and with A options recap we can also see hidden files and folders. Okay, now let's try to edit new file.txt, and for that let's use nano editor. Let's type nano. And let's type name of the file. Enter. And here you can add any lines to this file. Let's add, for example, line, this file was just edited. And now we can write changes using key combination Ctrl-O, or we can exit from editing, and if you'll exit editing, you'll be asked whether you want to save changes or not. And I prefer to save changes first, Ctrl-O. And here I just need to press enter, changes were written, and now I can exit from editing, Ctrl-X. And let's list files now, ls-la, and now you see that new file.txt is not empty anymore. Here you see size. Here is previous size. Let's look at contents of this file. Cut new file.txt, enter, and here you see contents of this file. This file was just edited. In the same way, we can change actually any file. For example, let's change another file.txt. Nano, another file.txt. Again, I use tab whenever possible, enter, and here we can add new line here, ending line. Let's write changes, Ctrl-O, enter, and exit from editing. Let's list contents of another file, enter, and here you see this ending line. Let's edit file again, nano another file.txt, enter, and here I'll add one more line. And now let's try to use Ctrl-X without using Ctrl-O. Ctrl-X. Now I'm asked whether I want to save changes, and I need to type Y key if I want to save changes, Y. And here I need to press enter, it's name of the file. Changes were written and file was closed. I can use again cut command, enter, and here you see this one more line. Okay, that's all for file management, and let's quickly summarize. In this lecture, we have talked about such commands as touch. With touch command, you can create new file. Also, I have shown you how to use echo command plus greater than sign. With this combination, you can also write data to the file. With those two greater than signs, you can append data to the file. With cut command, you can list contents of any file. And Nano is actually one of editors that is very convenient for use, and I recommend you to use it as well for editing of files. Of course, you could use it only if edits are relatively simple. If edits are larger, then I suggest you to use more complicated editors like Visual Studio Code or Atom or something else. I have actually forgotten to show you how to delete files, and for that you should use rm command, stands for remove. Let me actually add this command here. rm, remove, and it stands for removing files and folders. Remove files and directories. And let's get back to terminal and I'll show you how to remove files. I am still in new folder and recap that there are two files, ls-la. And let's remove new file. rm, new, tab, autocompletion, enter, and this file was removed. ls-la, and here I don't see this file anymore. Let me show you how to remove folders with files. For that, let me change directory to parent, cd two dots. Now I am located on desktop, ls-la, and here are two folders, another folder and new folder. And let's suppose that I want to remove new folder together with all files in it. If I'll try to use rm command, rm, new folder, and press enter, you'll see warning that new folder is a directory and command didn't work. If I list files again, you'll see that new folder is still here. If you want to remove a directory, you should use options of rm command, rm-rf, and here type name of the folder, new folder. Enter, and now I don't see any warnings, and if I list files again, ls-la, I will not see new folder anymore. In the same way, let's delete another folder, rm-rf, another folder. Enter, and folder was deleted, ls-la, I don't see any folders here on desktop. And small task for you. Please use man command and read about those two options, R and F. Okay, let's get back to summary. Also, you know that clear command will clear current terminal window, tab is used for auto-completion, echo will print any text to terminal, or you can combine echo with greater than sign to write contents to the file. Also, man command is useful when you want to read more about any specific command. For example, you have forgotten any options or don't want which option you should use and so on. With man, you can easily get access to help on any command. Okay, that's all for this lecture, and I recommend you to spend some time and practice on your own. Please create new directories, list files there, create new files, edit those files, and so on. Please become familiar with all those commands because they are most popular and we will use them very often during this course. Okay, that's all for this section, and in the next one, let's finally start exploring Git, and we will start by exploring its internals, how Git works. I'll see you in the next section. Bye bye. This section is the most important section in entire course, so please don't skip it. Even if you know Git for years and know all its commands, please watch this section from beginning till end. Here I'll explain you how Git works under the hood and how it performs its operations. And we will use some low-level commands like git mk3, git hash object and git cut file. I am sure that most of you never used those commands. Also, you'll understand which types of objects Git stores in Git repository. There are actually 4 types: blobs, trees, commits and annotated tags. Okay, let's dive in, and I really hope that after this section you'll understand Git much better and Git will become easy for you. In this section we will be primarily focused on how Git works instead of how to use Git. But for explaining you how Git works under the hood, we need to initialize at least our first repository. And for initializing of Git repository, you should use git init command. Of course, you should enter this command while you are already in new folder or existing folder where you want to create new repository. And for that, you should first use cd command, or if directory is absent, you should first create it using mkdir command, and after that cd to newly created directory. And only when you are already in required directory, you could use git init command. And this command will actually create new empty Git repository. And after creation of new Git repository, you will be able to add new files to it. But how it actually works? What allows you to add files to Git repository? Under the hood, this command git init will create new hidden folder called .git. And in this lecture, let's initialize new Git repository and explore contents of .git folder. Let's get started. Let's go to terminal and let me change directory to desktop, cd desktop. And on desktop, I'll create new folder, and let's name it first project, mkdir first-project. Enter. This directory was created, ls-la, here it is. And now, in order to initialize first project with Git, I need to cd to first project directory first, enter. And now I can enter git init command, enter. And here you'll see message that the new empty Git repository was initialized in this folder. And notice here .git folder, subfolder of first project folder. And if I list files now in this folder, ls-la, enter, you'll see this hidden folder, .git. Please notice that without a option, you will not see this hidden folder on a list. If I list files like that, ls-l, enter, I will not see anything here in that folder. Okay, you also may have noticed that our command prompt was changed as well. And this section was added here, git : and here master. Git word indicates that this directory is under Git control, and master is name of default branch. I will not concentrate now on branches, but please keep in mind that the default branch is called master, and after initialization of new Git repository, you will be on this branch, on master branch. If I'll open terminal, let me do it quickly. Terminal, enter, And if I'll change directory to this newly created folder, cd desktop slash first project, enter, I will not see this prompt here. That is the difference between built-in terminal with bash shell and iterm with ZA shell. Here in command prompt you see that repository is managed by Git, and also you see current branch. Okay, we have successfully initialized the new repository with Git. And now it's time to explore contents of this .git folder that is hidden. And let's talk about contents of this folder after the small pause. I'll see you in a moment. Bye.
Hey, I want to buy YouTube likes. How much it costs? $5 per 20 likes? No, I don't have enough money for that, sorry.
In the previous lecture, I have created a new project called the first project. It is actually a new directory, and I have initialized this project with Git. And now if I list files in this folder, ls-la, I'll see only one hidden folder, .git, and no other files. That's because first project directory is actually empty at the moment. Okay, now let's try to examine contents of .git folder. And for that, let's open up this folder in Finder in my case. On Windows it will be Explorer. Let's just type open and dot. On Windows please type either explorer dot or start dot. Enter, and this folder will be opened in Finder. But by default I will not see any hidden folders or files. In order to show them, I need to press key combination Command Shift and dot. Press, and here this hidden folder has appeared. Let me change here view like that and increase size of this view. Okay, here is hidden .git folder, and this folder is completely managed by Git. And please never make any changes in this hidden folder. It must be managed only by Git. Okay, let's go into this folder, double click, and here you'll see a bunch of other folders and several files. I will not describe in details contents of each folder, but you can see that, for example, branches folder is empty at the moment. Objects folder contains two other folders, info and pack, and they are empty as well. Let's have a look at contents of those files, config, description and head. And we can read those files directly from terminal. Let's go back to terminal and let's first change directory to .git, cd.git. Don't forget to put a dot in front of the git because it is a hidden folder and we need to type it as here. Enter. Now we are in .git folder and here we can read any of those files. We can use cat command for that, cat config, enter, and here you'll see contents of config file. It is a configuration of your Git repository, and here you'll see some default settings. Okay, let's have a look at description file, cat description. Notice that I can also use tab here. Enter, and here you'll see description of your repository. Unnamed repository, edit this file description to name the repository. And let's finally have a look at head file, cat head, all capital letters, enter, and here you'll see only a single line of text, refs/heads/master. I will not explain what this line of code means, but in this section you will fully understand what it means and how it works. Okay, before I have told you that Git has own file system. And now it's a good time to start talking about this file system and about structure of Git documents. In its file system, Git stores objects, and all objects are stored in this folder, objects. And here at the moment there are no objects, because we have just initialized our new repository. There are several types of objects that Git can store. And let's talk about types of objects next. I'll see you in a moment. Bye. In the previous lecture, we have explored hidden.git folder, and it is highly not recommended to make any changes in this folder manually. I have also told you that Git has its own file system and it stores its own objects. And there are several types of objects that Git can store. Let's discuss Git object types now. There are 4 object types in Git, and they are called blob, tree, commit, and annotated tag. And those 4 object types allow Git to store all necessary data required for file tracking, for tracking of changes of files, and so on. So what those object types represent? Let's make a short overview. In blob object types, Git stores files. Any files with any extensions, either video files or pictures or text files, any files of any types are stored as blobs. Next, tree. With help of tree object type, Git actually stores information about directories. And the same as in any other file system, directory may be empty or contain files or contain other directories or have mix of files and directories. Same here. Tree in Git may be set of blobs or set of blobs and other trees. Again, tree is representation of folder or directory in Git. Next object type is commit. And with help of commit object type, we are able actually store different, let's say, versions of our project. And last object type is annotated tag. Annotated tag is actually persistent text pointer to specific commit. In this section, we will not talk about commits and annotated tags, but we will talk about blobs and trees. Recap that blob represents single file in a Git file system, and tree represents directory or folder. And for management of blobs and trees, we will use so-called low-level Git commands, like git hash object and git cut file. With help of git hash object command, we will be able to create new object in Git structure. With help of git cut file command, we will be able to read Git objects. Okay, let's go on, and in the next lecture, let's create very first blob in our new Git project. I'll see you in a moment. Bye. We have just talked about 4 different object types in Git. And now it's time to create the very first object in our Git repository. And we will create blob. Recap that blob represents single file in Git structure. And for creation of new blob, we will use one of low-level commands, git hash object. With help of this command, you are able to create new Git object and write it into Git repository. After creation of Git object, we will be able to read information about it and its contents using git cut file command. Also in this section, we will use another low-level command, git mk3. And with this command, we will be able to create new tree object. Here we will create new blob object, and with git mk3 we will be able to create new tree object. Okay, let's start by creating new hash object. But you may ask me, why this command named in such strange way, hash object? Why here we see word hash? I'll give you answer to this question in the next lecture. Now let's use this command. Let's go to shell and here ensure that you are located in your first project folder. Recap that there is only single folder .git and we have not created any files in this folder. If I'll open this folder, open and dot, I will see only single hidden folder, no custom files or other folders. Okay, that is our starting point here. Now let's do following. Let's use echo command and print to the console following line: hello, Git. And let's press enter. And now I'll see hello Git here in a terminal. Now let's do following. We will direct output of this command, this output is hello Git, to another Git command, namely git hash object. And based on this input, we will create new Git object. Let's do that. We can press up arrow to get back to previous command, this one, then space and pipe. This key is located near delete key. Then again space and type here git space hash dash object, and here I need to add option dash dash std in. And this option will mean that git hash object command will take its input from standard input. And pipe here means that result of this operation will be sent as standard input to this next command. Okay, let's now press enter and see what will happen. Enter, and I get strange sequence of characters. And if you have entered this string same as I did, you should get same result here. Actually, you can omit those quotes here and type like that. Let me remove those quotes here. I have just moved to beginning of the line by pressing key combination Ctrl-A. Let's press enter, and now I'll get same result. Also, you can use single quotes here instead of double quotes, like that. Single quote here and single quote here. Enter, and result will be again the same. Echo command will treat all those variations as string. Okay, we have got strange result here in the terminal. But let's examine our Git directory and let's verify whether something has changed there. Let's open up folder, open dot, and let's go into Git folder and let's open up objects folder. And here we still see default folders info and pack, and those folders are empty. Okay, let's now do following. Let's execute same command as before. Let's choose this one, and let's add one more option here, -w. And let's execute this command now. Enter. I see same result as before, this line. But if I'll open contents of the folder now, let's go into Git, go to objects, I'll see new folder called B7. And notice that the first two letters in this folder matches first two characters in this string, B7. Strange or not? Let's go back to this folder and let's open it up. And here inside I'll see one file with strange name. And notice that name of this file ends with 5e. And here you see same ending, 5e. And this file starts with AE. And AE are third and fourth characters in this string. What all of this means? It means that Git has added object into its file structure. Here we see this object. And Git has created for this object new folder with name B7. And if you will concatenate name of the folder B7 and name of this file, you'll get this string. And this string is hash of this string. And now it's time to answer the question, what is hash and how Git stores objects in its internal objects folder. Let's discuss what is hash and how it is generated in the next lecture. But before going on, let me show you one important thing. Let me list files in our project, first project, ls-la. And here we still see only .git folder. No files were created in our first project folder. This file was created only in the objects folder in a .git folder. Okay, let's talk about hash in the next lecture. I'll see you in a moment. Bye.
Hey, do you remember that we have studied the university together? I have just published a great Git course. Not interested? Don't call you anymore. Okay, sorry.
In the previous lecture, we have used git hash object command, and with help of this command, we have created new Git object that was written to objects folder. And new folder inside of the objects folder was created with name b7, and new file inside of this folder was created. It means that Git creates names for folders and files inside of those folders based on hash. And hash is generated based on input. So here is input in our case. But before talking about hash, let me quickly explain you what is JSON. JSON stands for JavaScript Object Notation, and if you have some relation to programming, to any programming language, you should know this format pretty well. This format is used for data exchange between different servers. For example, you can retrieve some data via API, application programming interface, from server to web browser. Or you can send data from database in JSON format to another server, and so on. It is just format for data exchange. Here you see sample structure of JSON object. Here you see curly braces that represent starting point and ending point for this object, and object itself consists of set of key value pairs. Here you see such keys as ID, name, age, city, and hobbies. And values are different. Here you see string values, here you see number, and here you see array. But values in this case doesn't matter. What I wanted to show you here is that keys here are all distinct. It's not possible to have same keys in same JSON object. What I mean? In the same JSON object, you are not able to have two key value pairs where key is equal to name, or two key value pairs with key ID. Each key is unique across entire JSON object. And values, of course, may match. You may easily have same values in different key value pairs. That is a JSON. And the structure of Git database is pretty similar to JSON. Git also stores keys and values. And key in Git is equal to hash of each object. And if I'll get back to this folder, you'll see that this folder plus this file name is equal to hash of the file. And of course, only single file with such name can be located in folder with name b7. Same as with JSON. We couldn't have two key value pairs with same key. But I have just told you that in JSON it's possible to have same values in different key value pairs. In Git it's not possible. That's because key in Git is generated based on value. If I'll get back to terminal, you'll see that we have generated this hash based on this value. And if you have repeated those steps along with me, you got same hash here. Okay, now you know that Git database is actually set of key value pairs, similar to JSON objects. And now it's finally time to explain you what is hash and how it is generated. Let's talk about it in the next lecture. I'll see you in a bit. Bye bye. So far we have tried to use git hash object command with the -w option in order to create git object from this string and write this git object to git objects database. And here in the Finder we have discovered new folder in objects folder with name b7, and there is single file with this name inside of this folder. And hash of this string hello, git is here. And if you have repeated the same steps along with me, you should get same hash, exactly same hash as I did. It means that in Git database we store files based on their hash. First we create hash from the file contents, and after that create corresponding file in objects folder. Okay, now it's finally time to explain you what is hash function and how it works. And also I'll explain you which hash function is used by Git. Okay, let me show you first what is actually hash function. Hash function is a function that takes any variable length input and creates fixed length hash. Independent of the input, this hash length will be always fixed. For example, we can take just a short string like we did here, hello Git, and generate hash based on this string. But also we can take other file much larger than this string. We can take even, for example, video file which size is several gigabytes. We can also take, for example, photo or something else. Any file works here. And hash function will always create hash of fixed lengths. And there is very important characteristic of every hash function. If you know hash but don't know input, you are not able to create this input based on hash. And such functions are called one-way functions. We are able to create hash based on input, but we are not able to find out which input was used to create specific hash. That's why very often passwords that you are entering on any website are stored in databases as hashes. And when you enter each time your password when you are logging into any website or application, again hash is created from your password and only hashes are compared. Because hash functions will always generate same hash from the same input. That's why here, when you have entered same command as I did, you got same hash. It means that there are two important points that you should remember about hash functions. First, hash function is one-way function. Knowing hash, you are not able to get input value that was used for creation of this hash. And second characteristic is that same input will produce always same hash. Please keep this in mind because it is important in terms of Git. Okay, let's make a short break now, and in the next lecture, let's make a short overview of some hash functions. I'll see you in a moment. Bye. Now you know that hash function creates fixed length hash from variable length input. And it is a one-way function, and it always creates same hash for the same input. Let's now make a short overview of some hash functions. There are many of them, but here you see most popular. For example, MD5. This function will create a hash that is 128 bits long. And as you see here, it is the smallest size among those hash functions. Next is SHA-1, and length of the hash that is created by SHA-1 function is 160 bits. There are also other modifications of SHA algorithm like SHA-256, SHA-384 and SHA-512. And length of the hash for all those three hash functions is the same as you see in the name of the function. And the largest hash here among those functions is 512 bits. You can try to generate MD5 or SHA hash, for example, online. Let's type MD5 hash online, enter, and here is the first link, and here you can try to type any text, for example, hello world, and below you'll see MD5 hash of this string. We can also generate, for example, SHA-1 hash. Let's click on this button, and here type again hello world. And here you'll see SHA-1 hash of this string. And this SHA hash is longer than MD5 hash, because MD5 hash is 128 bits long. Also, you can try SHA-512, this one, and type again hello world. And here you'll see much longer hash that is 512 bits long. Okay, that's how MD5 hash or SHA hash can be generated. And please note that if you have repeated same steps along with me, with same string hello world, you should get exactly same hash. But again, knowing this hash, you're not able to retrieve input that was used for generation of this hash. Okay, in one of next lectures, we will also generate SHA hash using command line utility. For now, please keep in mind that there are several hash functions, and Git utilizes SHA-1 hash function. And if you look at this string, this one, it will be 160 bits long. But you may ask me the question why I am talking about bits, 160 bits length hash, but here we see actually string with letters and numbers. That's because this format is hexadecimal format. It is used for more concise representation of the hash. Let's now make a break, and in the next lecture, let's talk about SHA-1 hash in details. I'll see you in a moment. Bye. Let's now talk about SHA-1 hash function, and that is a function that is used by Git. SHA-1 algorithm creates a hash that is 160 bits long, or 40 hexadecimal characters. And here you see example of SHA-1 hash. But not all of you may know what is hexadecimal representation. Let me explain you that. In hexadecimal format, there are 16 characters, numbers from 0 to 9, and letters A, B, C, D, E, and F. In standard base 10 format, there are only 10 characters from 0 to 9. And in base 10 format, we usually represent numbers, for example, 160 or 545 or something else. In base 16 format, we use 16 characters instead of 10. And here you see example of base 16 representation or hexadecimal representation. Sometimes letters are represented as capital letters, sometimes as lowercase letters. It doesn't matter. For example, here in command line we have seen lowercase letters. And notice that here you may see only 6 letters A, B, C, D, E, and F. Okay, that is hexadecimal or base 16 format. There is also binary representation, and for example, this hexadecimal string may be represented in binary format like this. In binary format, there are only 2 characters, 0 and 1. And binary format is also called base 2 format. And that is exactly that format that is used under the hood on your computer for storage of all data. All data is converted first to binary format and after that stored on specific media, for example on your hard disk or USB stick. But here as an example, I have represented this hexadecimal string in binary format. And you see that binary format takes much more space and it's really hard to read for humans. That's why base 16 format is used, for example, for representation of hashes. And using hexadecimal format, we can very fast and easy compare 2 hashes. And we can just look at the first 2 or 3 characters and decide whether hashes are equal or not. That is hexadecimal format. And again, in this format, we can use 16 characters. Numbers from 0 to 9 and letters from A to F. Okay, let's now get back to SHA-1 hash function and let's have a look at those 2 strings. Hello, Git and hello, Git with exclamation mark. There is only single small difference in those strings. But if we will create SHA-1 hashes of those strings, we will get 2 completely different hashes. And that is one more important characteristic of every hash function. Even small change of input data will lead to creation of completely different hash. And on this diagram you see that two completely different hashes. That's why it is really hard to guess input based on hash if you don't know input. Now let's try that in action and let's generate hashes from those two strings, hello, git and hello, git with exclamation mark. We can do that online, same as we did before. Generate SHA-1 hash, enter, and first link leads us to generation of the hash. Let's enter here string hello git, and here I'll get this hash starting with 0a, and if I'll get back you'll see that this hash is here. And if I'll add exclamation mark like that, I'll see completely different hash that starts with 1d, and here you see this hash as well. Now let's try to generate SHA-1 hash using command line interface, using our terminal. Let's go back to terminal and let me open up new tab. You can open new tab by pressing key combination Command T, like that. And here let's use SHA-SUM utility. We can read about it first using man command, man, and type SHA-SUM like this, enter. And here we see that this utility SHA-SUM is used for printing or checking SHA checksums. Here you'll find some options. With help of this utility we can generate hash from any text input or from any file. Okay, let me close this help page and let's try to use SHA-SUM utility. Let me clear terminal, and here same as before we will combine two shell commands. First command will be echo, and here let's type in double quotes hello git without exclamation mark. If I'll enter this command, you'll see hello, git here in the terminal. Also you'll see that the echo command has automatically added line break after hello git. If we don't want to add hello break after the end of the text, we need to use following option -n. If I'll press enter now, you'll see this %sign, and that means that this line doesn't have line break at the end. Why I have shown you this? It is important because hashes from the strings with line break at the end and without will be completely different. Let's check this out now. And let's add pipe. I'll use first hello git without -n option, and here I'll add pipe and type simply SHA-SUM like that. And press enter. And here you'll see SHA-1 hash. You can count those characters, and if you'll count them, you'll find out that there are exactly 40 hexadecimal characters. And that means that SHA-SUM utility generates SHA-1 hash that is 160 bits long. Now let's try to do the same with -n option. Let me add this option here, -n, and press enter. And here I'll get completely different hash. And this hash was generated from this string without ending line break. And if I'll get back to our diagram, you'll see this hash here. It starts with 0a and ends with 1c. And exactly this hash we got here. Let's now try to add exclamation mark to our string. Let me go to history and add here exclamation mark. Enter. It seems that exclamation mark along with double quotes didn't work. Let me exit from here, Ctrl Z, and let me change double quotes to single quotes, like that. Let's press enter now, and here we see required hash. It starts with 1d and ends with 6-3. And if I'll go back here, you'll see same hash here. Okay, that's our hashes that were generated for those strings hello, git and hello, git with exclamation mark. And you see that those hashes are completely different. Another takeaway from this lecture is that echo command will automatically add line break at the end of the text. And if you don't want to have this automatic line break, you should use -n option. And with this option in ZH terminal, you'll see %sign That is an indicator of missing line break at the end of the text. Actually, if you'll try to open terminal, let's do that quickly. Terminal, and let's type here, let me make it larger, and let's type here same as in iterm, echo -n hello git. Enter, and here you'll see that hello, git was printed to terminal, and new command prompt was simply appended to this string. Of course, it's not readable, that's why in the H shell you'll see new command prompt, but also you'll see this %sign that means that there is no line break at the end of this text. Okay, we have tried to generate different SHA hashes from different strings, and for that we have used SHA-SUM utility. And now you know another important feature of every hash function. Even small change in input data will lead to completely different hash. And here you see that. Okay, also at the moment you know that Git uses SHA hashes as file names. And if you will combine folder name and file name, you'll get the hash of the file. And now you may ask me the question: how many different files we can store in a single Git repository using such approach, when file name is equal actually to hash of the contents of this file? Let's talk about this in the next lecture. I'll see you in a moment. Bye.
Are you enjoying this video? If so, please leave a like and share it with anyone you know.
We have talked about hashes a lot, and you know that Git uses SHA-1 hash function in order to create hashes for files. But there are two important questions. First one, how many files Git can store in the same repository? And second question is, what is the chance of producing same hash for different files? Or rephrasing this second question, what is the probability of hash collision when two different files have same hash? Answers to those questions are not straightforward, and we need to talk about combinations first. And let's first discuss how many combinations we can create if we have only two places and two characters for each place, 0 or 1. We are talking here about base 2 or binary system. And here I have listed all possible combinations of zeros and ones on two places, 0, 0, 0, 1, 1, 0 and 1, 1. And total quantity of such combinations is 2 to power of 2, that is equal to 4. Same applies if we would like to find out combinations quantity for 3 places. And here I have listed all those combinations. First one is 3 zeros, then 0, 0, 1, and so on until 3 ones. Total quantity of such combinations is 8, and that is equal to 2 to power of 3. 3 is quantity of places where we can set either 0 or 1. There are only two possible characters, 0 or 1, that's why here you see 2. And 3 places, that's why power here is 3. That is the basics. But what if we want to find out how many combinations we can create using SHA-1 hash? Let's have a look at this diagram. And here logic is the same as we have just discussed. We already know that length of SHA-1 hash is exactly 160 bits. We have talked about that here. It is usually represented as 40 hexadecimal characters, but now let's talk about binary format of the hash. On each of those 160 places could be either 0 or 1, two possible combinations. That's why if we want to find out how many combinations we can create in total, we should bring 2 to power of 160. And here is the result in traditional decimal format. And this number is really large. And that is the answer to our first question. How many files Git can store in the same repository? Answer is here. 2 to power of 160. That is the quantity of possible SHA-1 hash combinations. This number is so huge that you shouldn't worry about ability of Git to store all files in any repository. Even if you have billions of files in your repository, Git will be technically able to store them in objects folder. Okay, we have answered this first question, how many files Git can store in the same repository. And answer is here. Now it's time to answer second question. What is the chance of producing same hash for different files? Or in other words, what is the probability of hash collision? And let's try to answer this question in the next lecture. I'll see you in a bit. Bye. In the previous lecture, we have answered this question, how many files Git can store in the same repository. And answer is here, this number in decimal format, that is equal to 2 to power of 160, because 160 is length of each SHA-1 hash. Now let's answer second question, what is the chance of producing same hash for different files? And before talking about that, we need to recap dice game. I am sure that all of you have played this game in your life. And dice is actually a cube with 6 different numbers on each side. And those numbers are 1, 2, 3, 4, 5, and 6. And when you use only one dice and throw it on a table, probability of each number is 1 divided by 6. And every time when you throw the dice, for example, probability of number 5 will be 1 divided by 6. And if you use 2 dices and throw them on a table simultaneously, probability of each combination will be 1 divided by 6 multiplied by 1 divided by 6. And that is equal to 1 divided by 36. Or in decimal format, it will be 0.028. Or if we will convert it to percents, probability of each combination, for example 6 and 6, will be around 3%, or 2.8%. And that means that on average you need to throw 2 dices 33 times in order to get the same combination, for example 5-5 or 6-6 or 1-1 or something else, any combination of 2 dices. It is the basics of probability theory. Again, if you use only one dice, then probability of each number is 1 divided by 6. That is approximately 16%. But if you use 2 dices and want to find out probability, for example, of same number on 2 dices, 1-1, 2-2, 3-3 or 6-6, then you should use this formula. And probability of such combinations is around 3%. And now question to you. Here you see probability of same number on 2 dices. But what about probability of different numbers on 2 dices? For example, if we are talking about combination 4 and 5. Please try to pause video now and answer this question. Okay, let me answer this question as well. If you want to get combination 4 and 5, then you will need to multiply this probability by 2. Why? Because we don't care on which of 2 dices we want to get number 4 and on which number 5. That means that we will be satisfied with both combinations 4 here and 5 here, or 5 here and 4 here. Probability of each of those combinations is here, 0.028. And because there are 2 reverse pairs, 4, 5 and 5, 4, we should multiply this probability by 2. And probability of non-matching numbers will be around 6%. Okay, that is the basics of probability theory in dice game. Now let's try to reflect this theory on SHA-1 hashes combinations. And let's go on after the small pause. See you. In the previous lecture, we have briefly talked about probability theory in dice game. And we have found out that probability of same numbers on both dices is around 3%. Let's now answer the question, what is the probability of each SHA-1 hash? And here is the same formula that was used here. Here there are only 6 possible numbers. In SHA-1 hash there are 2 to power of 160 combinations. And this number was equal to this value, really large decimal number. And if I'll divide 1 by this really large number, I'll get this number. Here I have represented this number in scientific E format. Here at the end you see E minus 49. It is not exact number, but we can estimate how small it is. This number 49 means that if you'll add 49 zeros on the left here and move this dot 49 characters to the left, you'll get a number without this E. That is the probability of each SHA-1 hash, and this number is very, very small. 49 zeros after 0. 0.000, 49 zeros, and only after 49 zeros comes 6. That is the probability of each SHA-1 hash, and this probability is again very, very small. Now let's try to answer the question, what is the probability of producing same hash for different files? And you may guess what we should do in this case. If you look at this formula, you may understand that we should multiply two probabilities. And here is the formula that shows us probability of the same hash for different files. Here we need to multiply this number by itself. And result will be 1 divided by 2 to power of 320. 2 to power of 320 is equal to this number, and here you see again scientific representation with E, but here you see E plus 96. And that means that if you want to get rid of this E plus 96, you need to move this dot 96 characters to the right. And in such case you'll get decimal number. But of course it will not be fully exact, because all numbers after 1 will be zeros, and in scientific notation we usually calculate approximate value with several characters after dot. And if you divide 1 by this number, you'll get this number. Again, in scientific notation it is E minus 97, or 0.96 zeros, and only after that comes 4, this 4. Then after 4 comes 6, 8, and so on. And this number is much, much smaller than this number. Here we had only 49 zeros. Here we have 96 zeros. Twice more zeros than in this number. And that means that probability of same hash in SHA-1 for different files, or it is usually called SHA collision, is so small that you shouldn't even think about that. It will almost never happen in your Git repository. So please don't worry about that, and you can be sure that every file will have distinct hash, and Git will be able to store all files that you have in your repository. And that means that we have answered both those questions. How many files Git can store in the same repository? Answer is here. This number in decimal format represents quantity of files that can be stored in the same Git repository. And answer to the second question, what is the chance of producing same hash for different files, is here. So here is this chance. That is really, really, really small. Okay, sorry if this information was too complicated for you, but I have tried to clearly answer those questions in order to make you fully understand that Git is capable of storing any quantity of files you want. Okay, please keep all of that in mind, and now let's move on to next Git low-level command, namely git cut file. With this command, we are able to read contents of any Git object and read information about that object. Also, you may have noticed that when we have created SHA-1 hash from this string, we got this result. But when we used same string hello Git and created hash using git hash object command, we got completely different hash, this one. Please compare. This starts with B7 and this starts with 0A. And in the next lectures, you'll understand why those hashes differ. I'll see you in the next lecture. Bye. So far we have created a single object in a Git database using git hash object command. Also, we have discussed that every object in Git database has SHA-1 hash. In the previous lecture, we have discussed how many different SHA-1 hashes may be generated, and here is this number. And this number is equal to maximum number of files that could be stored in one Git repository. Also, we have found out what is the probability of same hash for different files. And here is this value. It is really small. And you shouldn't worry about the case when two different files will lead to creation of same hash. Now let's go on with low-level commands and let's have a look at git cut file command. This command has several options and let me briefly explain them to you. Here they are. Git cut file command requires hash, SHA-1 hash, and it has such options as -p, -s and -t. If you'll use -p option, then contents of specific object with corresponding SHA-1 hash will be printed to terminal. But of course, such object with specified hash must exist in Git repository. Next option -s will print to terminal size of the object. And with last option, this one -t, you'll get type of the object. And before we have discussed that there are 4 object types in Git: blob, tree, commit and annotated tag. And when you'll enter git cut file command with option -t, you'll get one of those values: blob, tree, commit or annotated tag. Okay, let's now try all of this in action and let's get back to terminal. Recap that there is single object in Git repository now and its hash is here. Also, we can observe that this file exists in B7 folder. And name of the folder matches first 2 characters in this SHA-1 hash. Okay, let me copy this SHA-1 hash and let me clear terminal. Now let's use git cut file command with option -p. Git cut file -p and paste copied hash. Enter. And I'll get hello Git here in a terminal. And that's our contents of the file that we have stored in Git repository. Now let's use next option -t. Git cut file -t and again copy SHA-1 hash. And here we see that type of this object with this SHA-1 hash is blob. And blobs are used to store raw files in Git. And now let's try to use last option, git cut file -s, and again paste here SHA-1 hash. And here we see size in bytes, 11 bytes. That's how we can explore contents of specific object in Git repository. Again, first option -p will print us contents of specific object. Here we see contents hello Git. Option -t will print type of specific object. In our case, we get blob, it is just file. And the last option here, -s, will show us size of specific object. And in our case, size is 11. Let's now try to read information about object that is absent in database. And let me get back to this command. And let's change last character in this SHA-1 hash. And instead of E, let's type, for example, A. Enter. And I got fatal error, not a valid object name. And that is reasonable because there is no such file with such name in folder B7. And we can verify that here there is only single file with name that ends with 5e. Okay, that's an error that you'll get if you'll try to read information about absent object. Let's quickly summarize. With git cut file command, you are able to read contents of any object in Git repository, independent of its type. With option -p, you'll see contents of the object. With option -t, you'll get type of the object. And with option -s, you'll get size of specific object. Now let's move on, and in the next lecture, let's create one more Git object. I'll see you in the next one. Bye.
Are you still here? Please smash a like button. It's free. Who cares?
Now you know how to read the contents of a specific Git object, and for that you should use git cut file command that has several options such as -p, -s and -t. -p will show contents of a specific object, -s will print size of that object, and -t will show you type of the object, and there are 4 types: blob, tree, commit and annotated tag. Now let's create one more Git object in Git repository. And for creation of a Git object, we could use git hash object command. And before we have used such command in order to create a Git object with contents hello Git. Recap that we have used here pipe, and the result of echo command was directed to next command as standard input. That's why in the next git hash object command we have used option --stdin that stands for standard input, and we told this command that it should take its input from standard input. And option -w was used in order to tell Git that it should store Git object in its database. Now let's try another option, and let's create Git object based on existing file. And for that we will use this command, git hash object, then comes file name, and then option -w. We don't need to use echo command anymore, and we don't need to use stdin option. Okay, let's try that. But before entering this command, we need to create a file with some contents. And let's create a new file on a desktop, not in our Git repository, and then based on the contents of this file on a desktop, we will create new Git object. Okay, let's do that. Let's go back to terminal and let me clear terminal. Let's actually open new tab, Command T. And here let me cd to desktop. Enter. And here let's create new file with some contents. Recap that there are several ways to create new files via shell. And we could use either touch command or nano command, or we could just write some text to file directly, like that. Echo, then text, second file in Git repository. And here just use greater than arrow and write here name of the file. And let's name it just new file.txt, like this. Enter, and if I list contents of desktop folder now, ls-la, I'll see new file here on the list. Now let's go back to our first project here, and let's now try to create new Git object based on this file, new file.txt. I'll of course can list contents of this file, cut, new file.txt, enter, and here you'll see text inside of it, second file in Git repository. Okay, let's get back to our first project. And here I'll enter git hash object, and here I need to add path to this file, new file.txt. And this file is located in parent directory for first project. Because if I'll list actually current directory, pwd, enter, you'll see that first project folder is located on desktop. That's why in order to find path to this file, new file.txt, I will use two dots in a file path, like this. Git hash object, two dots, slash, and here I'll type name of the file. Let's verify whether autocompletion will work. Just type N and press Tab. And file name was autocompleted. We could try to press Enter now, and if I'll press Enter, no Git objects will be created and we will just see SHA-1 hash of this file in a terminal. Let's do that. Enter. And here is SHA-1 hash of this new file.txt. We can verify that no new objects were created in Git repository. Let's go to objects folder, and here we still see only one B7 folder for objects. Now let's use same command but with option -w. And with this option we will write new Git object to repository. Enter. I see same SHA-1 hash here in a terminal, but if I'll get back to Finder, you'll see brand new folder with name 44, and the folder name matches two first characters in this SHA-1 hash, and inside of this folder we'll see new file. And name of this file matches remaining part of SHA-1 hash. Here is name of the file. Okay, now we have two objects in Git repository, and let's try to read contents of this new object. Let me copy this SHA-1 hash and clear terminal. And let's use git cut file command, git cut file, with option -p and paste copied SHA-1 hash, enter, and here I'll see contents of second object, second file in Git repository. Now let's verify type of this object, git cut file -t, and again paste this SHA-1 hash and I see blob, same type as for our first Git object. And last option, git cut file -s, will show us size of this object, and size is 30. Okay, now there are two objects in Git database. Here they are. They are located in two different folders, B7 and 44. And this second object in this folder we have created based on the contents of the file. And this file we have created here on desktop. But now we don't need this file anymore, that's why we can simply delete it. We can use rm command, and here will be name of the file, like this. Enter, and now this file is absent here on a desktop, but file in Git repository is still here. And with this I wanted to demonstrate you that Git repository is independent from files in your file system. It is a separate database with separate files. Okay, now you know how to create a new Git object using git hash object command with file name. And in this command that we have used in this lecture, we have specified file name of the source file that was used for creation of new hash object. But in this command there was no file name. And the Git didn't ask us about file name for new Git object. Why is that? How do you think? The reason for that is simple. Git blobs don't have file names. And let's talk about it next. I'll see you in a bit. Bye. In the previous lecture we came to conclusion that Git blobs don't have file names. What does it mean? Actually, each blob that is stored in objects folder has name, but this file name is based on a SHA-1 hash of every object. And in previous lectures we have seen that. For example, here you see folder B7 and inside of it you see this file. Or in a previous lecture we have created one more file and it is located here in this folder. But this Git object, Git blob, was created based on the contents of the file, and name of the file was not stored in this object. Okay, file names of the files that were used as source for creation of Git blobs are not stored in Git. We have discussed git cut file command and we have used it in previous lectures. And we have used such options as -p, -s and -t. And with -p we got contents of the object. Also with such options as -s and -t we are able to retrieve size of the object and type of the object, for example, blob or commit. There is no option to read file name of the blob, because blob doesn't store file name of original file. But here is another question. Where size and type of each object are stored in Git? How do you think? Answer is pretty straightforward. This information, size and type of each object, are stored directly inside of each blob. And now another question. Do you remember that we have compared SHA-1 hashes that were created for the same input, hello Git, by SHA-SUM utility and by git hash object command? And we have got two different SHA-1 hashes. Git hash object produced this hash and SHA-SUM utility produced this hash. And answer to the question why those two hashes are different is related to the answer to this question. And I have told you that size and type of each object are stored directly inside of the blob. And SHA-1 hash by Git is generated based on this information as well. And let's talk about it in the next lecture. I'll see you in a moment. Bye. We have just discussed that Git blobs don't store name of the file that was used as source for creation of Git blob. Also, we have discussed that object type and object length are stored inside of the blob. And now it's a good time to explain you structure of every Git object. Git object consists of 4 fields: object type, object length, delimiter, and content. And here you see example of the blob. Here object type is blob, object length is 11, here you see delimiter, it is actually null character and it is written as \0, and after that comes content. And in our database, in our first project, we have such object. Type blob, object length is 11 and content hello Git. And it doesn't matter how this object is created. There are always only 4 fields inside of actual Git object in Git database. How can we prove that? There are 2 ways. First is to read contents of Git object directly. And second, by creating SHA-1 hash of those contents and comparing resulting hash with the hash that was generated by git hash object command. In our case, this hash. But let's first try to read contents of Git object directly. And let's do that here in a terminal. Let's clear terminal and let's cd to .git/objects. Let's list files here, ls-la, and here now we see 2 folders for 2 files, 44 and b7, and let's for example cd to folder 44. And inside of this folder, ls-la, I'll see only one file, this one. And let's now try to read contents of this file using cut command. Please note, not git cut file command, just cut command. Cut and name of the file, 00, and I'll press tab here and press enter. And I see nothing here in the output. The reason is simple. Git stores files in compressed binary format. And that's why we are not able to read them directly in such way. But if you want to read contents of Git object, you can install Python and use zlib utility in order to uncompress specific Git object. I will not show you that, and we will use second way to verify that structure of Git object is like this. And for that, let's use SHA-SUM utility and generate SHA-1 hash based on all those contents on those 4 fields. Let's go back to terminal and let me open new tab, Command T. And here let's write following string: echo, double quotes, blob, then space, then 11, 11 is a size, then \0, it is null character, and after that without space, hello, Git, and closing double quotes. Let's press enter, and here in a terminal I see this string, blob space 11 without escape character, hello, Git. And let's try to generate SHA-1 hash from this string. Let's go to history, add pipe here, and type simply SHA-SUM. Recap that with help of pipe we can direct output of this command to next command, in our case SHA-SUM. Let's press enter, and here SHA-SUM has generated us SHA-1 hash from this string. And this SHA-1 hash looks pretty similar to the SHA-1 hash of the Git object that we have already created. If I'll get back to this tab and scroll up to the place where we have created this object, this one, we see this hash. It starts with B7 and ends with 5e. And this hash exactly matches this hash. And that means that Git has used those contents for generation of SHA-1 hash. And that proves that Git stores such object in its database. And each object has object type, object length, delimiter, and contents of the object. Please note that if you use other shell, not iterm with zh, you may get other result here. And the reason for that may be in different interpretation of this escaped character, \0, null character. And in order to tell shell that it should interpret escaped characters, you should add another option to echo command. Let's get back to history, Ctrl A to the beginning of the line, and here add option -e. And in our case, if I'll press enter, I'll get same result as before. And if I'll try to generate hash SHA-SUM hash with this option -e, I'll get same result, enter, and same result as here. But if I'll open built-in terminal, let's do that, terminal, enter, and let me make it larger and type same command, echo, double quotes, blob space 11 \0, hello, Git, and add here pipe and SHA-SUM, enter, I'll get another hash. But if I'll add -e option, let me do that here, -e, and press enter, I'll get desired result. That's because in terminal, if I'll just enter this command, let me copy it and paste here, I'll see escaped characters here. And it means that this escaped character wasn't interpreted by bash shell. And if I want to interpret it, I'll need to add here -e option, -e, enter. And now I'll get string without escaped character. But it doesn't mean that escaped character was simply deleted. It is here, but we simply don't see it. If I'll close this terminal window and get back to iterm and try to generate SHA-1 hash without this escaped character, like this, and press enter, I'll get different hash. But if I'll print to terminal result of this command, like this, you'll see same string as here. But again, in this case, escaped character is here, but it is hidden, and in this case, there is no escaped character. May sound difficult, but that's how it works under the hood. Okay, summary from this lecture is that each Git object has such structure. It contains object type, object length, delimiter, and content of each object. And now small task for you. please try to generate SHA-SUM hash for Git object as it looks in Git database for our another string. Recap that there are two files in Git database and the contents of second file are here, second file in Git repository. So task for you, please try to generate SHA-1 hash for this Git object using SHA-SUM utility and compare result. You should get this SHA-1 hash. I wish you good luck. Okay, let's quickly do that together. Here is text for the object, here is type of the object blob, and here is its size. We need simply combine all those three inputs. Let's go back to this tab, let me clear it, and type here following: echo. Let's add -e option for interpretation of escaped characters, then double quotes, and first comes type of the object, in our case it is blob. Then space, after that comes size, and size of this object is 30. Let's type 30, \0, escaped character null, and after that comes string. In our case, this string is here, second file in Git repository. Let's copy it and paste here, without any spaces. Let's add closing double quotes, and let's verify whether everything is fine. Let's press enter now. And here we see this string in terminal without escaped character, but again, it is there. Let's get back to history, add here pipe and type SHA-SUM. Enter, and here is result. And this SHA-1 hash matches this SHA-1 hash. Okay, I hope that you enjoyed this lecture and now you know how Git stores objects in its database. Every object is stored along with its type, length and delimiter. Okay, that's all for this lecture, and in the next one, let's find out how to create file names for the blobs. And I think that you could guess an answer. File names for the blobs could be stored in trees. And tree is another object type in Git. Let's talk about it in the next lecture. I'll see you there. Bye bye. Let's now shortly summarize what we have so far. There are two objects in Git repository, and those objects are located in folders B7 and 44. There is a single file here and single file here. And those objects have type blob. They are actually files. And we have examined those files using git cut file command. One of the files contains text hello Git, and another file contains text second file in Git repository. In the previous lecture, we have discussed the format of objects in Git database, and each object in Git repository has actually 4 fields: type of the object, object length, then delimiter, \0, this null delimiter, and contents of object. And using SHA-SUM utility, we have generated same hash as was generated by Git. And here is an example of the hash for our second file in Git repository. Okay, that's what we have so far. Now it's time to move on, and now it's time to create object of other type, specifically tree. And you know that blobs don't contain actually file names of the source files. And that's where tree object type in Git comes in. You know that tree in Git data structure represents actually directories. And the trees may contain blobs and trees. And now it's time to have a closer look at tree, and now it's time to create very first tree in our Git repository. And let's talk about it next. I'll see you in a bit. Bye. Now let's talk about trees. Tree is one of 4 object types in Git. And before we have talked about blobs. And using blob you are able to store any file inside of the Git repository. But please note that blobs don't store file names of the source files. And each blob consists of contents of the file, type of the file, size, and delimiter, \0. And name of each blob is based on a SHA-1 hash of each file. And tree object type in Git is representation of directories. And each tree may contain blobs and other trees. But what is the structure of tree object type? Its structure is the same as structure, for example, of the blob. But instead of the blob, here will be tree. Here will be size of the tree, again delimiter and contents. But what about contents of the tree? What will be stored here? Let me show you this example. And in this example, you see contents of one of the trees of the real-world project. And here you actually see list of links to other blobs or trees. And every line contains 4 fields. Here you see permissions, then comes type of the object, tree or blob, then comes SHA-1 hash of this, in this example, tree, and then comes name. And that's where file names or names of directories are stored. For example, here on the first line you see link to the blob. Here you see permissions for this blob, then SHA-1 hash of this blob, and name, file name for this blob. That's why we don't need to store file names inside of the blobs. File names are stored inside of the tree objects. Okay, in this example you see that this sample tree object contains other trees, here or here. But in some cases, when tree doesn't have child trees, it will contain only blobs. Okay, now you see how simple is structure of the tree Git object. Now let's make a break, and after small pause, let's talk about permissions that appear here at the beginning of each line. I'll see you in a moment. Bye.
Enjoying this tutorial? Don't forget that it is part of the large, complete Git and GitHub course. In that course, I'll explain a lot of other advanced features of Git, like rebasing, working with pull requests, squashing, and many more. I hope to see you in that course.
Now you know that Git tree object is very simple, and its contents are like this. It is a set of links to other blobs and trees. And each record, each line here has 4 fields: permissions, type, blob or tree, then SHA-1 hash, and then name of the file or directory. And now let's quickly talk about permissions that appear here at the beginning of each line. There are 6 possible permissions, but most often you'll see first one and second one. First one, 0, 4 and 4 zeros, represents directory. Second one represents regular, non-executable file. And for example, executable file will have such permissions as 100,755. But you may ask me, why do we need those Git objects permissions? Answer is pretty simple. As you know, Git repository is independent from your file system. It is own file system of the Git. And based on Git repository, you are able to create files and folders on your computer. For example, in our case, we have 2 blobs inside of the Git repository, here in those folders. But we don't have any files here in our root folder, in our first project folder. But in one of the next lectures, based on the contents of objects folder, we will create files in our project. And that's where Git needs to know which permissions those files and directories should have after creation. Again, directory has this permission and regular non-executable file has this permission. And in the previous example that I have shown you, you see that permissions for blobs are set as for regular non-executable files. And permissions for trees are set as for directories 0, 4 and 4 zeros. Okay, that's our permissions for Git objects. Now let's move on, and next let's create tree object using another Git low-level command, git mk_tree. I'll see you in the next lecture. Bye. Currently in our Git repository there are two blobs with contents hello Git and second file in Git repository. Also those blobs have corresponding SHA-1 hashes, and starting from this diagram I will not use complete SHA-1 hash for Git objects. Instead, I'll usually use 5 or 6 first characters that clearly indicate specific Git object. For example, this blob with contents hello Git has SHA-1 hash that starts with B7AEC5, and blob with contents second file in Git repository has SHA-1 hash that starts with 4400AA. Now it's time to create new Git object of tree type, and inside of this tree we will add two pointers to existing blobs, to this one and this one. And you know that file names are specified inside of the tree object. And in our project let's name those files as file1.txt and file2.txt. Type for both those objects will be blob, and file permissions will be for both blobs equal to 100644. They are regular, non-executable files. And it means that our tree object will have contents like this. Two strings, and each will contain pointer to one of the blobs. In the first case, here is a pointer to our first blob, here is its full SHA-1 hash, here we must type exactly entire SHA-1 hash, and here will be name of the file for first blob, and we'll name it file1.txt. Same applies for second blob. Here you see permissions, then type blob, then SHA-1 hash of the second blob, and file name for this second blob, and its file name will be file2.txt. Okay, that's how tree object will look like. But we need to create it in some way. And for that we can use another low-level Git command mktree. This one, git mktree. Let's do that together and let's go to terminal. I'll close other tabs except this one and ensure that you are located in your first project, in the root of it. ls-la will show us that there is .git folder that is hidden. And let's now list all files in the objects folder inside of the .git folder. And for that we can use another shell command, find. And here we can type path to the folder where we're looking for the files, and path is .git/objects. Again, that's because I am located here in first project and I need to type entire path. And after that space, then option -type, and here F, where F stands for files. Let's just press enter and see what we will see in the output. Enter, and here I see 3 files. First one is actually system file, and we can safely ignore it, and next you see 2 files inside of the folders 44 and B7. Here is our first file, first blob, and here is our second blob. Okay, so far we have 2 files in 2 folders 44 and B7. Now let's create one more Git object, and it will be tree object. For that we will use mktree command, and first let's take a look at the help for this command. Let me clear terminal and type git mktree --help. Enter, and here you'll see that git mktree is used for building tree objects from ls-tree formatted text. And here below you see more detailed description, and it tells us that this command reads standard input in non-recursive ls-tree output format. We have not yet used this command ls-tree because it will output nothing at the moment. We will use this command later on in the course. For now we need somehow create tree object using mktree command. And the way how we can do that is following. Let me close this help, and we will do following. We will create new file and put contents like those inside of this file. And after that we will pipe 2 commands. First command will be cut, here will be file name.txt for example, and then pipe and then git mktree. And this will direct contents of this file to git mktree command as standard input. And using such a combination of commands, we will be able to create new tree Git object. Okay, let's start doing that, and let's first create file with required contents. And this new file will contain 2 lines, 2 links to 2 blobs. Okay, let's do that. And let's create new file again on the desktop in order to avoid confusion with our Git repository and our first project folder. Let me open new tab, Command T, go to desktop, enter, and here let's create file called temp3, temporal tree. And for creation of the file, I can use touch command and create file, and after that use nano editor in order to edit it. But I can also use nano editor straightforward without touch command, like that. Nano, and here let's type name of the file, temp-tree.txt. Enter, and here I'll add 2 strings like those. First comes file permission 10.0.0.644, that stands for non-executable regular file. Then space, and after space we need to specify type of the Git object. And type will be in our case blob for both records. Then space, and after space we need to type SHA-1 hash of specific blob. Let's go back to this tab, and in a history using up arrow let's find command that lists files in Git objects folder. Let's enter, and here will be first blob, this one. Let me copy this section and paste here. And of course I need to delete slash here, like that. I can go to the end of the line by pressing Ctrl E. Then after SHA-1 hash you need to press tab instead of space. It is very important. Tab, and here type name of the file. And let's give it name file1.txt. Okay, first line is completed. Let's go to the next one, just press enter. And here will be again link to the blob. Its file permissions will be 10.0.644, same as for the first blob. Then space, then type blob. Then comes SHA-1 hash for the second file. And let's go back again to this tab and copy this part. Go back to this tab and paste copied path. Go back again to slash and delete it. Ctrl E, go to the end of the line, press again tab, not space, tab. And here type name of the second file. And let's name it file2.txt. Like that. That's all. We have created required contents, and based on those contents we will create new tree object. Now we can write contents of this file, Ctrl O, press enter and exit from editing, Ctrl X. Let's now list files on a desktop, ls-la, and here we see this temp-tree.txt file. Let's read contents of this file, cut temp-tree.txt, enter, and here we see 2 lines that represent 2 links to our blobs. Okay, now we can finally use mktree command and create new tree object. Let's go back to this tab and let me clear terminal. And let's here use cut command in order to list contents of this file that is located on a desktop. And for that we will use again 2 dots in a path, like that, cut, 2 dots, slash, and here let's type name of the file, temp, let's use tab, temp-tree.txt and press enter. And here I see same contents as I saw here. Okay, now we can pipe this output to git mktree command. And for that let's go to history, add here pipe, and type here git mktree, like that. Let's press enter. How do you think, what is this? This is SHA-1 hash of new Git object, tree object. And if I'll open, for example, Finder, I'll see brand new folder with the name 3b in an objects folder. And inside of this folder, I'll see new file. And logic of creation of this file is the same as for blobs. But now we have just created our first tree in Git repository. And let's examine contents of this new Git tree object in the next lecture. I'll see you there. Bye. In the previous lecture, we have created new tree object in Git repository. And for that, we have created a temporal file called temp3.txt with such contents. Notice that here you need to use tab before file name instead of space. And each line contains actually pointer to the blob. Here you see permissions, then type blob, then SHA-1 hash of corresponding blob, and here file name for this blob. You can choose at this point any file name you want. I have set file names as file1.txt and file2.txt for the second blob. And here you see SHA-1 hash of the brand new tree object that was created by Git. And actually now we can delete this temp3.txt file, and after that we will explore contents of new tree object. Let's go to next tab and just use rm command and delete temp3.txt file. Let's press enter, and now this file was removed. Okay, let's go to our project and let's use first find command and list all files in the objects folder in .git folder. Let's clear terminal and find files here, find space .git/objects, then option -type and F. F stands for files. Enter, and now I see 3 files, not counting this system file, in objects folder. And this one was created in the last lecture. It stores now 3 objects. And let's now use git cut file command in order to read information about this object. Let's type first git cut file -p, and here I can write either full SHA-1 hash of git object or just few first characters. And here I'll write just 3b95d. Enter, and here I see contents of the tree object. And contents match contents of the file that we have used in the previous lecture as source for creation of the tree object. And it contains 2 links to 2 blobs. Okay, now let's use git cut file command with -s option. Let's go to history and replace -p with -s. Enter, and here you see size of this object, 74. And let's finally check type of this object, git cut file -t, and let's try to type just first character, 3. Let's press enter, and here you'll see error, not a valid object name 3. Let's try to type 3b and press enter, again not a valid object name. Let's add one more character, 9, and now press enter. Again not a valid object name. Let's add 5 and press enter, and only now it worked. It means that you need to enter at least 4 characters, first characters of SHA-1 hash. And here you see result 3. And that is correct, because type of this Git object is tree. And that is great. We have manually created our first tree, and now structure of our Git repository looks like this. Tree with links to 2 files, file1.txt and file2.txt. And here you see information about those 2 files: SHA-1 hash, type, blob, and names of the files. Okay, now we have dived really deep into Git internals, and we have created this hierarchical structure actually using only low-level commands. We didn't use any add, commit commands, only low-level commands like git hash object and git mk3. Also, you know how to use git cut file command in order to read contents of any Git object. And you see here that 3 Git objects contain same information as, for example, blobs. They contain contents of the file, then size of the file, and then type. Structure is the same as we have discussed here. 4 fields: object type, object length, delimiter, and contents. And if you have did all those steps same as I did, you should get exactly same file name for new tree object, this one. Okay, now it's time to move on, and next we will discuss how to retrieve files from Git repository and put them into special area called staging area or index. Let's talk about it in the next lecture. I'll see you there. Bye bye. Before we have actually worked with Git repository, and we have inserted blobs and one tree directly into Git repository. But there are actually three main areas where files and folders may live in Git. And they are working directory, staging area or index, and Git repository. Again, you are already familiar with structure of Git repository, and you know how files are stored there, and every object in Git repository has a file name that is based on SHA-1 hash of that object. Okay, that is Git repository. But now it's time to talk about staging area that sits between working directory and Git repository. Staging area is usually called index, and the staging area is actually responsible for preparing files to be inserted into Git repository, and in opposite way, it prepares file taken from Git repository to be put into working directory. Please note that putting files into staging area or index is mandatory step in all Git operations, either when you want to place files from working directory into Git repository or when you want to read files from Git repository and check out them into your working directory. Staging area or index always sits in between. Okay, next let's examine files in our first project and their distribution among those three areas: working directory, staging area or index, and Git repository. I'll see you in the next lecture. Bye. Let's now have a look at our first project in terms of those three areas where files may live in. And you know that at the moment we have such structure in Git repository here. There is a tree, and inside of this tree there are two links to two blobs. And we have added file names for those blobs: file1.txt and file2.txt. Every object in Git repository has its SHA-1 hash. And here in the corners I have put the first 6 characters of each SHA-1 hash. Here is beginning of SHA-1 hash for this blob, here is beginning of SHA-1 hash of this blob, and here are first characters of SHA-1 hash of the tree object. And we have created this tree object in one of the previous lectures. These are 3 objects that are now located in Git repository here. But please note that there is no other tree that points to this tree. And that means that this tree object represents a root directory. This is very, very important. If you would like to put those 2 blobs into another tree that will represent folder with name, you need to create one more tree between those blobs and this root tree. We will not create one more tree now, but you should understand that this tree in our first project represents root directory, because there is no other tree that points to this tree. Okay, that's are 3 objects that are located now here in Git repository. Now let's examine our working directory. And for that we can simply open up Finder, and here you see folder first project. And at the moment there is only one hidden folder .git. Actually I can hide this hidden folder by pressing key combination Command Shift and dot like that, and now you'll see that this folder is empty. There are no files or folders. Okay, that's our working directory. Let me show hidden files again. Command Shift and dot. Now let's examine staging area. And for that there is a special command called git ls files. And with help of this command we can examine all files that are located currently in staging area or index. Let's go to terminal, and here in terminal let's first clear it and then type git ls files. Enter, and here you see that now index is empty. There are no files in Git staging area. It means that there are files only in Git repository, there are no files in staging area or index, and there are no files in working directory. And that means that we can represent our current situation in first project in following way. Working directory is empty, staging area or index is empty, And in Git repository there are two files. Actually, there are two blobs and one tree that points to those two blobs. And those file names are located inside of the tree. That is our current files distribution among those three areas. Now it's time to take those files from Git repository and put them into staging area or index. Let's discuss how to do that in the next lecture. I'll see you in a bit. Bye. Okay, at the moment picture of the first project is like this. There are two files in Git repository and no files in staging area and working directory. And we know that in Git repository there are two blobs and one tree that points to those two blobs. And this tree represents root directory. And in a corner again you see SHA-1 hashes, short versions of them, for all three objects. And in order to retrieve files from Git repository and put them into staging area, we should use git read tree command. And this command requires SHA-1 hash as argument, SHA-1 hash of the tree object. And when you enter this command, Git will try to find Git object with such hash. And after that, if object is found, it will take entire tree under this object and put it into staging area. And after this operation in our first project, two files should appear here in the staging area. Again, there will be no tree because this tree represents root directory. Okay, let's try to do that, and let's do that in the terminal. Here, let's first list files in our objects folder. Let's first clear terminal and let's use find command. Find.git/objects, type F, enter, and tree object is stored in this file that is located in 3b directory. Actually, we have created all those three objects in Git repository manually. And you and I know that here is a blob, here is another blob, and here is tree object. But any other person that will look at all those files will be able to guess where is tree or where is a blob. And at the moment there is no other way to get information about that except git cut file command. Because at the moment we have files only in Git repository. There are no pointers, no commits, nothing. Only three Git objects in Git repository. That's why we can first ensure that here is a tree, and for that we can use git cut file command, git cut file, and here write at least 4 characters of the SHA-1 hash, 3b. Don't forget to put first name of the folder, and then 95. And let's add the option -t because we are looking for the type of this object, -t, and here we see that type of this object is tree. That's why in git read tree command we should use this hash 3b95, and this hash is the hash of our tree that points to two blobs, this blob and this blob. Okay, let's take files from Git repository and put them into staging area using git read tree command. Git read tree, and here will be SHA-1 hash of tree object. Again, we can just type several first characters of the SHA-1 hash of the tree object. And let's press enter now. Enter, and nothing happened. But we see this yellow cross sign here in command prompt. I'll tell you what does it mean later on. But for now, we already should have two files in staging area. And let's examine staging area in the next lecture. I'll see you there. Bye.
Now please stop and do 3 simple actions. First one, smash a like button. Second one, subscribe to my channel. And third one, ring a bell to get notifications about all further videos.
In the previous lecture we have talked about git read tree command, and we have used it with argument 3b95. And this number represents first 4 characters of the SHA-1 hash of our tree object that is located in the folder 3b, and here is its file name. Okay, Now staging area in our project shouldn't be empty anymore. And two files, file1.txt and file2.txt, should appear here. And we can read contents of staging area or index using git ls files command. Let's try that. Git ls-files. Enter. And now it is not empty anymore. There are two files, file1.txt and file2.txt. And if I'll add option -s like that and press enter, I'll see those files in a table format. Here are permissions of each file, and notice that those permissions match permissions that are located in the tree object. Next comes SHA-1 hash of each file. Here is SHA-1 hash of the file that contains hello git string, and here is SHA-1 hash of another file. Those zeros here for each file, here and here, mean that those files in staging area here are the same as files in Git repository here. Those files were not changed. And here you see file names for each file, file1.txt and file2.txt. Okay, that's great. Now we see files here in a staging area. And now it's finally time to take files from staging area and put them into the working directory. And let's do that next. I'll see you in a bit. Bye. At the moment we have two files in a staging area or index. And those files are file1.txt and file2.txt. And we have used the read tree command in order to retrieve files from Git repository and put them into staging area. We have listed files in staging area using git ls files command, and here are two files. Okay, now it's time to take those files and put them into our working directory. At the moment it is empty, there are no files except hidden.git folder, and here you see that. Again, let me press Command-Shift-Dot and no files are here. Also, we can go back to terminal actually and open up new tab like that and cd to desktop and first project and list files here. And again it is empty. With -a option you'll see hidden.git folder. Okay, but how we can put files from staging area into working directory? For that we can use another git command, git checkout index. And with option -a we will read all files that are located in staging area and put them into working directory. Please recap that files in staging area here are the same at the moment as Git files in Git repository. Okay, let's now use git checkout index command. Let's go to terminal. Again, this folder is empty at the moment, it is our working directory. Let's go back to this tab and enter here command git checkout index -a. Enter, and command was successful. Now let's go back to this tab and list files again. ls, enter, and here are two files. Let's list them in the table format ls-l, enter, and here are two files with names file1.txt and file2.txt. And now we can easily use cut command in order to read contents of each file. Cut file1.txt, enter, you see here hello git, and cut file2.txt, enter, you see second file in Git repository. And that's great. Now our working directory has two files. We can go to Finder and we'll see those files here as well, file1.txt and file2.txt. And finally, we have completed entire process of retrieving files from Git repository and putting them into working directory. And please note that we have done all of that manually. We have manually inserted files into Git repository, then retrieved them and put into staging area, and after that we have read files from staging area and put them into working directory. Okay, let's next summarize what we have so far and what you have learned so far. I'll see you next. Bye.
Just friendly reminder, now it's the best time to become my subscriber, smash a like button and leave a comment under this video.
Before summarizing what you have learned in this section, let me ask you a question. And this question is here. How many folders for objects Git can create in Git objects folder? At the moment, Git has created 3 folders for Git objects, and they are named 3b, 44, and b7. I'm not counting those 2 folders. Please try to answer this question yourself. You got an answer? Answer is pretty simple. As you see, Git distributes all objects among folders. And both name of the folder and name of the file are based on the SHA-1 hash of specific object. And for name of the folder, Git takes first 2 hexadecimal characters from the SHA-1 hash. Of course, if another Git object will have, for example, hash that starts also with b7, you'll see another file in the same folder b7. And if we want to find out how many folders with such names Git can create here in this objects folder, we should do simply following. We should take a quantity of hexadecimal characters, and it is 16, and multiply by itself, because there are only 2 places here in folder name. And that means that formula will be following. 16 multiplied by 16, and it is equal to 256. And that is maximum number of folders that Git could create in Git objects folder. Again, each folder name contains 2 hexadecimal characters. That's why to find out maximum number of folders here, we need to multiply 16 by 16. 16 is quantity of hexadecimal characters, 10 numbers and 6 letters. Okay, now you know how Git distributes objects among folders, and you know maximum quantity of those folders. It is 256. Okay, let's move on and proceed to summary of this section. I'll see you in a moment. Bye. Now let's summarize what we have discussed in this large section. In this section, we were focused primarily on Git repository. But you already know that there are 3 areas where files and folders may live in Git. And they are working directory, staging area or index, and Git repository. In Git repository, Git stores all objects in special format. And there are actually 4 types of objects that Git can store, and they are blobs, trees, commits, and annotated tags. Structure of each object looks like this. There is type of the object, object length, delimiter, and object contents. And again, this format is the same for all object types in Git, for blobs, for trees, for commits, and for annotated tags. In our first project, we have created several Git objects, 2 blobs and 1 tree. And for that, we have used several low-level commands like git hash object, git cat file, and git mk3. Actually, for creation of the blobs, we have used git hash object command, and for creation of the tree, we have used git mk3 command. And this command, git cat file with different options, is used for reading contents and information about objects from Git database. Okay, also we have discussed that there is special area in Git called staging area. And all files and folders that you want to retrieve from Git repository go first through the staging area, and after that they may be placed into working directory. And that's what we did in our project. We used 2 Git commands. First one was git read tree, and with help of this command we have read our tree from Git repository and placed files into staging area or into index. And after that we have used another Git command, git checkout index, that allows us to read contents of staging area and create files and folders in working directory. And finally, in our first project we have 2 files in working directory. And if I'll go to terminal and list files here, you'll see file1.txt and file2.txt. And again, those files are located in working directory here. They are located actually in staging area and in Git repository as well. But you have seen that after using git read tree command, this one, and putting files into staging area, our command prompt in terminal has changed and this yellow cross sign has appeared. And now it's time to move on to next section, where we will start talking about commits. Also in the next section we will extend this first project and add new folders and files into it. Because at the moment it contains actually only two files, file1.txt and file2.txt. And there are only 3 objects in Git database. And before moving to the next section, let me show you another Git command that is probably familiar to you, and it is git status. Let's enter it, git status, enter. And here you'll see status of your Git repository. We are located currently on the master branch, it is default branch. There are no commits, and in the next section we will fix it, we will create several commits. And here you see changes to be committed. And there are 2 new files, file1.txt, file2.txt. And that's why Git shows us here this cross yellow sign. It says that there are some uncommitted changes. And as soon as you'll commit those changes, this yellow cross sign will disappear. But let's discuss all of that in the next section. I'll see you there. Bye bye.
In the previous section, we have used the non-traditional way of working with Git, and first we have created files in Git repository, after that we have moved them to staging area, and finally we have moved files from staging area into working directory. In this section we will get back to traditional way of using Git and we will create some files in working directory, then I'll explain you how to stage them and commit them. I'll tell you how to set up Git author name and email and how to use those settings in your Git repository, and also I'll explain you in details what is the difference between 3 areas: working directory, staging area and repository. Let's dive in and let's learn basics of Git.
Let's start this section by talking about commits. And commit is another Git object type that we have not yet discussed. And in a command line here, you have seen that there are no commits yet in our project. Okay, what is commit? First of all, commit has same structure as blob and tree. I mean that it contains object type, object length, and contents of the object. But what are contents of every Git commit? Each Git commit has following info inside: author name and email, commit description, and parent. Parent is optional. Also, of course, each commit has its own SHA-1 hash. That's because commit is regular Git object and every Git object must have SHA-1 hash. But what is the purpose of commit? Why do we need this special Git object type? Commits allow us actually store in Git database different versions of our projects or different, let's say, snapshots. And after that we are able pretty easily and fast move to any version of your project by checking out specific commit. But how commit actually stores current version of the project or current snapshot? There is one more field that is absent here. That is one more field that I have not listed here. And this field is pointer to specific tree object in Git database. Let's have a look at this diagram. And here you see our 3 objects in Git database that we have already created. And commit is simply a wrapper around tree object. And commit contains pointer to specific tree. And here you see SHA-1 hash of this tree object. It matches this SHA-1 hash here. And that is how simple it is under the hood. Commit is simply wrapper around tree object in Git database, nothing else. And of course, you may have multiple trees in your Git repository and multiple pointers, multiple commits to different trees. And you can easily change those commits and check out different versions of your project. Checkout means taking files from Git repository and put them into your working directory. In the previous section, we have actually also checked out files from Git repository. But for that, we have used two commands, git read tree and git checkout index. And after that, files have appeared here in our root first project folder, file1.txt and file2.txt. But with commits and with git checkout command, you'll be able to do that in a one step. Again, commit has such fields as author name and email, commit description, it is just text that is included in every commit, parent, it is a pointer to parent commit, we will talk about that in the next lectures, and pointer to specific tree object in Git database. That's all. And of course, every commit has its own SHA-1 hash, as every Git object has. Now we could create our first commit in our first project, but before that we need to set author name and email. And those fields could be set in global configuration of the Git. And let's talk about it in the next lecture. I'll see you there. Bye.
Yeah, I have done everything as you have explained me. Yes, 10 hours long. Yes, I worked nights and days during several months. What? It's still piece of... What?
In the previous lecture we have talked about commits. And you know that every commit contains such information as author name and email, commit description, parent commit, and pointer to the tree object. But why do we need, for example, author name and email? This field is required in order to save information about the author of the changes that were made in your project. And you know that Git is distributed version control system, and that means that on the same project many people could work on. And that's why, in order to track all changes and keep entire history, Git stores in every commit information about author of that commit. And this information includes author name and email. And now let's discuss how to set author name and email. For that we will use another git command, git config. And with this command we are able to set name and email that will be attached to every git commit. And you could set username and user email either globally or per project. And usually it is set globally. And please note that you change settings only of your local Git setup, only on your local computer. And you can set here any name and email you want. Git doesn't care what will be set here. It will simply take this information and attach to every commit. But usually if you have account at GitHub, it is a pretty good practice to set name and email that will match name and email in your GitHub account settings. We will talk about GitHub later on in this course. If you want to set username and user email globally, you should use here option --global. And we will use now those two commands in order to set globally username and user email. And after that, we will read the configuration of the Git using this command, git config with option --list. Let's do that. Let's jump into terminal and let's clear it first. And let's now set user name. Git config --global, this option, user.name, and here in double quotes I'll type my name and surname, Bogdan Stashuk. Double quotes here are required if there is a space in your username. Okay, let's press enter, and now let's set email. Git config --global user.email, and here you can enter any email. But later on in the course we will talk about GitHub, and I'll ask you to create a new GitHub account if you don't have one. That's why please enter here email that you will use for creation of GitHub account. I'll enter mine, like this, and let's press enter. And now let's verify whether those changes were applied. And for that, let's use git config with option -- list. Enter, and here you'll see a bunch of git options. And let's scroll down, and somewhere here you'll find username and user email. And they were set correctly in my case. Okay, let's close this, and now we are all set and we are ready to create very first commit. And let's do that in the next lecture. I'll see you there. Bye. In the previous lecture, we have set up git username and git user email. And for that, we have used those two commands, git config -- global username and git config -- global user.email. And we have set git name and email globally. We have verified that configuration was applied using git config -- list. And now we are ready to proceed and create very first commit in our first project. Let me clear terminal, and again note that here we now see this yellow cross sign. Let's now check status of our Git project using git status command. Git status, enter, and here you'll see that there are no commits yet. We are now on master branch, and there are changes to be committed. And those changes are located in a staging area or index. Recap that in previous section we have taken files from Git repository and placed them into staging area and placed them also in working directory. And that's because there are two files in staging area. Git shows us this yellow cross sign and shows us this section. There are changes ready to be committed. And in our case now, we have two new files, file1.txt and file2.txt. And now important conclusion and another purpose of the staging area or index. If you want to create new commit, you must have some changes. And those changes must be placed into staging area or index. And at the moment, there are changes in our project. And if I'll use git ls files command with option -s, I'll see two files located in index. And that's why we are able now to commit those changes. And let's finally create our first commit in our first project. And for that, we will use command git commit with option -m. Using option -m, you are able to add description for your commit. Let's do that. Let's clear terminal and type here git commit -m, and here in double quotes, let's write our very first commit in the project. Like that. And let's press enter. Enter. And here we see result of this operation. Please try to pause video now and try to interpret this result yourself. What every field here means. Okay, let's do that together. This commit was created on default master branch. That's why here you see master. Next, this commit is our first commit in our project, and that's why it is called root commit. It doesn't have any parent commits. Later on, we will create other commits that will have parent commits. Here you see SHA-1 hash, actually part of it, of this new commit. You know that every commit is just Git object, and every Git object must have SHA-1 hash. Next, you see description of this commit, our very first commit in the project. And here you see that two files were changed, and Git has created two files, file1.txt and file2.txt, with those permissions. But you may ask me, where Git has created those two files? Let's answer this question in the next lecture. Also, we will use git cat file command in order to read information about this new object, new commit. I'll see you in the next lecture. Bye.
Hey, are you still here, enjoying this tutorial? Then smash a like button and leave a comment.
In the previous lecture, we have created our very first commit in our project. And here you see it's SHA-1 hash. Let's now go to Finder and examine folders in the Objects folder. And here you'll see one more folder, that starts with 6F. And those characters are two first characters of the SHA-1 hash of the commit object. And other folders remained unchanged. We still see folder 3B with one file inside of it, folder 44 and folder B7. Recap that here is a blob, here is another blob, and here is tree object. And now let's examine new object that was created here in this folder 6F. And let's use git cut file command. Git cut file -p, and here let's write 6F B7. Enter. And here you'll see contents of commit object. At the first line you see tree and SHA-1 hash. And it's a pointer to the tree object. And remember that I have told you that commit is just a wrapper around tree object. And that's why here you see SHA-1 hash of specific tree object. And it means that now we have structure like this. We have commit that points to our tree object. And here you see SHA-1 hash of this tree object. And in our case it is 3B, 95 and so on. After that you see author of commit and committer. Author is the person that has written changes, and committer is the person that has committed changes, issued git commit command. And in most cases author and committer is usually the same person, and that's why here on both lines you'll see same information. And here on both lines, author and committer, you'll see name here, and this name was configured in one of previous lectures using git config command, and we have configured it globally on our computer. And next, after name, you'll see email of the committer here, and again email was configured using git config command. After that, after name and email, you'll see timestamp or time when this commit was made. Time here is formatted in Unix timestamps. Here you see time in seconds that was passed since Unix epoch, since 1st January 1970, and here you see time zone. Here is my local time zone. Again, here is time in milliseconds, and here is time zone. Okay, after information about author of the commit and committer, you'll see description of the commit. And that is a text that we have added here using -m option. Okay, that's a contents of commit object. Let's read the size of this object. And let's change here option P to S. Enter. And size of this object is 215. And let's finally read type of this object. -t. Enter. And type is commit. And now we have 4 different objects in our Git repository. And there are 2 blobs here and here, 1 tree here, and 1 commit here. And it means that in the previous lecture, after this command, Git has created only 1 new object in Git repository. And this object contains actually commit. But here in the output after this command, you have seen that 2 files were changed, 2 insertions. And 2 files, file1.txt and file2.txt, were created. But in fact, we don't see any new files except existing files. And that's because in the previous section, we have created those 2 blobs here and here manually. We have inserted them using git hash object command. If those files were absent here, Git will create those files after this command. And now it's a good time to create new file in our project, add it to staging area and commit it, and observe changes after committing. And we will start by creating new file in working directory. After that we will place this file into staging area, and finally we will commit changes. And Git will write changes into Git repository. Recap that in previous section we have performed those steps in opposite direction. First, we have created files in Git repository. After that we have placed them into staging area. And finally, we have checked out those changes and placed files into working directory. In the next lecture, we will perform all of that in more natural way, the way how it usually happens in a real-world projects. First, files are placed here into working directory, then into staging area, and after that into Git repository. I'll see you in the next lecture. Bye. We have just created the very first commit in our project, and for that we have used the git commit command. With -m option, we have added description to our commit, and description is here. SHA-1 of the commit in my case starts with those characters. But please note that in your case you'll get another SHA-1 and the reason for that is pretty simple. In your case, author and committer will be different. And of course timestamps here and here will be different as well. But you know that the SHA-1 of each object in Git database is created based on contents of the object, and contents are here in my case, then on the length and type. And that's why in your case again you'll get different SHA-1 for your commits. So please keep that in mind and don't try to compare SHA-1 of your commits with mine. Now let's examine what we have so far in our project. And first of all, let me adjust this diagram, and here I'll add SHA-1 of my commit, and I'll take 6 first characters and paste here like that. And here I'll take description of the commit, this, copy it and paste here instead of this text like that. And this commit will be root commit in our project. Let me copy this and paste here, and here will be root commit, like that. Okay, great. That is a picture of our project at the moment. There is single commit object that points to tree object. Commit is just a wrapper around tree object, and inside of the tree object there are 2 links to 2 blobs. And those blobs contain strings hello git and second file in Git repository. Again, that is a current structure of our Git repository. Also, at the moment there are 2 files in working directory. Let's examine it. Just type ls. Here are 2 files, file1.txt and file2.txt. We can list them in table format like that, ls-l. And those files are still located in Git staging area. And we can list contents of staging area using git ls files command. We can also add -s option. And here you'll see them in table format. And again, those 2 files are still in staging area. It means that same files at the moment are located in working directory, here, in staging area, here, and in Git repository. We can examine Git repository by looking at files like this, find.git/objects-type f, enter, and here you'll see several objects in 4 different folders. Here are 2 blobs, here and here in folders 44 and B7. Here is our tree object in folder 3b, and here is commit object that was created in last lecture. And all of this means that distribution of the files among 3 areas, working directory, staging area, and Git repository, looks now like this. There are 2 files in working directory, there are 2 files in staging area index, and there are 2 files in Git repository. There are actually also Git commit object and Git tree object, but for simplicity I have shown here only 2 files, file1.txt and file2.txt. Actually, they are stored as blobs in Git repository. In the next lecture we will add 1 more file into working directory, and name of the file will be file3.txt, and the distribution of the files will be like that. And our goal next will be to place this new file into staging area, into index, and after that write changes into Git repository. And for that, we will create one more commit. And for all of that, we will use such basic commands as git add, git commit, git log, and git status. Also, we will start using git checkout command. Before creating new file in working directory, let's make a short overview of those basic git commands. And let's do that after the small pause. See you next. Bye. In this lecture, let's make a short overview of basic git commands. You already know several low-level commands like git hash object, git cut file, and git mk3. And in this course, I have started with low-level commands on purpose. I wanted you to fully understand what Git does under the hood and what is the structure of Git repository. And now it's time to move on and talk about several basic Git commands that are used very often, and probably most of those commands are already familiar to you. Let me make a short overview of those commands. First one that we have already used is git status. And with help of this command, you can get the current, let's say, state of your Git repository. This command will show you current branch. Also, it will show you if there are some changes ready to be committed. Also, if you'll change some files or add new files into working directory, this command will show you those changes. Next, git add command. This command helps you to add files to staging area. But of course, those files must be already located in working directory. It means that this command takes files from working directory and places them into staging area. Next, git commit. This command writes changes to Git repository, and we have already used this command. This command creates new commit object in Git repository, and it also creates new blobs and trees if it is needed. For example, if you create new file in working directory, then place it into staging area using git add command, and after that commit changes, then Git will create new blob in Git repository. And you'll see that in the next lectures. Next, git log command. This command is very useful and it shows history of the changes that were made in your repository. Actually, it shows you history of commits, and you can easily read information about all commits that were made. And finally, git checkout command. With help of this command, you can check out any commit or branch. And the checking out means that files are taken from Git repository and placed into working directory. In other words, using git checkout command, you can travel between different versions of your project, different commits or branches. And this command will completely overwrite contents of your working directory. And you'll see that in the next lectures as well. Okay, we have made a short overview of basic Git commands. There are also several other commands that are used when you work with remote repository. We will talk about such commands as git pull, git push, git clone, git fetch in separate section when we will talk about remote Git repositories and interaction between local repository and remote repository. For now, let's go on, and next let's try to use several of those commands, and let's add one more file into our repository. I'll see you after the small pause. Bye.
What did you say? I should delete my YouTube channel and don't post any videos anymore? Please leave a like if you don't think so.
Let's start by looking at current state of our project using git status command and git log command. Let's go to terminal and clear it. Git status. Enter. And here you see that we are located on branch master. Actually, we see that also in command prompt here, thanks to ZH and iterm2. And there is nothing to commit. Working tree is clean. And that is the current status of this project. And also you see that yellow cross sign has disappeared after committing changes. And that is a reflection actually of Git status output. If there is nothing to commit, you'll see nothing here in command prompt. But as soon as you'll make any changes and until you will commit them, you'll see here this yellow cross sign. In some cases, in some command prompts, you may see green check sign if there is nothing to commit, like in our case now. Okay, that is the current status of our project. Let's enter second command, git log. Enter, and here we see history of the changes. And at the moment we see only single commit. Here is its hash, here is author of this commit, it's me, my name and my email. And again, when you commit any changes, Git takes name of the user and email of the user from configuration of the Git. And you can set those values either in global configuration of the Git or locally for a specific project. And we have configured name and email globally for local Git. Also, you see here date of the commit, and now it is represented in readable format, not in Unix timestamp. Here you see date and time when I have made my commit. Also you see here time zone. And below you'll see description of the commit. And in our case, description is our very first commit in the project. Also here in the brackets you see strange word head, then arrow and master. I'll explain you what is head just in several lectures. At the moment, let's just skip this part. Okay, that is git log and its output. Again, we have only one commit at the moment, and structure of our project looks like this. There is commit that points to 3 and 3 points to 2 blobs. And in my case, SHA-1 hash of the commit starts with 6f b7 3b. Here is first several characters. In your case, SHA-1 hash will be completely different because of different contents of commit object. Okay, Ctrl Z, and now we are ready to create one more file in our project. And we will create it directly here in our first project folder. At the moment, there are two files, file1.txt and file2.txt. Let's create one more file, file3.txt. Let me clear terminal, and let's create it using nano editor. Nano file3.txt. Enter. And let's write here, for example, this is third file in our Git repository. Like that. Ctrl X exit, save modified buffer Y, enter, and we are done. File was created. And we immediately see again here this yellow cross sign. Let's now list files, ls-l. And now we see one more file in our working directory here. And now distribution of the files will be like this. There are two files here, here and here, and one more file was created in working directory. Let's get back here and let's list files in staging area. Git ls files -s. And there are still only two files, file1.txt and file2.txt. File3.txt is absent now in staging area. Now let's have a look at current state of our project. Git status. Enter. And now we see that we are still on master branch, but there are untracked files. And file name of untracked file is listed here. It is file3.txt. And also you see that there is nothing added to commit, but untracked files are present. And in parentheses here, you see that we should use git add command in order to start tracking files. And now it's time to stop here and talk about different tracking statuses of the files. In this current output, you see that file3.txt is now untracked. But we can change its status to tracked by entering git add command. In Git, there are 4 different tracking statuses of each file. And every file may change its status multiple times while you are working with your project. And those 4 tracking statuses are untracked, unmodified, modified, and staged. And let me make short overview of file tracking statuses in the next lecture. I'll see you in a bit. Bye. We have just created a new file in working directory, file3.txt. And in the console, with git status command, we see that this file is untracked. And in order to start tracking it, we should use git add command. And it means that when you add any new files into working directory, those files will become automatically untracked. And you decide whether you want to track them or not. And now let's discuss different tracking statuses for every file and the life cycle actually of every file. Please note that every file in Git may change its status multiple times. But by default, when you create new file, its status will be untracked. There is no status called tracked, but there are statuses called modified, staged, and unmodified. And we can say that file is tracked when it is either modified, staged, or unmodified. And let's now discuss different commands and actions that allow you to transition file from one state to another. And first transition is between untracked and staged state. And in order to move file from untracked state to staged state, you should use git add command. And with this command, you actually start tracking new file. And this file is copied from working directory into staging area. That's what you do with git add command. And that's why here in the console you see suggestion to use git add command to start tracking file. Again, this is relevant only to new files that are untracked. Okay, next, when file is already staged, it is considered as tracked, we can commit this file. And in order to commit file, you should use git commit command. Of course, you usually commit multiple files and folders using single git commit command, because commit is just a wrapper around the tree object. And tree object may contain links to multiple subtrees or blobs. Okay, and when you enter git commit command and when there are files or file in staged area, those files after committing will transition to unmodified state. And if we will look at our current distribution of the files among different areas, we can say that file1.txt and file2.txt are now unmodified. They are present in all those areas: working directory, staging area, and Git repository. And that's why if I'll go to terminal and type git ls files-s, you'll see those files here in staging area. But we don't see any information about those files when we enter git status command. Those files are absent in this information block. And that's because those two files are unmodified. They were not changed since last commit. Okay, git commit command transitions state of the file from staged to unmodified. And in most cases, most files will have unmodified state. Okay, but what happens if you change specific file in working directory? What does it mean? For example, there are already files file1.txt and file2.txt that are currently unmodified. And I change, for example, file2.txt in working directory. And if I make any changes to the file that is already tracked, that is, for example, unmodified, it will transition its state to modified. And you'll see those changes with git status command. And in case when we will modify any of unmodified files, for example, file1.txt or file2.txt, you'll see here in git status output separate section modified files and list of modified files. No worries, we will try that soon. Okay, that's what happens when you make any changes in any unmodified file. It will transition to modified state. And when a file is modified, you can again use git add command and move this file into staging area, stage it. And when you will stage it, its status will transition from modified to staged. It means that with help of git add command, you can stage either untracked files or modified files. And finally, you can untrack files. If a specific file was already committed, you can untrack this file and move it from unmodified state to untracked state. But you may ask me, when do we need to untrack specific file or files? This may happen, for example, when you have added a certain file or files to your repository by mistake, and you have already committed those changes. And you could remove those files from your repository and make them again untracked. More than that, you can even ignore specific files or even folders, and if you ignore them, you will not even see them as untracked files here in git status output. We will talk about that later on in the course. For now, let's proceed. And now there is a file, file3.txt, located in working directory, but now it is untracked. And we should use git add command in order to change its status from untracked to staged. And let's do that in the next lecture. But before moving on, let me quickly summarize what we discussed in this lecture. There are 4 states in file lifecycle in Git: untracked, modified, staged, and unmodified. When you add new file into working directory, it becomes untracked. If you want to stage file or files, you should use git add command, and you could stage either untracked files or modified files. When there are files in staging area and you commit changes, all those files or file that were located in staging area and were staged move to unmodified state. And when file is unmodified, it will not be listed in output of git status command. And that's why here we don't see any information about file1.txt and file2.txt. They are now unmodified. Okay, if you change any file that is unmodified, it will transition to modified. And the modified files will be listed in separate section here in this output of git status. And finally, you can untrack unmodified files. Some of those operations when file changes its state have, let's say, opposite operation. What do I mean? For example, when file was modified and you have moved it to staged state with commit git add, you can unstage this file and move it back to modified state. And same for untracked files. When specific file was staged and before it was untracked, you can unstage it and make again untracked. But I didn't want to overcomplicate this diagram, that's why I didn't add those transitions here. And actually they are used not so often. Okay, let's go on, and next let's use git add command in order to stage this untracked file. I'll see you next. Bye. We have already created new file in working directory. It is file3.txt. And we have talked about different states for every file: untracked, modified, staged, and unmodified. And now this new file is untracked. Let's now stage it using git add command. Let's go to terminal and clear it. Again, here you see that this file is untracked. Okay, clear. And now let's enter git add command. If I'll just enter git add and press enter, you'll see that nothing specified, nothing added. It means that git add command requires an argument. If you want to stage all untracked and modified files, you can use git add command with dot as argument, like this, git add and dot. But you can also stage specific file. And if you want to stage only one file, you should type here file name of this file. And in our case, we have only one file that is currently untracked and we want to stage it. That's why let's use here file name file3.txt, like that. Enter, and file was staged. There is no output of this command, but if I'll use git ls files command now, you'll see that file3 has appeared in staging area. I can list files with option -s, enter, and here you'll see SHA-1 hash of this new file as well. Okay, we have transitioned file3.txt from untracked state to stage state. And we can actually revert this operation back and make this file again untracked. And let's try this next. I'll see you in a bit. Bye.
You know what? Watching long videos here at YouTube is not really convenient. That's why I recommend you to enroll to the full-length course, link is up in the description below. And in this course, all lessons are split into different videos and are organized into different sections. I'll see you in that course.
We have just staged file3.txt and now it is located in staging area. If I'll enter git status command now, git status, you'll see that file3.txt is no longer untracked and it is ready to be committed. And that's because this file is now located in staging area. And here you see this file in output of git ls files command that lists files in staging area. Now let me show you how to make this file again untracked and move it out from staging area. This command that I'll use now will work if you have not yet committed changes of specific file. And in order to unstage specific file and move it out from staging area, we can use git rm option -- cached, and here will be name of the file that we want to take out from staging area. And in our case, this file3.txt. Enter. Here you see output rm file3.txt, and that means that file3.txt was removed from staging area. Let's verify that. Git ls files -s, enter, and now we see only two files here. File3.txt was removed. Let's verify that using git status command, and status of file3.txt should be again untracked. Enter, and yes, it is. File3.txt is now untracked. But please note that this command, git rm -- cached, doesn't remove file from your working directory. It is still here, ls, and this file is located still here in your working directory. And now it is untracked. Please note that with help of this command, git rm -- cached, you can transition file back from stage state to untracked state or to modified state if you have not committed yet your changes. If you have committed changes and you want to revert them back, you should use other command and we will talk about it later on. Okay, now our file3.txt is again untracked and let's move it to stage area again, because in the next lecture we will move it to unmodified state by committing those changes. Okay, let's clear terminal and again use git add command and type here file name file3.txt. Enter, and now this file should appear again in staging area. Git ls files -s, enter, and yes, here it is. And git status should show us that we are ready to commit our changes. And let's commit our changes in the next lecture. I'll see you in a bit. Bye. Now file3.txt was transitioned from untracked state to stage state, and now it is located in staging area. Now we can use git commit command in order to commit changes. And after committing changes, file3.txt will be moved from stage state to unmodified state. And please note that git after git commit command will create brand new object, new blob in Git repository, because file3.txt was absent in Git repository. Okay, let's commit changes. Git commit -m. With -m option we can add description of commit directly here, and description for this commit will be second commit, like that. And let's press enter. Enter, and changes were committed. you immediately see that this yellow cross sign has disappeared from command prompt. Here in output you see again name of the branch, master branch. You see here SHA-1 hash of new commit object that was just created. You see here description of this commit, second commit. You see that one file was changed, and one insertion plus means that there is one line of text in this file that was just committed. And it is true, file 3.txt contains only one line of text. We can read it, cut file 3.txt, enter, and here you see this line of text. This is third file in our Git repository. Also, you see here permissions of the file that was inserted to Git repository and name of this file, file 3.txt. And that means that Git should create new object for new commit. Here you see this SHA-1 hash. It should also create new blob for file 3.txt contents, and it should create new tree. And let's observe those changes in Git repository in the next lecture. I'll see you in a bit. Bye. In the previous video, we have used git commit command in order to commit our changes. And file 3.txt was moved from stage state to unmodified state. And now there are no changes in our project. Let's clear terminal and let's first use git status command. Enter, and here you see that we are still on branch master and there is nothing to commit. And working tree is clean. And that means that all areas, working directory, staging area and git repository are consistent now. Okay, let's now use git log command in order to see history of the changes. Git log, enter, and now we see two commits. Here you see our very first commit in the project. Here you see date of this commit, it was made 2 days ago. Here you see SHA-1 hash of this first root commit. And here above you see second commit that we have just made. Here above you see date of this second commit, and interestingly that I have made this second commit almost at the same time as first commit. Author is the same as in previous commit, it is me, my name and my email. And again, those settings, name and email, are taken from configuration of the Git. And here you see SHA-1 hash of this new commit. And again, please ignore this section, we will talk about it pretty soon. Okay, now we have two commits, first commit and second commit. Let me copy first several characters of this SHA-1 hash of the new commit. Copy and let's close this, Ctrl Z. Now let's use git cut file command in order to read contents of new commit object. Clear terminal, git cut file, -p, and paste copied hash, part of this hash. Enter, and now we see contents of second commit. Here is description. Here is information about author and committer. Timestamp in seconds since unique epoch, time zone, and above here you see line that was absent in first commit, and it is pointer to parent commit. Here you see keyword parent, and after that SHA-1 hash of parent commit. Before explaining you what is actually parent commit, let me copy several characters of this SHA-1 hash and use again git cut file command, -p, and paste copied characters. Enter, and here we see our very first commit. And again, I want to show you difference. In this output you don't see parent string. And that's because this commit was root commit and it doesn't have any parent commit. And all next commits in your project will have parent that points to parent commit. And that's why here in second commit we see this pointer to parent commit. We will discuss it once again and I'll show you it using diagram. But for now, please just note this difference. Root commit doesn't have parent and second commit has parent here. And also in second commit you see pointer to tree object. And this tree object is brand new object in Git repository. You see that its SHA-1 hash is different from SHA-1 hash of this tree object that was used in first commit. And let's now actually have a look at objects folder in Git repository. Let's go to Finder, and here I'll see 3 new folders that were created today. This one, and this one. And we already know that new commit object has this SHA-1 hash 44E073. And if I'll expand this folder, you see this new object inside that was created today. But you see that in my case it happened so that SHA-1 hash of this new commit object starts with 44. And there is already an object, it is blob, that was created in one of the previous lectures, and it is also located in this folder 44. And this again proves that Git distributes files among folders based just on first 2 characters of each SHA-1 hash. And again, in my case, it happened so that 2 objects are located in one folder. And again, second commit in my case is located here. In your case, again, you'll get completely different SHA-1 hash for your second commit. And that's because of difference of author, timestamp, and probably you'll enter other description. Okay, that is our commit object. Let's collapse this folder and let's have a look at tree object. We see in this second commit SHA-1 hash of new tree object, and it starts with 31b1. Let's have a look at this folder 31, and inside of it you see one object that was created today. And this object contains actually tree that points to blobs. Let's have a look at contents of this object. Git cat file -p, and we should enter here first several characters of this SHA-1 hash. And let's enter 31b1. Enter, and here you see contents of new tree object. And now it contains links to 3 files: file1.txt, file2.txt, and new file, file3.txt. And please note that SHA-1 hashes for old files that were already present in Git repository, file1.txt and file2.txt, are the same as before. They start with B7 and 44. And the reason for that is pretty simple. Contents of those 2 files were not changed. That's why objects in Git repository were not changed as well. There is no need to create new objects if those objects are already in Git repository. And that is very, very important. But file3.txt was absent in Git repository before this commit. That's why Git has automatically created new blob in Git repository. And here you see SHA-1 hash of this new blob. And if I'll go back to Finder, here in folder 28 you'll see brand new file that starts with 99. 99 are third and fourth characters in this SHA-1 hash. And that means that after commit, Git has created 3 new files in Git repository. This file, here are contents for file3.txt. This file, it is tree object. And commit object is located in already created folder 44, and the second file in this folder, and here you see its file name. That's what was done by Git after committing our changes. And again, using git log command, you can see history of commits. Here is first commit, and here is second commit. Okay, wonderful. Let's close this Ctrl-Z. And next, let me show you structure of our Git repository on diagram. It may look complicated, but in fact it is pretty simple. Here is this diagram. Let's discuss it in the next lecture. I'll see you there. Bye. Now our Git repository contains 7 objects, 2 commits, 2 trees, and 3 blobs. And using this diagram, let's discuss relations between all those objects. Before this second commit, Git repository looked like this, and we have discussed the structure. There was one single commit, root commit, that pointed to one tree object. Commit was a wrapper around this tree object, and the tree object had 2 links to 2 files, file1.txt and file2.txt, and there were 2 blobs. And after second commit, one new commit object was added, one new tree object was created, and one new blob. But all previous objects in our case remained unchanged. there are still those two blobs, there is this tree and there is this commit. If I'll go to Finder, you'll see here 6 folders in my case, because there are 2 files here in this folder. In your case, you'll probably see 7 different folders. And that means that the old objects were not deleted. Okay, let's have a look at this connection between 2 commits. Here is first commit, root commit, and here is second commit. And please note that timeline is here. And that means that this commit was created after this first commit. And that is pretty important for understanding. This commit is newer, it is more recent than this commit. That's why in this second commit there is a link to parent commit. And we have seen that in output in command line. There is separate line parent that contains SHA-1 hash of the parent commit. And root commit doesn't have this line, because this root it is very first commit in our project. Okay, that is second commit, and description of this commit in our case is just second commit. Please note that here in a corner I have put SHA-1 hash of my commit. In your case, SHA-1 hash will be completely different due to different author and different timestamp. Okay, next this commit points to tree object. And the contents of the tree object should be, in your case, the same as in my case. That's why SHA-1 hash of this tree object should match with mine. Okay, that is a second commit. But question to you, how do you think why second tree, new tree was created? Why Git didn't just reuse this tree object? Answer is pretty simple. Contents of this tree object are different from contents of this object. There are 3 links in this new tree, and all 3 contained only 2 links to 2 files. Contents are different, that's why SHA-1 hashes of the objects are also different. That's why Git has created brand new object with new hash, in new folder, 31 in my case. Next, this new tree object contains 3 links to 3 different blobs. There was no need to create new blobs for file1.txt and file2.txt. That's why those blobs were simply reused, and links to existing blobs were added to this tree object. Here you see those links. But blob for file3.txt was absent. That's why Git has created brand new blob with such contents. And if you have entered same text in this file3.txt as me, this is third file in our Git repository, you should get exactly same SHA-1 hash as I get for this blob. And if this SHA-1 hash is the same, SHA-1 hash for tree object should be also the same. Because in your case contents of the tree object should be exactly the same as in my case. Same 3 links to different files. Okay, that is that simple. There is new commit object that is wrapper around new tree object, and this new tree object contains links to 3 blobs. To 2 existing blobs, first file and second file, and new blob for third file, file3.txt. And again, please note that file names for the blobs are located inside of the tree objects that are not located inside of the blobs. Blobs contain only contents of specific file plus size of the object and type of the object. And please pay attention on this relation between 2 commits. Here is timeline, here is more recent commit, and more recent commits have pointers to parent commits. And in such case, in our case, there is single parent for this commit, and it is root commit. Okay, I hope that now it is fully clear to you what happened in Git repository after second commit. 3 new objects were created: new commit, new tree, and new blob. And now we actually have 2 versions of our project, 2 trees. One tree contains 2 blobs and the second tree contains 3 blobs. And currently in working directory, here we see actually 3 files: file1.txt, file2.txt, and file3.txt. And now it's time to explain you how we can change, let's say, version of our project by moving to different commits. Now we are located at this commit, but we can safely move to previous commit and check out actually this tree. And let's start our discussion about traveling between different versions of the project by looking at this diagram. Let's discuss it in the next lecture. I'll see you there. Bye.
Could you please make me a favor? Please leave a like under this video and share this video with anyone you know.
After previous section, you know that every file in Git has its own life cycle, and by default all files that are created in working directory become untracked. And if you want to make file tracked, you need to add it first to staging area. After adding it to staging area, you should commit changes. And after committing changes, Git writes actual object in Git repository. In this section we will talk about branches, and I'll explain you why branches are needed, how to create new branch, how to check out different branches, and how to delete branches. Also, I'll tell you about head, and you'll understand what is head, why it is needed, how it works, and so on. By default, head points to current branch, and it moves of course along with branch. But also you are able to check out specific commit by using its SHA-1 hash. In such case, you will move into so-called detached head state. We will talk about this state in details in advanced Git section. For now, let's talk about branches and let's create some branches. In the previous lecture, we have created one more commit in our Git repository. And we have used two most common Git operations: adding files to staging area and committing files to Git repository. And using this diagram, let me explain you one more command, git checkout. We will talk about this command in the next section in details, but for now let me just give you a short overview of it. Okay, here are three Git areas: working directory, staging area or index, and Git repository. Using git add command, we can move files from working directory into staging area. And as you already know, we can add to staging area either untracked files or modified files. And we can add either specific file or all files that were modified or that were just added to our working directory. That is git add command. After that, when files are already located in staging area or index, we can commit changes using git commit command. Every commit includes such information as author name and author email, date of the commit, and commit message or commit description. And after committing changes, files or files that were located in staging area are moved to Git repository. And the status of those files is changed to untracked. That's how you can move files from working directory to Git repository, and it is necessary to move them through the staging area. It is also an option to move files from working directory to Git repository with single git commit command. We will use it later on. But under the hood, files will be moved through the staging area as well. Okay, when files were committed, and you have more than one commit in your project, you can jump between different versions of your project. At the moment in our project there are two commits. This one, root commit, and the second commit that points to parent commit. And now we already have two versions of our project. This version, where this commit stands at the root of the tree, and second version, where second commits point to this second tree. And we can easily change versions of our project by jumping between those two commits. And that's where git checkout command is used. You can use this command in order to retrieve specific version of your project from Git repository. And with this command, Git retrieves files and folders from Git repository and puts them into working directory. And under the hood, this command also replaces files in staging area. And after checking out a specific version of your project, you can easily move on and make, for example, any changes, add new files to your project, commit those changes, and so on. That's what we will do in the next section. But before moving to the next section, let me also show you this diagram and explain you how different file states relate to different Git areas. Again, there are three areas: working directory, staging area index, and Git repository. And when you add new file to working directory, it becomes untracked. It means that untracked files are located only in working directory and are absent in staging area or Git repository. After that, when you, for example, stage untracked file, its state becomes staged. And this file is now located also in staging area. Of course, this file is still located in working directory as well, but for simplicity, I have added stage state only under staging area. When you commit changes of the file, its state changes to unmodified state. And after committing, Git writes file into Git repository, it remains in staging area, and of course, it remains in working directory. And when there are no changes in your project and all previous files and folders were committed, all files will have unmodified state and will be located in all three areas. When you take any of unmodified files that is already in working directory, in staging area and in Git repository and modify it, it becomes modified and it remains modified in working directory. If you want to move it to staging area, you should use git add command and stage it. And after this operation, file becomes staged. And now it is located in staging area as well. I mean changed version of the file. But until you will commit changes, Git repository will still contain only old version of specific file. And when you commit changes, this modified file transitions from stage state to unmodified, and again all three areas, working directory, staging area and Git repository, will become fully consistent. Okay, that's how file states are distributed among different Git areas. I hope now it is fully clear what is file state, how file states are changed, and what happens under the hood when you use git add and git commit commands. Okay, that's all for this section, and at the moment, picture of our project looks like this. There are two commits, root commit and parent commit, and there are actually two trees that point to different blobs. This tree points to 2 blobs and this tree points to 3 blobs. In the next section, we will start using git checkout command. I'll explain you what is head and what is branch. I'll see you in the next section. Bye-bye.
Hey, are you still here? Do you like this tutorial? If so, please smash a like button and share this video with your friends and coworkers. Let's go on.
In the previous section, we have discussed a lot and we have done a lot. We have talked about commits and we have created one more commit in our repository. And it was second commit. And you know that after committing, Git creates new objects in Git repository. And in our case, 3 new objects were created. 1 new commit object, 1 new tree object, and 1 new blob object. And now we have 2 versions, or let's say snapshots, of our project. And in this section, we will actually discuss how we are able to jump between different versions of the project. We will talk about such concepts as head and branches. But before talking about head and branches, I would like to ask you to install one more program on your computer. And that is a graphical user interface for Git. You will install a program called GitHub Desktop. And we can easily find it here. GitHub Desktop, enter, and here is first link. Let's install this program in the next lecture, and I'll actually explain you why do we need to use it now and what features it has. I'll see you in the next lecture. Bye. Before this lecture, in the previous sections, we have used different Git commands in command line interface. And you know such commands as git cut file, git hash object, and so on. And many people may tell you that CLI is the best way to learn Git and it is a single way to learn Git in depth. I don't agree with such people, and I think that graphical user interface may give you much more details about what is happening actually in your project, in your repository. And now we will install GitHub Desktop. It is actually graphical user interface for Git, and we will use it parallel with command line interface. And I'll show you how it reflects changes in your Git repository. You already know that GitHub is actually hosting service for your repositories. And that means that primary goal of GitHub Desktop is to interact with remote repositories. But it also works well just with local repositories, and now we actually have only one single repository. It is local and it is called First Project. Let's now download GitHub Desktop and see it actually in action. It is available for macOS and for Windows, and it looks like this. Okay, let's click on download button. Let's wait a bit until file will be downloaded. Okay, file was downloaded, let's unzip it. And inside I'll find .app file, let me drag it into applications folder, and let me open it up. Let's click open here. And here I am prompted to sign into github.com. Before I have not asked you to create new account at github.com, that's why let's simply click on the button skip this step. Here in the next window we are prompted to configure Git, and you already know what those fields actually mean. Those name and email fields mean which author name and author email will be used when you will commit your changes. And we have actually already set up it in global configuration of the Git on your local computer. That's why here you'll see that those fields will be auto-populated. But if they are not, please fill in your name and your email. And let's click continue. Uncheck this checkbox and click finish. Okay, let's get started. And here we have several options. Clone repository from the internet, create new repository on your hard drive, and add existing repository from your hard drive. We already have our repository called First Project, and it is located in my case on desktop, and let's add this repository into GitHub Desktop. Click on this button and choose here path to our repository. It is in my case on desktop, and here is its folder. Let's select folder and click open. And click here add repository. And now this repository was added to GitHub Desktop. I'll double click on the window and enlarge it by pressing Command and plus, like this. And let's make a quick walkthrough in GitHub Desktop in the next lecture. I'll see you in a bit. Bye. In the previous lecture we have installed GitHub Desktop graphical user interface for Git. And we have added our current local repository called First Project to GitHub Desktop. And let me make now a quick overview of this program. Here in the top left corner we see current repository. Now it is First Project. We can click on this drop down, and here you'll see list of all repositories that you have added to GitHub Desktop. You can click here on add button and clone repository, create new repository, or add another existing repository. We will not add any other repositories now, we will leave here only just this repository, First Project. Let's click here, and next you see current branch, and current branch is master. You know that this branch is default branch. If you click on this drop down, you'll see that you are able to create new branches. For example, by clicking on new branch, you are able to give name to new branch, and then by clicking create branch button, create new branch. We will not do that now, let's simply close this window. Next, you see that you are able to publish repository to GitHub. We will do that, but later in the course. Next, you see that there are no local changes, and it means that now our repository is up to date, and the working directory, staging area, and Git repository are consistent. Here, if there are no local changes, you'll see also several options like publishing again your repository to GitHub, same as this action above. Also, we are able to open repository in your external editor. In my case, I have Visual Studio Code installed, and that's why here I see this option Open in Visual Studio Code. Later on in the course, I will ask you to install VS Code as well, because we will create another large project using VS Code editor. Also, you are able to view files of your repository in Finder simply by clicking on this button, Show in Finder. Let's click on it, and here you'll see folder First Project. If I'll expand it, I'll see my project files. It is actually our working directory. Also, I'll see hidden .git folder. Okay, let's close this and let's go on with overview of GitHub Desktop. Here at the left, you'll see column with changes and history tabs. At the moment, there are no changed files. And if I'll click on history, I'm able to see all commits that were made before. Here you see last commit, so most recent commits are at the top, and first commit here is at the bottom. You are able to click on any of those commits, and here you'll see details of each commit. Here you'll see SHA-1 hash of this commit object, and you know what SHA-1 hash actually means. Also you'll see author of this commit, and below you'll see all changes that were made in this project by this commit. Here you see that two files actually were added, file1.txt and file2.txt, and here in the right pane you'll see contents of every file. This file 2 contains line second file in Git repository, and file 1 contains text hello, Git. If I'll click on second commit, I'll see its SHA-1 hash, I'll see again author, it's me, and I see that file 3.txt was added to this project, and here are contents of this file. That's how you can pretty easily and fast look at the history of all commits. Okay, let's go back to changes. Also, when you will make any changes in your project, you will be able to commit them directly here in GitHub Desktop. After adding commit message here, it is called actually summary in GitHub Desktop, you will be able to commit your changes. And no worries, we will do that later. Okay, that's all for a quick overview of GitHub Desktop. It has many different other features. For example, you can perform different actions with branches, with repositories, and so on. And we will use GitHub Desktop parallel with command line interface in order to simplify learning process. Okay, let's move on. In the next lecture, we will discuss what is actually branch and how Git stores branches. So far, you know that the current branch is master branch, and here you see this information in GitHub Desktop, and you can see it also here in command line interface. So master is default branch. Let's discuss what is branch in the next lecture. I'll see you in a moment. Bye. In this lecture, I'm going to explain you concept of the branch. What is branch? After all previous discussions about internal Git structure, about blobs, commits, and so on, concept of the branch will be pretty easy to grasp for you. So what is branch? Branch is just text reference to specific commit, nothing else. Here I have summarized several key points of the branch. Default branch is master, and you already know that. Next, multiple branches can exist in the same repository, and you are able to switch between different branches. But of course, current branch may be only one, and by default this current branch is master branch. Next, pointers or references for all branches are located in the folder .git/refs/heads, and inside of it you'll find pointers for all branches that are created in your project. Next, current branch tracks new commits. What does it mean? For example, there are two branches, let's say master and new branch. Current branch is master, and for example, you have made several commits in this master branch. After that, you have switched to new branch and made 2 or 3 commits there. And after that, switch back again to master branch. And in master branch, you will not see commits that were made in new branch. That's because current branch tracks new commits, and those commits are not added to other branches. But there are ways to merge branches and rebase branches, and we will talk about those concepts later on as well. Next, branch pointer moves automatically after every new commit. But of course, name of the branch does not change. And you noticed that after second commit, we still remained in master branch. That's because master branch is our current branch. And when we make any new commit, you know that Git creates new commit object in Git repository. And this Git object has SHA-1 hash. And after committing changes, branch pointer will point to SHA-1 hash of this new commit object. And of course, we will observe it in practice. And finally, you can change branches using git checkout command. Just type git checkout and name of the branch you want to change to. And here I have added some examples of the names of the branches. For example, master is default branch name, new-branch is another example of the branch name, and here you see example of the branch name that is used more common in large companies when many developers collaborate on the same project. And for example, this number may mean number of the ticket that was assigned to specific developer. This prefix may represent short version of the project name or microservice name that is developed by a group of people. And please note that the branch name cannot have spaces inside of it. And if you'll try to create, for example, new branch with spaces, let's try that quickly, for example, in GitHub desktop. Click on this drop down, click new branch and type here name of the branch, for example, new space branch. You'll see that new branch will be created as new dash branch. Space will be replaced with dash. Okay, let's click cancel here. We don't want to create new branch now and go back to the list. That's all for main key points that are related to branches, and please note that current branch always tracks new commits and branch pointer moves automatically after every new commit. And now my question to you. At the moment we have two commits, first commit and second commit. And also both those commits were made in default current master branch. And now question, which commit master branch points now to? You are right, master branch now points to this second commit. It is last commit in the chain of commits. And picture is like this. Master branch is simply pointer to this second commit. Let's prove this. Let's get back to this list and let's have a look at contents of this folder. Let's go to terminal and here let's clear it first and cd to .git /refs/heads. Enter and let's list files here ls-l. Enter and here we see only one file called master. Let's have a look at contents of this file. Cut master. Enter, and contents are as simple as one line of text. And you guess what is this? It is SHA-1 hash of commit object. And in my case, this SHA-1 hash starts with 44E0, and it is exactly hash of the second commit, this one. In your case, SHA-1 hashes of both commits will be of course different due to different author and the different commit date. But in any case, contents of this file, master file in this folder, will be equal just to SHA-1 hash of specific commit, last commit that was made inside of this current branch, in our case master branch. Okay, now you see in practice that every branch is actually text wrapper around specific commit. And by creating different branches, you can create different references to different commits. And you can pretty easily jump between different commits. That's how branch looks under the hood. It is just pointer to specific commit. In our case, it is pointer to second commit. Now we will not create new branches, but please keep all those points in mind. We will create new branches pretty soon. Now it's time to talk about head. You remember that we have seen head in the output of git log command, here. And from current lecture you know that current branch is master and branch is wrapper around specific commit. And here you see that head is pointer to the branch. Let's talk about head in the next lecture. I'll see you there. Bye bye.
Hi, I'm looking for people who could share my new YouTube tutorial. What? Where?
In the previous lecture, we have talked about branches. And you know that you can create multiple branches in a single Git repository. Also, you know that you can create many different commits in your project. And more than that, in different branches, you can create different commits. And at the moment, you may have only single, let's say, version or snapshot of your project in your working directory. And now question, where Git stores information about current branch? How it knows which branch is current? From the previous lecture, you know that every branch is actually just pointer to specific commit. And this pointer does not change if you don't make any new commits inside of specific branch. And at the moment, our current branch master points to second commit. And if we will look again at contents of the master file located in this folder, we will find SHA-1 hash of the second commit. Again, in your case, you'll see here completely different SHA-1 hash, but commit will be second commit. But we may have multiple branches, and here inside of this file, you don't see anywhere that this branch is current. So back to the question, how Git understands that master branch is current branch? That's where head is used. Head is just pointer to specific branch or specific commit. And head may be only one. There may be multiple branches, multiple commits, but head is always one. It is a pointer to current snapshot of your project. Let's discuss properties of the head in details. Okay, so head is just a reference to the currently checked out branch or commit. First, head is locally significant. It means that if you work in distributed project and you host your project on GitHub, for example, you can move head as you want. It will be moved only locally in your project on your computer. It will not affect in some way remote repository or remote developers. It is locally significant. Next, Git stores this pointer in a file called head in a root of the .git folder. If I'll go to Finder and go inside of the .git folder, you'll see this file here, head, all capital letters. Next, default pointer is refs/heads/master. And this path is already familiar to you, refs heads master. This file stores pointer to last commit inside of master branch, default master branch. Let's actually have a look at this file ourselves. Let's go to command line, let's clear terminal, let's cd to level apps like this, and now we're located in .git folder, and let's list files here, ls-la, and here we see this head file. Let's have a look at contents of this file, cut, head, enter, and here we see just one string, refs/heads/master. And if I'll again look at contents of this file, let's copy this path, cut and paste copied path, enter, we see SHA-1 hash of our second commit. And that means that head in our case at the moment is just pointer to master branch, and master branch points to second commit. That's all. In the next lecture we will create one more commit, master branch pointer will move to this new commit, and head will move of course along with master branch, because contents of head file will not change. It still points to refs heads master file. That's our default contents of the head file. Okay, let's go back to those points. Next, you can easily change position of the head, and you can point it either to specific branch or specific commit. If you want to point head to specific branch, you should use command git checkout and name of the branch. For example, git checkout new branch. And if you want to get back to master branch, you will use git checkout master. You can also move head to specific commit instead of branch. For that, you should use same command git checkout, but now with SHA-1 hash of specific commit. And that means that you are able to move head, for example, to this first commit. And after checking out specific commit, head will point directly to commit, like this. Master will still point to this second commit, but head will point to this first commit. And we will try that, of course, later on. Now let's move on, and next let's create one more commit and observe changes in our project. I'll see you in the next lecture, but please keep in mind all those points regarding head. I'll see you in a moment. Bye bye. Current picture of our project is here. There are two commits, first commit, second commit, two trees, here, and there are three blobs. I have omitted blobs on purpose in order to not overcomplicate this diagram. Master branch is current branch, and it simply points to second commit. Head points to master branch. That's why here in git log output we see this pointer. Head points to master branch. Great. Let's now create one more commit in our project. Let's clear terminal and let's do following. Let me cd to our root folder like this and make sure that you are located here in your first project. Let's list files here, ls-l, and there are three files: file1.txt, file2.txt, and file3.txt. Let's simply delete all those files. And after deleting, we will stage changes and commit them. And after that, we will explore what will change in our repository. Okay, let's do that. rm file1.txt, enter, rm file2.txt, enter, rm file3.txt, enter. Immediately after deletion of the first file, we see this yellow cross sign, and that means that there are changes in our project. Let's have a look at those changes. Git status, enter, and here are three files that are deleted. But those changes are not yet staged for commit. And that means that before committing, we should stage those changes first. Actually, before we have talked about 4 different states of all files in Git. And those states were, for example, here. I told you about untracked, modified, staged, and unmodified states. There is one more state, it is deleted state. And in our case, those 3 files are marked as deleted. And this state is actually very similar to modified state. That's why I have decided not to include it here on this diagram in order to make it simple. In fact, now those files are deleted only in working directory. Again, it is pretty similar to modified state. And now we should stage those changes. And after staging those changes, we will commit them. Okay, let's get back to command line and add files to staging area. And for that, we can use command git add and dot. And dot means that all deleted, modified, or untracked files will be added to staging area. Let's press enter and observe what was changed in the output of git status command. Enter, and here we see that there are changes ready to be committed. And those 3 lines turned now green. And now we are ready to commit those changes. But before doing that, let's quickly switch to GitHub desktop and observe changes there. Here we are. And here we see changes as well. 3 files, and here you see that those files are marked for deletion. File1.txt, file2.txt, and file3.txt. Again, if I'll go to history, we still see only 2 commits here. Actually, we can commit those changes directly here, but let's do that in a terminal. Let's go back to terminal and let's type git commit. And let's now omit -m option. And let's simply type git commit and press enter. Enter. And here you see that default editor, in my case vim, will be opened. And here we need to enter commit message for our changes. Vim editor, from my point of view, is not the best editor in the world. And it is pretty hard to use, from my point of view again. And it has 2 different modes of operation: insert mode and command mode. Default mode is command mode. In order to make changes inside of the file, you should enter insert mode, and for that you should press key I. Let's press it, and now you see here insert mode. And now let's type third commit, like that. Now we should exit from insert mode by pressing escape. Pressed. And now using pretty strange key combination, we can save changes to this file. And this combination is following: WQ. W stands for write and Q stands for quit. Let's press enter, and now changes were written. Here we see result of the operation. We are still on a master branch. Here you see SHA-1 hash of the new commit. Here you see commit message, third commit. And here you see that 3 files were changed. And 3 lines of text were deleted. 1 line per each file. That's what happened after third commit. Let's observe changes in our project after this last third commit, but let's do that after the small pause. I'll see you next. Bye. We have just deleted 3 files from working directory, staged those changes and committed them. And we have created third commit. In my case, SHA-1 hash of this commit is here. And we did it still on a master branch. At the moment there are no changes, and that means that all 3 areas are consistent. I mean working directory, staging area and Git repository. Let's first have a look at the list of commits. Git log. Enter. And now we see 3 commits. Here is first commit. Here. Next comes second commit. Here it is. And last one commit is here. Here is SHA-1 hash. Author, it's again me. And date of this commit, along with time zone. Here you see still same pointer. Head points to master branch. And that proves all what we have discussed in the previous lectures. Current branch tracks all new commits, and pointer of the current branch moves automatically to the last commit. Let's have a look at contents of the head file. Let's close this and let's cut .git/head. Enter, and here we see contents of the head file. And contents remain unchanged. Here we still see reference to refs/heads/master file. And if I'll have a look at this file, let's copy this and cut .git, make sure to add .git folder here, because we are located in first project folder, then slash and paste copied path. Let's press enter, and now here I see new SHA-1 hash, and that is a SHA-1 hash of new commit. It starts with A8 to C, and if I'll again look at git log command, you see this SHA-1 hash here as well. And this again proves that pointer for current branch master has changed automatically, and now it points to last third commit. Let's now use git cut file command in order to read contents of our last commit. Git cut file -p, and here let me copy several characters like this, paste here and press enter. And here we see contents of last third commit. Here is pointer to new tree object. Here is pointer to parent commit. Here are author and committer, same person, and commit message, third commit. Notice that this commit has pointer to parent commit. That's because this commit isn't the first commit in our project, and I have told you that all further commits must have pointer to at least one parent commit. Later on in the course, you'll see that commit may have pointers to multiple parents. Okay, great. That's our contents of last commit object. Let's have a look at contents of this new tree object. Git cut file -p, and here let's paste several characters of this tree SHA-1 hash object. Copy, paste, enter, and here we see nothing, empty output. But if I look at the type of this object, instead of -p I'll use -t, enter, I'll see that it is tree object. But why contents of this object are empty? Please try to answer this question yourself. Answer is pretty simple. We have deleted all 3 files from working directory. Our project is now empty, and that's why this tree object doesn't have any links to any blobs or other trees. And in order to simplify understanding of those changes, I have outlined them in this diagram. So, here is third commit, and it points to this tree. But this tree is empty, it doesn't have any links to any blobs. Why? Because we have deleted all three files. Now our working directory is simply empty. If I'll go to it, you'll see only hidden.git folder, no files at all. And that's why again tree object is empty as well. Here again you see our last third commit. It has pointer to parent commit. Again timeline is here. Here is first commit, second commit and third commit. And we can say that second commit is child of the first commit and third commit is child of second commit. Master branch points to last third commit, and this pointer was changed automatically. And certainly head has moved along with master branch. It still simply points to refs/heads/master file, nothing else. That is a picture of our project now. Let me show you one more thing. Let's go to terminal and let's examine contents of staging area now. Git ls files -s. Enter, and we see nothing. That's because there are no files in staging area now as well. Working directory and staging area are now consistent. There are no files here and no files here. But there are still files, old files in Git repository. And if I'll go to Finder, go to .git folder and open objects folder here, I'll still see bunch of folders here inside. Only two of them were created today, this one and this one. Inside of this folder, Git has created three objects, this one that starts with 4b82. And in your case, SHA-1 hash for this tree object must match with mine, because contents of this tree object are the same. It's empty tree. And another file was created in my case in folder A8. And here Git has created commit object. In your case, this folder and file name will be different because of different SHA-1 hash of third commit. In my case, SHA-1 hash of this last third commit is here, A82C and so on. Please note that all previous files and folders are still in place. And that means that Git stores entire history. All previous trees and blobs are still in Git repository. And we will be able pretty easy and fast go to previous commits and check out previous trees and get access to the files that were actually deleted by last commit. I mean file1.txt, file2.txt and file3.txt. Please observe changes in your repository on your computer, and only when it will become fully clear to you, please move on. In the next lecture, we will try to travel in time and go to previous commits, commit 1 and commit 2. I'll see you in the next lecture. Bye bye. Current picture of our project looks like this. There are 3 commits and 3 trees, and under trees there are 3 blobs. There is master branch, current default branch that points to last third commit. There is also head, and the head points to master branch. And of course, when master branch moves along with commits, head moves with master branch as well. We have discussed what is the branch and what is head. Here are characteristics of each branch, and here are characteristics of head. Please note that the head is only one, but you may have multiple branches in your project. But again, head is only one and it is locally significant. Pointer itself is located in .git/head file, and default pointer is this one. Now we will try to move head, and for that we will use git checkout command. Please note that git checkout command is used when you want to change version of your project. And when you use this command, Git takes specific, let's say, version of the project from Git repository and replaces contents in staging area and working directory. And all what Git actually does under the hood when you enter git checkout command, it just moves head pointer, nothing else. it changes contents of the head file located in the root of the .git folder. Let's now try to take a head pointer and move it, for example, to this commit, to second commit. And for that, we will use git checkout command and pass SHA-1 of this second commit as argument. Let's do that. If you don't know SHA-1 of your second commit, you can find it in multiple ways. First way, you can switch to GitHub desktop, click here on history and click here on second commit. And here in this section, you'll find SHA-1 of second commit. In my case, it starts with 44E0. You can simply copy this SHA-1 and then use it in git checkout command. Next, you can find SHA-1 of second commit in command line in terminal. Let's clear terminal here, and let's first use cut command and read contents of the head file .git/head. Enter. And here let's copy this path, this reference, and let's cut .git and paste copied path. Enter. And here we see contents of the master branch actually, and it points to last commit, third commit. And now I'll take several characters from this SHA-1 and use git cut file -p and paste copied SHA-1. Enter. And now I see contents of third commit. And inside of this commit, we see pointer to parent commit. And it points to second commit. Let's get back to diagram. So here is third commit and here is second commit. Parent for third commit is second commit. That's how you can find SHA-1 of second commit. In my case, it starts with 44E0 and the same SHA-1 I see here in GitHub desktop. Okay. Let me copy several characters from this SHA-1 and now let's clear terminal and let's enter git checkout and paste copied SHA-1 like this. Enter. Command was successful and here I see large node. Node checking out and SHA-1 of the commit, specific commit. And now our head has moved to second commit. And here in command prompt, you see that instead of master branch that we saw before, we see SHA-1 of the commit that we have checked out. And now we are located in detached head state. What does it mean? Normally, head points to the branch, and before this action, head has pointed to master branch like that. But now head points directly to specific commit, not to the branch. And this state is called detached head. When head points to specific commit instead of pointing to specific branch, this state is called detached head state. And here you see that we can look around, make experimental changes and commit them, and we can discard any commits we make in this state without impacting any branches by performing another checkout. This looks complicated, but pretty soon I'll show you what it means. In this state, detached head state, we will not do any commits at the moment, but we will try it later on. And we will see what will happen if we will get back to specific branch instead of detached head state. In this detached head state, we can also create new branches and retain commits that we create in detached head state. We will try that as well later on. Okay, so now head is pointing to this SHA-1 to second commit. And let's examine contents of head file in .git folder. Cut .git/head. Enter, and we see just SHA-1 of specific commit. Please note that before this action, before checking out specific commit, contents of head file were like this: ref:/refs/heads/master, and that was reference to master branch. Now it is reference to just single commit, second commit. But let's now examine what happened with master branch. Is it the same as before or not? Let's go back to terminal and go to history. Somewhere in history we have command cut.git refs/head/master. Let's enter this command and we see that contents of this file, master file in ref/heads, remained unchanged. master branch still points to last commit, this one. And it means that git checkout command doesn't do anything with branches. It just moves head pointer, nothing else. Let's now examine what happened with working directory and staging area. Let's go back to terminal and let's simply list files in our first project, in our working directory, ls-l. Enter, and we see 3 files again. Before our project was empty, but after checking out specific commit, we see 3 files. And that means that we have moved to another version of our project, to this tree that contains 3 links to 3 files. That's how this works. By simply moving this pointer, we move to specific version of our project, to specific snapshot. We can check also contents of staging area, git ls files -s. And we see 3 files here as well, file1.txt, file2 and file3.txt. And that's great. That shows you git checkout command in action. It has replaced contents of staging area and working directory. And now contents of those areas are the same. Great. Let's now try to check out first commit. And in order to find out SHA-1 of first commit, again, we can switch to GitHub desktop and click here on first commit and see SHA-1 here. Or we can use git cut file command, git cut file -p, and use this SHA-1 of second commit. Paste, enter, and here we see SHA-1 of first commit. And in my case, it starts with 6fb7. Recap that first commit is parent for this second commit. But let me get back to GitHub desktop for a moment before checking out first commit and show you something. Notice that now in history we see only 2 commits, first commit and second commit. Last third commit has disappeared. That's because now we see our project from perspective of this pointer, of this head. It sees this second commit, this tree under this commit, and it sees parent of this commit. It does not show us next commits that were made after this current second commit. And this means that moving this pointer between different commits or branches, we are traveling, let's say, in time. And if I'll get back to terminal and enter here git log command, I'll see only 2 commits, first commit and second commit. And here we simply see head without pointer to any branch, and that again means that we are located in detached head state, when head points just to single commit. Okay, let's now check out first commit. Actually, I can take SHA-1 of this commit from this section. Let me copy a few characters from this SHA-1, close this, and now let's check out first commit. Git checkout and paste copied SHA-1. Enter. And here we see that previous head position was at this second commit, and now head is at this commit, our very first commit in the project. Let's have a look at contents of head file, cat.git/head. Enter. Here I'll see simply SHA-1 of the very first commit. And that means that we have moved head to our very first commit like this. Okay. So head is now pointing to first commit in our project, and this commit is a wrapper of this tree that has 2 links to 2 blobs. It means that now contents of working directory and staging area should be replaced again, and I should see just 2 files in working directory. Let's get back to terminal and list files here again, ls-l, enter, and yes, here it is, there are just 2 files. Git ls files -s will show us contents of index, and here we see 2 files as well. And again, staging area and working directory are consistent. In those parentheses you also see change. Here we saw SHA-1 of second commit, now we see SHA-1 of the very first commit in our project. And if I'll enter git log command, I'll see only single commit in history. And that's because head points now just to first commit. It does not see all further commits. That's how it works with git checkout command. You can pretty easily and fast travel in history and change versions or snapshots of your project. Now let's get back to master branch and move head pointer back to master, as it was before at the beginning of this lecture. And for that we can simply use git checkout command and pass master name of the branch as argument. Let's go back to terminal, close this, Ctrl Z, let's clear terminal as well, and type git checkout master. Enter, and here we are, we have switched back to branch master. Previous head position was this one, it pointed to very first commit, to this commit, and now head points again at master branch. And if I'll enter git log command now, I'll see again all 3 commits. And same output here in parentheses, head points to master branch. Let's have a look at contents of head file again. cat.git/head. Enter, and contents are the same as before. It is reference to refs/heads/master. And this contains pointer to last commit. cat.git/paste copied path, enter, and here is SHA-1 hash of the last commit. If I'll open up GitHub desktop, I'll see all 3 commits here again. And I see that current branch is master. Okay, wonderful. That's how you can pretty easily switch between different commits and branches using git checkout command. At the moment you see that the history of the changes in our project is just straight line. There are 3 commits in a row. And we can just move head pointer between those 3 commits. Now it's time to explain you why do we need actually branches, how we can use branches, and of course we will try to create a new branch in practice. Let's start talking about that in the next lecture. I'll see you there. Bye bye. In this lecture I would like to explain you purpose of the branches and actually reason for using branches. But before doing that, let me quickly recap what is actually branch. Branch is just text reference to specific commit, and we have discussed that before. Default branch is master, and of course multiple branches can exist in the same repository. Next, all pointers for all branches are located in .git/refs/heads folder. And inside of this folder you'll find multiple files if you have multiple branches, and every file will have same name as branch. Next, current branch tracks new commits, and branch pointer moves automatically after every new commit. And you can check out specific branch by using git checkout command, and here type simply name of the branch, for example master or experimental or temporal or new branch or dev 1512. You can check out any existing branch. But please note that when you create new branch you cannot use spaces in the name. Use, for example, dashes instead. Okay, that's what is branch. But why do we actually need branches? Let's have a look at this diagram. Let's suppose that you are working on your master branch, and here you see commits made in master branch. But now at some point of time, please notice that timeline is here. So here you see more older commits, and here to the right more recent commits. And let's suppose that at a specific moment of time, for example here, you decide to work on a specific feature, but you don't want to implement this feature directly in master branch, because, for example, you're not sure whether this feature will remain in your main project, and let's say that master branch is our main project. And at this moment of time, for example here, you decide to create new branch with name BR102, and you start working in this branch. And recap that all commits are made in current branch, and if this branch BR102 is current branch, those commits will be made only in this branch, and master branch will remain intact. But parallel after making this branch, someone else or you may continue working in master branch. And for example, here and here you see commits that were made after creation of this BR102 branch. And notice that, for example, this commit and this commit were made on different moments of time. That's because now those two branches, BR102 and master, are independent, and you can make commits in those two branches at any moments of time. In the same way, we can create another branch, for example, a branch called EXP, experimental. And this branch was created at this moment of time, after this commit in master branch. And here you see commits made in experimental EXP branch. And again, this branch EXP is completely independent from master branch and BR102 branch. And commits made in this branch don't match in time with commits made in other branches, master or BR102. More than that, this branch EXP doesn't even know about presence of other branches, because you know that each branch is actually just text reference to specific commit, nothing else. Branch simply stores SHA-1 hash of specific commit. That's why branches are completely independent from each other. Here you see branch that was created on the basics of other branch. For example, here after this commit, inside of the branch BR102, you decided to perform some tests and create other branch based on this branch. And here you have created branch called temp. And you can make some commits inside of this branch, test some features or something like that. And when you are done with your experiments, you can simply delete this temporal branch. And all commits will be deleted as well. And picture will be like that. Okay, that's what are branches. And in simple words, we can say that every branch is actually separate history of your project. So here is one line, here is another line, here is main line, let's say, it's a master branch, and here is one more line. And you can develop different features in parallel. More than that, if multiple people are working on the same project, they can work in separate branches and they can do their job completely independent from each other. And when specific feature is ready and it is tested and verified, corresponding branch with its commits can be merged, for example, into master branch. We will discuss how to merge branches later on in the course. For now, please keep in mind that every branch is actually separate history line of the project, or let's say separate story. And my recommendation to you, please be consistent in naming conventions for all branches, and if you decide to name branches like this, please use such names for all branches. Or you can use self-explanatory names for the branches. For example, you can create a branch with name, let's say refactor main menu, like that. And this branch name clearly tells other developers what is the reason for this branch. Okay, that's how you can name branches. Next, you see here head pointer, and you know that the head can be only one. There are multiple branches on this diagram, but head pointer is just one. And at the moment it points at experimental branch EXP. This experimental branch is wrapper for this commit. And you know that underneath this commit there is a tree with blobs and probably other trees. And that means that at this moment of time your working directory contains files and folders based on a tree object underneath this commit. And of course you can easily change version of your project and move to another branch. For example, you can check out branch master. And after checking out, for example, master branch, your head pointer will move to this location. And now this version of the project that this commit points to will be checked out to your working directory and staging area. You can also easily check out other branches, for example, move to this branch, or move back to experimental branch, and so on. And for that you can use git checkout command. And in the previous lecture, we have actually checked out different commits. And that's not a preferable way to change versions of your projects. And that is actually another reason for using branches. When you use branches, you don't need to remember SHA-1 hashes of specific commits, for example, this one, or this one. And you can check out different commits simply by using branch names that are wrappers for those corresponding commits. For example, master branch is wrapper for this commit, BR102 branch is wrapper for this commit, and so on. That's how you can change versions of your project using human-readable text names. And recap that, of course, you can check out specific commit, but in such case, when head points to specific commit like this, we allocate it in so-called detached head state. And it's not recommended to create new commits in detached head state. But if you do so and after committing changes move back, for example, to specific branch, those commits that were made in detached head state will be lost and deleted automatically by Git. And you will be able to return to those commits. That's why in most cases head is reference to specific branch, not commit. And again, you can pretty easily change branches by using git checkout command, and after git checkout simply type name of the branch you want to check out. Okay, quick summary. Every branch is, let's say, separate story of your project. And you can create commits in different branches in parallel. And branches greatly simplify collaboration process when multiple people work on the same project. For example, I can create branch called BR102, make one or two commits in this branch, and after that my coworker may continue working on the same branch and create other commits. But of course, for that we need to distribute our repository among different computers. And for that you can use Git hosting services like GitHub or Bitbucket. And another advantage of using branches is actually their text names. You don't need to check out specific commits by remembering their SHA-1 hashes. You just need to remember branch name and check out specific branch by its name, for example, temp, master, or exp. Okay, this lecture was relatively large, and in the next one, let's finally dive into the practice and create another branch in our project. Please recap that at the moment we have only one default master branch and we have committed our changes 3 times. And that means that there are 3 commits. This one, and this one. Okay, I'll see you in the next lecture. Bye.
Still watching? Please leave a like and don't forget to subscribe and leave a comment.
Let's finally dive into the practice and let's create a new branch in our project. And before that, let's quickly overview most commonly used commands for branches management. First command, git branch. This command lists all local branches. And currently checked out branch will be marked in this list with asterisks. Next command, git branch and name of the branch. This command will create new branch with corresponding name. And please note that you're not able to use spaces in branch name. Next command, git checkout and name of the branch. You are already familiar with this command and it allows you to check out specific branch or commit. If you specify here name, it will check out specific branch. If SHA-1 hash, it will check out specific commit, and you will move into detached head state. Next command, git branch -d and name of the branch. This command will delete specific branch. But please note that with this option, lowercase d, you will be able to delete only merged branch. If branch wasn't merged, you will be able to do that with -d option. And for that, you should use force delete with capital D. No worries, we will try that in action pretty soon. And if you want to rename a specific branch, you can use -m option. And with this option, first you need to specify old name of the branch or current name of the branch, and after space, specify new name of the branch. Okay, that's our most commonly used commands for Git branches management. But there is one more command that I wanted to show you here, and it is this one. Git checkout -b and branch name. This command is actually a shortcut for creating a branch and checking it out automatically. And all what you need to do is to add here option -b in git checkout command. And notice that if you use -b option, this branch that you specify here should be absent at this moment. And only in this case, this branch will be created and automatically checked out. And that means that this command simply combines those commands: git branch and name of the branch, and git checkout and name of the branch. And I recommend you to use this command when you are going to create new branch and immediately go into that branch and do some changes. Okay, that's all for most common commands that are used for Git branches management, and in the next lecture, let's create another branch in our project. I'll see you in a moment. Bye bye. In this lecture, we will dive into the practice and create new branch. But we will not make any commits in that new branch. We will simply create new branch, check out this branch, and after that delete that branch that we have just created. Let's do that now. Let's go into command line, and here let's use git branch command first. Git branch, enter, and here we see list of current branches, local branches. At the moment there is only one default current branch, and it is master. And notice that currently checked out branch is marked with asterisk. Okay, let's close this list. And now let's create new branch called temporal branch. Git branch and simply name of new branch, temp. Enter, and new branch was created, but we still remain in master branch. This command git branch and name of the branch doesn't automatically check out newly created branch. But if I list branches now, git branch, enter, I'll see two branches on a list, master and temp. And currently checked out branch is still master. Okay, let's close this. Let's now have a look at the contents of the refs/heads folder. I mean this one, ls.git/refs/heads. Enter, and here we see now two files, master and temp. Recap that those files contain actually pointers to specific commits. And you know that every branch is simply a wrapper for commit. Let's explore contents of those files. cat.git/refs/heads/master. It's pointer for master branch. Enter, and here I see SHA-1 hash of the third commit. And now let's have a look at contents of the temp file. Let's replace master with temp like this. Enter, and contents of the temp file are the same as of master file. And that means that newly created temp branch points to the same commit as master branch. It is the last third commit. And that is important. It means that when you create new branch, it will be based on the last commit on current branch. Notice that we have created new temp branch while we are working on master branch. And that's why this temp branch was created based on this branch. And that's why pointers here match. Okay, that's how temp branch looks like. Now let's have a look at contents of the head file, cat.git/head. Enter, and here we still see reference to refs/heads and master. And that's because currently checked out branch is master branch. Let's now check out this temp branch. Git checkout temp, simply name of the branch. Enter, and here you see message switched to branch temp. And here you see this new branch name in a parenthesis as well. And that means that head pointer has moved to newly created branch. And if I look at contents of the head file again, cat.git/head, you'll see new reference, ref:/refs/heads/temp. And that's all what happened under the hood when we checked out new branch. Git has simply replaced contents in a head file, and now it points to refs/heads/temp. But if I look again at contents of the branch itself, let's go to history to this command, enter, I'll still see SHA-1 hash of the last third commit. And that's because we have not yet created any commits in new branch. It's still same as before, points to this commit. Okay, let's now get back to master branch. Git checkout master. Enter. And now we have switched to branch master. And if I look at contents of the head file again, I'll again see reference to master branch. That's how you can pretty easily and quickly change branches. And under the hood, Git just replaces contents of the head file. Okay, and that means that after creation of the new temp branch, our picture of the project looks like this. Here is this diagram. Here are 3 commits, first, second, and third. Here is pointer to last commit and it is master branch. Head points to master branch. And here is newly created temp branch that is wrapper again for the same commit as master branch, third commit. And we have just observed it in the command line. That's how picture of our project looks like now. In this lecture we will not create any new commits in this temp branch, we will simply delete it. But before deleting, let's actually try to rename it. Let's go back to command line and type here git branch -m, and here name of the branch temp, and here will be new name for this branch, new-temp. Enter, and branch was renamed. Let's list branches, git branch, enter, and here now we see new name for the branch, new-temp. And we can of course check out this branch, git checkout new temp, enter. Now we have switched to new temp branch, and let's check out master branch back, git checkout master, enter. And we have switched back to master branch. Okay, great. Now let's finally try in action delete option, git branch -d lowercase d, and type here new-temp, enter. And branch with name new-temp was deleted. And here you see that this branch was actually wrapper for this commit. Notice that Git allowed us to delete this branch with option lowercase d. But I have told you that with this option you are able to delete only merged branches. But in our case we didn't make any new commits inside of this new temp branch. That's why Git has successfully deleted this branch. We didn't lose any information, any new commits that were made inside of this branch. Okay, let's now list branches again. Git branch, enter, and now we again see only one master branch. Okay, let's close this. We have tried most commonly used operations with branches, and in the next lecture let's create branch again and let's make new commit inside of the new branch. Let's do that after the small pause. I'll see you in a bit. Bye. Now we have deleted temp branch, and in this lecture let's create another branch called br-1. And after creation of new branch we will check out this new branch and then create new commit. Of course we will change some files in our Git repository. Let's do that. Let's clear terminal and let's ensure that we are on master branch and there are no other branches. Git branch, enter. So here is just single branch master and it is current. Let's close this and let's create new branch. And now let's use shortcut for creation of the branch and checking it out. For that let's type git checkout -b, and here I'll type name for new branch, br-1. Enter. And you see that new branch br-1 was created and we have automatically switched to this new branch. And now we are in branch br-1. Let's list branches now, git branch, enter. And now I see that current branch is br-1. Okay, let's close this and let's make some changes in our Git repository. At the moment, if I list files in our working directory, I'll see nothing. That's because in our last commit we have deleted all 3 files in our repository. Let's now create file with file name file4.txt and with contents hello, git. Recap that we have already created before such file with contents hello git. Let's do that again, but inside of the file with another name. And let's see what will happen in Git repository. Let's do that. I can use echo command, echo, here type hello, git, greater than sign, it will create new file and write this string, this file. And here will be file name, file4.txt. And let's press enter. Now we see that there are uncommitted changes. This yellow cross sign means that. And let's have a look at contents of our working directory, ls, and here I see single file, file4.txt. Let's have a look at contents of this file, cut file4.txt, enter, and here I see hello, git. Let's now look at the status of our Git repository, git status, enter, and here you see that there is untracked file, file4.txt. And we need to add it first to staging area and after that commit changes. Let's do that. Git add, and let's here type file name, file4.txt, enter. Now this file is ready to be committed, git status. And yes, here it is, changes to be committed, and here is new file. And now let's commit those changes. And notice that I will make commit while I'm working in BR1 branch. And remember that current branch tracks new commits. And that's why this new commit that I will make now will be created in the branch BR1. Let's do that. Git commit -m. Here will be commit message. And let's add description first commit in the BR1 branch. Like that. Enter, and changes were committed. Here you see branch name BR1. Here you see SHA-1 hash of new commit. Here you see commit description, first commit in a BR1 branch. And you see that one file was changed and it was created with file4.txt file name. Okay, we have just committed changes in a new branch, BR1. Let's have a look at git status again. Git status, enter. And here you see that we are still on branch BR1 and there is nothing to commit. Working tree is clean. And in working tree there is single file. Let's list files here. It is file4.txt. And if I list contents of staging area, git ls files -s, enter, I'll see this single file, file4.txt. And that means that now working directory, here, staging area and Git repository are consistent. Let's explore contents of Git repository after this commit, but let's do that after the small pause. I'll see you in a bit. Bye bye. We have created new branch BR1 and we have created first commit in this branch. And the description for this commit is here, first commit in the BR1 branch. Let's now explore changes in Git repository. And let's start by looking at git log output. Git log, enter. And here now I see 4 commits, starting from our very first commit in the project. Then comes second commit, third commit, and first commit in the BR1 branch. That means that inside of the BR1 branch we see entire history of all commits made before. Also here you see that head now points to BR1 branch. That's because we are now located in BR1 branch, we have checked out it before. Okay, let's now examine commit object that was created in a Git repository. And SHA-1 hash of this commit object is actually here. Also, we can take SHA-1 hash of this last commit from git log command. Let's enter it again, and here is this SHA-1 hash. Let me copy a few characters from it, close this, and let's use git cut file command, git cut file, -p, and let's paste copied SHA-1 hash. Enter, and here we see commit object. Here is pointer to tree object, here is pointer to parent commit, here is outer committer, same as before, and description of this commit, first commit in the BR1 branch. Okay, Let's closely look at the parent string, this one. What is a parent for this commit? How do you think? Parent is of course third commit. And remember that we have created br1 branch from master branch at the moment when we have made third commit. And that's why parent for this first commit in a br1 branch is of course this third commit. Let's quickly have a look at this commit. Git cat file -p, and let's copy several characters from this SHA-1 hash, paste, and yes, of course, it is third commit. Let's also switch to GitHub desktop and explore changes there. Notice that here now current branch is br1, and here in a dropdown we see other branch master, and we can actually easily change branch here in GitHub desktop. Let's try that. Choose master, and we have switched to master branch. If I'll get back to command line and press enter, you'll see that we are now in master branch. Let's get back to GitHub desktop and let's get back again to br1 branch. Just click on this drop down and click on the branch you want to check out, this one. And let's click on history here, and now you see here 4 commits. And last commit is first commit in the br1 branch, and here we see that in this commit file 4.txt was added, and here we see contents of this file. And here, same as before, we see SHA-1 hash of this commit object. Okay, let's go back to command line and let's have a look at contents of head file. cat.git/head. Enter. And now we see that head points to refs/heads/br1. And that is correct. That's because we have checked out br1 branch. Okay, let's observe those changes on this diagram. So, here are all previous commits, first, second, and third. Those commits were made on master branch, and here is master branch. It is still on third commit. We can actually verify that. Let's get back quickly to command line and cat.git/refs/heads/master, enter, and here we still see SHA-1 hash of third commit. Let's go back to diagram. Okay, at this moment of time we have created br1 branch, and br1 branch pointed to third commit. Picture was like this. After creation of br1 branch, we have checked out this branch and head has moved to br1 branch. And after that we have created new file 4.txt, and committed changes. And that's why now picture looks like this. There is new commit object, this one, here is SHA-1 hash in my case, here is pointer to third commit, it is parent for this commit, and now br1 branch points to this commit, it is wrapper for this new commit object. And of course, head has moved along with br1 branch. That's because currently checked out branch is br1 and head is reference to this branch. And you know that current branch tracks all commits and pointer moves automatically. That's how it looks at the moment. But let's now examine blobs and trees that were added to our Git repository after this fourth commit. And let's do that after the small pause. I'll see you in a bit. Bye.
Just checking, did you smash like button? Yeah? Okay, you are good to go.
Let's continue exploring changes in Git repository after fourth commit, first commit in br1 branch. Here above we have seen contents of commit object that was made in br1 branch. And here is pointer to tree object, and here is its SHA-1 hash. Let's copy part of this SHA-1 hash and let's explore contents of the tree object. Git cat file -p and paste copied SHA-1 hash. Enter, and here are contents of this new tree object. And here we see link to one blob. Here is a name, file name for this blob, and here is SHA-1 hash for this blob. Let's have a closer look at this SHA-1 hash. Did we see it before or not? Of course, we have seen that, and we have seen that in the very first commit in our project. Let's go to Finder actually, and let's explore contents of the objects folder. And notice that Git has created two folders, this one and this one, today. Inside of this first folder starting with 0b, Git has created actually this tree object we are exploring now. SHA-1 hash starts here with 0b, 7a and so on. And inside of this folder, 28 in my case, Git has created commit object. We can look at it again, git log, and here is SHA-1 hash for this commit object. It starts with 285b, and that's what I see here, folder 28 and file that starts with 5b. But there is no third file that was created here in Git repository. Git has created only two objects, here and here. Let's have a look at this file with this SHA-1 hash, starting with b7ae. Let's go back to Finder, and here is this folder, b7, and here is file inside of this folder. And you see that this folder was created several days ago in my case. And this folder contained blob with hello git string. Actually, we can prove that. Let's go back to command line and use git cut file -p. Actually, let's check type first, and let's copy this SHA-1 hash, paste here, enter, and yes, it is blob. And let's now explore contents of this blob. Instead of -t, let's type -p, enter, and yes, we see hello Git. What does it mean? It means that Git has reused existing blob. Even if file name is different, we have created new file, file4.txt, with same contents as file1.txt that we have created before. In order to fully clarify what happened here, let's have a look at this diagram where I have shown all commits that are created at the moment, all trees and all blobs. Here is first commit made in br1 branch, here is tree object that this commit points to, and here are links in this tree object. This tree object points only to one file, file4.txt. And contents of this file are the same as contents of the file 1.txt, this one. That's why Git has simply reused existing blob, even if file name is different. That's because file names are stored in the trees, and there is no need to create new blobs with same contents. More than that, you know that every file that is created in objects folder has file name that is based on SHA-1 hash of the contents of the blob. And if contents are the same, SHA-1 hash will be the same as well. And in your case, SHA-1 hash for this blob should be the same as here. It starts with b7ae. And again, Git has simply reused this blob even if file name is different. And if I'll check out this first commit, you'll see same SHA-1 hash in this tree that starts with b7ae. Let's actually do that quickly, and let's quickly check out this first commit. Let's go back to command line, type here git log, enter, and let's copy SHA-1 hash of this very first commit. Copy, close this, and let's check out this commit. Git checkout, and paste copied SHA-1 hash. Enter. We are in detached head state now. Here is SHA-1 hash of this commit. And let's list files in working directory. ls, enter, and here I see file1.txt and file2.txt. Let's have a look at contents of file1.txt. Enter, and here I see hello Git, of course. Let's observe contents of this commit object. Copy its SHA-1 hash, git cut file -p, paste copied SHA-1 hash. Here is pointer to tree object. Let's copy this SHA-1 hash and explore this tree object. Git cut file -p and paste copied SHA-1 hash. Enter, and here are two pointers to two blobs, file1.txt and file2.txt. And here you see exactly the same SHA-1 hash as we have seen for file4.txt in the last commit. And that proves that Git has simply added pointer to existing blob. Let me show entire picture like this, and let's summarize. We have created new branch, br1, and we have made first commit in this branch. And Git has created in Git repository commit object, this one, and this tree object. But Git has reused existing blob object, this one. That's because contents of file4.txt are the same as contents for file 1.txt that was created here at the beginning of our project. Now we have two branches in our project and we can easily switch between those two branches and create different commits in different branches. Let's go back to command line and let's actually check out again br1 branch, because now we're located in the detached head state. Git checkout br-1, enter. And now we are again at br1 branch. Let's list files in working directory, ls, enter, and now I see only one file, file4.txt. Let's change branch to master, git checkout master, enter, and let's list files now, ls. And I see nothing. That's because in last commit, third commit in master branch, we have deleted all files from working directory. And that's how you can easily change versions of your project. Here is version in br1 branch and here is version in master branch. Okay, now you know how to create new branches, how to create new commits inside of the branches, and how to check out different branches and commits. Now it's time to move on to the next section, where I'll show you how to clone remote repositories and how to explore real-world projects created by other people. Let's talk about all of that in the next section. I'll see you there. Bye-bye. Git is used by millions of people in the world, and there are many public repositories. And you are able to clone to your local computer any public repository. And that's what we will do here in this section. We will find one of public repositories, then clone it to our local computers, and then make some changes and commit changes. Of course, if you don't have right access to public repository, remote repository, you won't be able to push changes, but you are able to commit them locally. Also, we will install additional program called Visual Studio Code that is actually editor that allows you to edit text files pretty fast and easy, and also it has built-in Git support. Also, we will explore cloned repository in GitHub desktop. Let's get started. In the previous sections, we have explored basics of Git, and we have used our local Git repository with several sample files. But in this section, let's have a look at real-world projects and let's explore real Git repositories. And of course, we will examine commits history, examine blobs, trees, and so on. You know that GitHub is a hosting service for Git repositories, and many people host their open source projects that are available for use. That's why now we will find one of the popular Git repositories, we will clone it to our computer, and after that explore contents of this Git repository. Please navigate to github.com, then explore menu, and here choose collections, this one. And here let's have a look at Learn to Code collection, this one. Let's click on it. And here we will see popular repositories in this collection, Learn to Code. Near every repository you'll see amount of stars that this repository has collected, and more popular repositories have more stars. Also, you'll see how many people have forked this repository. We will talk about forking repository later on in the course. Also, you'll see tags. For example, here you see JavaScript tag, here is HTML tag, here is Ruby tag, and so on. Every repository is created under specific account. For example, here you see account named 30 seconds and repository name is 30 seconds of code. Here account name is Rails Bridge and repository name is docs. Please scroll down and find this repository named Hello World. This repository contains Hello World in every computer language. Let's try to clone this repository to our computers and let's explore its contents. Let's click on it, scroll down, and here you'll see that there are more than 1,000 commits made in this repository. There is a single branch and there are almost 300 contributors. Here you see license. Mid license is one of the open source licenses. Here you see contents of this repository and we are able to clone or download this repository. You see that current branch is master actually and it is a single branch in this repository. Let's click on clone or download button. And here you'll see several options. Clone with HTTPS, open in desktop and download zip archive. Let's first try to download zip archive and click on this button. Click. And file was downloaded. Let's click on it, unzip it, and here you'll see Hello World Master folder. Let's dig into this folder, and here you'll see bunch of files. But if I'll try to show hidden files and folders by pressing Command Shift and Dot, I'll see only git ignore hidden file. I don't see .git folder. Let's actually try to explore this folder in command line. For that, let's go to command line, open new tab here, Command T, and cd, and after cd, just drag folder to terminal, like this. And after dragging, let's press enter. Now I'm located in this folder, and let's list files in this folder, ls-la. Enter. Let's scroll up, and again, I don't see .git folder in this repository. I see bunch of files, for example, license file, readme.md file, bunch of folders, and so on. But again, I don't see hidden .git folder. It means that if you choose download repository option here, not clone, you will not copy entire Git repository and you will be able to check out different branches and different commits. That's why we should use clone option instead of download option. If you want to clone repository, you should copy this URL here, click on this button, URL was copied, and after that you should use git clone command. Let's go back to terminal, and here let's cd to our root folder, cd, and cd to desktop from here, cd desktop. Enter. Let's clear terminal, and now let's clone remote repository. Git clone and paste copied URL like that. You see that URL points to github.com, here is username, and here is name of Git repository, helloworld.git. Let's press enter and see what will happen. Enter. Cloning into Hello World. Here you see output for cloning process, and here is amount of objects that were received, and now new folder was created on a desktop. Let's list files on a desktop, ls, enter, and here now I see two folders. Our first project folder and Hello World folder. Let's cd to newly created Hello World folder. cd Hello World. Enter. And here immediately we see that this folder is under Git control and we are located in master branch. And that is a good sign. Let's now list files including hidden files and folders, ls-la. Enter. And scroll up. And now, along with files in working directory, I see hidden .git folder. Let's explore contents of this Git repository, but let's do that after the small pause. I'll see you in a bit. Bye-bye.
You know what? Watching long videos here at YouTube is not really convenient. That's why I recommend you to enroll to the full-length course, link is up in the description below. And in this course, all lessons are split into different videos and are organized into different sections. I'll see you in that course.
We have just cloned remote repository, and after cloning, Git has automatically created new folder, Hello World, and if you cd to this folder, you'll see that this folder is under Git control, and current branch is master branch. Let's now explore contents of this Git repository. And first, let's have a look at git log output. Git log. Enter. And here you'll see bunch of commits in commit history. And commits are made almost every day. In every commit you see as usually commit SHA-1 hash, for example here. Also you see merge line, we will talk about that later on in the course. You'll see author of every commit, for example this commit was made by Mike Donaghy. Here is date of commit and here is time zone. Also here you see description of this commit. And most commits here are merge commits. Here you see two SHA-1 hashes. And that means that someone else has created pull request. We will talk about pull request again later on in the course. and Mike Donaghy has merged specific pull request into master branch. That's why author of all commits is same person, Mike. Okay, let's scroll up and here you'll see that head now points to master branch. Let's close this, Ctrl Z, and let's have a look at contents of head file. cat.git/head. Enter, and here you see same picture as we have seen in our project. Contents of head file are default, and here you see reference to refs/heads/master. Let's have a look at contents of this file. cat.git and paste copied path. Enter, and here you see SHA-1 hash of the last commit in history. If I'll enter again git log, you'll see same SHA-1 hash here at the top. Let's copy part of this SHA-1 hash, copy, close this, and let's use git cut file -p and paste copied SHA-1 hash. Enter, and here you see description of this commit object. Let's scroll up, here you'll see tree, here you see two parents instead of one, here you see author, here you see committer, and notice that author and committer are different in this case. Committer is GitHub, no reply at github.com. Here you see PGP signature, and below you'll see description of this commit. Merge pull request number 505 from this user, this branch master, and here is commit message. modiscript.chai was added. And again, this commit was made by another author. Mike has just merged those changes into this project. Again, we will discuss all of that later on in the course. For now, let's try to explore what we know so far. Here we see commit object, and here is pointer to tree object. Let's have a look at contents of this tree object. Let's copy several characters from its SHA-1 hash, like that, and let's git cut file -p and paste copied SHA-1 hash. Enter, and here you see tree object, and it contains bunch of blobs and other trees. This information is already familiar to you. Every line contains 4 fields. Permissions, then type, either blob or tree, then SHA-1 hash of specific object, and then name of the object. For example, here on this line, we see link to the blob. Its permissions are set as for executable file. Here is its SHA-1 hash, and here is name for this file. On the next line, we see link to another blob. Here is its SHA-1 hash, and here is name of the file, readme.md. On this line, for example, we see link to the tree object. Permissions for trees, as you know, are always 0, 4 and 4 zeros. Here is SHA-1 hash of this tree object, and here is name for this tree object. It is actually name of the folder. We can take this SHA-1 hash, let's copy it, and let's have a look at contents of that tree object. Git cut file -p and paste copied SHA-1 hash. Enter, and here are contents of this tree object. And here you see bunch of blobs. Let me make it smaller a bit like this and scroll down. And here you see same picture. Permissions, type, SHA-1 hash and file name. Let's for example have a look at contents of this blob. Let's copy its SHA-1 hash and git cut file -p and paste copied SHA-1 hash. Enter, and here we see contents of this blob. It is actually text file, and it contains instructions on how to print hello world in specific programming language. Let's have a look at contents of another blob, for example, this one, in awful language. Let's copy this SHA-1 hash and git cut file -p and paste copied SHA-1 hash. Enter, and this file is much more shorter and contains just 2 lines of code. Okay, you can spend some time on your own and explore contents of other blobs and trees. Now let's list again files and folders in this project. ls. Enter, and here you'll see such files as contributing.md, license, readme.md, and bunch of folders with short names A, B, C, D, E, F, and so on. Let's read license file, for example. Let's copy its name and use cut command and paste file name like that, And here you'll see license for this repository. It is mid license, copyright, Mike Donaghy, and here is description of this license. Let's have a look at other file, for example this one, listlangs.py. Let's copy it, cut and paste name of the file, enter. And here are contents of this file. It is actually executable Python file. Okay, let's now open this project in Explorer and have a look at objects folder in .git folder. Let's use open dot command. On Windows, please type explorer dot or start dot. Let's press enter. And here I'll see contents of the hello world folder. Let me make it larger like that, and let's go into .git folder. And here let's open objects folder. And here we see only two folders, info and pack. We don't see a bunch of other folders that we have seen in our project. The reason for that is simple. Git has optimized this repository. And all Git objects are located in a pack file, here in pack folder. You see that its size is 2.5 megabytes. And here this file with extension .idx contains index for Git objects. And that is internal optimization for space saving purposes. We can actually unpack this Git pack file, and after unpacking you will see a bunch of folders inside of the objects folder. Let's do that, but after the small pause. I'll see you next. Bye bye. We have just discovered that in a cloned repository, Git stores all objects in the objects folder in a pack file. It is actually archive that saves space. Also, along with pack file, there is index file with extension .idx. Now let's try to unpack this pack file. In order to do that, we need to move out from the pack folder this pack file, and after that use git unpack objects command. I'll simply drag this file and move it, for example, to .git folder here. After that, I'll cd to .git folder here in command line, like that. And then I'll use cut command. And here I need to type name of the pack file. Its name starts with pack-a1. I can start typing here, pack dash, and press tab, and terminal will autocomplete file name. Then I'll pipe output from this command to another command, git unpack objects. Let me make actually font size larger, like this. And again, this command will output contents of the pack file to git unpack objects command. We use here pipe for that. And after this command, Git should unpack objects located in a pack file into this objects folder inside of the .git folder. Let's press enter here and see what will happen. Enter. Here you see process of the unpacking, and it is done. Git has unpacked almost 4,000 files. Let's have a look at the contents of the objects folder again. And here we are, we see a bunch of folders inside of the objects folder. And this structure is already familiar to you. Let's have a look at contents, for example, of this folder. And here you see a bunch of other files. And you know that all those files contain either blobs or trees or commit objects or annotated text. Let's explore this folder, for example, and same picture here, bunch of files inside of it. Let's have a look at this folder, same picture here. Okay. That's how objects folder looks in a real repository. Remember that maximum quantity of such folders inside of the objects folder is equal to 16 multiplied by 16. 16 is quantity of hexadecimal characters. And here are two places, that's why we multiply 16 by 16. And it is equal to 256. Let's actually count quantity of folders inside of this folder. Let me minify this folder. And let's select all folders except info and pack, like this. Look at the properties, and here we see that this project contains maximum possible quantity of folders, 256. That's because it contains a lot of files in different folders, and it contains also a bunch of commits. That's how objects folder looks in a real project. Okay. In order to keep .git folder clean, let's remove this pack file because we don't need it anymore. Just rm pack dash tab File name was auto-completed. Here confirm deletion, enter. Let's list files here in this folder ls. And this file is still here. It is probably due to permissions. Let's use rm command with f option, -f, and remove same file. Pack, -tab, and press enter. And now file should be removed. Yes, it is absent now. Okay, we have unpacked pack file, and now you see bunch of folders inside of the objects folder. And those folders contain different Git objects such as commits, blobs, and trees. Okay, now let's move on, and in the next lecture, let's explore this project in GitHub Desktop. I'll see you in the next lecture. Bye-bye.
Just friendly reminder, now it's the best time to become my subscriber, smash a like button and leave a comment under this video.
We have explored cloned repository in command line. Also, in previous lecture, we have unpacked the pack file that contains actually objects in Git repository. In this lecture, let's switch to GitHub Desktop and explore this project here. For that, let's click here on this drop-down menu and click here Add. And add existing repository. Here, let's choose path to our repository, and in my case, it is located on the desktop, and name of the project is Hello World, this one. Let's select this folder and click Open, and click here Add Repository. And now you see here two repositories on a list. And GitHub Desktop has automatically switched to newly added repository. And here you see that current repository is Hello World. Okay, great. Here you see that the current branch is master, and here you see button fetch origin. We have not yet talked about remote repositories, but this button means that we are able to download all updates, latest changes from remote repository. Let's click this button now, fetch origin. And you see that changes were fetched just now. Also here in the main window you see that there are no local changes. And we can open repository in external test editor, and also we are able to view files of repository in Finder. Let's now click on history here. And here you'll see bunch of commits that were made in this repository. And each commit has description like merge pull request, number of pull request, and author of the pull request. Also, of course, you see here SHA-1 hash of every commit, and here in this pane you see changes that were made. And for example, in this commit, this file was changed. Here you see this dot icon. And here you see which changes exactly were made. For example, those lines, 3 lines, were removed. Let me make it a bit smaller. Those lines were added, that are in green. If I'll click on another commit, for example this one, you'll see another file and another changes. And this file is a new file that was added in this commit. You see here this plus icon. Let's have a look at other commit, for example this one. And here you see that this file was added. And here you see contents of this file. You can scroll down and explore other commits, for example this one. It seems that here a person with the same name as mine has committed and authored this commit. And Bogdan has added this file, and here are contents of this file. Let's scroll down and have a look at other commit, for example this one. And here you see another file that was added. And here are instructions on printing Hello World in this specific language, assembler NASM Macho 64. Okay, that is a history of commits in this project. Let's go back to Changes tab and let's explore branches. Let's click on this drop down, and you see here that there is only single master branch and there are no other branches that exist in this remote repository at the moment. But we can of course create easily local branches for this repository, because now this repository is local on our computer. It is of course connected to remote repository, but we can make any local changes we want. Okay, that's how this project looks in GitHub Desktop. Let's now switch back to command line and clear console here. And let's cd to main project folder. Make sure that here you'll see Hello World. And let's list files here, ls-l. And here you see again bunch of folders named with one single letter, for example M, N, O, and so on. And also you see some files. In one of the previous lectures we have read those files. For example, you can read again this file. Let's copy its name and use cut command and paste name of the file. And here are contents of readme.md file. But reading files in command line is not convenient. And editing files using, for example, Nano editor, let's open it up, Nano, and paste name of the file. Here you see readme.md and you can edit this file. But again, editing large files using Nano editor or Vim editor or any other command line editor is not convenient and does not save time. That's why in most cases external editors are used. And now it's a good time to install external editor, and in this course I'll use Visual Studio Code. But I'll make short overview of other editors that are also pretty good, and you can choose any of them. But let's talk about that in the next lecture. I'll see you there. Bye bye. In this lecture we're going to install external text editor. And we will do that to make process of editing files, adding new files and so on more simple and easy. In this course I'll use Visual Studio Code. It is open source and has a lot of different features. It also has many different extensions that you can install on demand. There are also other popular editors like Brackets, Sublime Text or Atom. All those editors are free and you can actually try all of them in action and choose your favorite editor. Before I personally worked with Atom and Sublime Text, but after those editors I have switched to Visual Studio Code and more than 2 years I'm working just in Visual Studio Code. That's my favorite editor. It is available for Mac, for Windows and Linux. Please choose installer depending on your operating system, download it and install. I'll download it for Mac. Okay, file was downloaded, let's unzip it. And drag .app file into applications folder. And now let's open it up. Type here Visual Studio Code. Verifying application, click here Open. And editor was opened. Here I see version, in my case this 1.36, and here I can read which updates were made in this last version. Let's close this and let's close this untitled file. And now let's open in Visual Studio Code project that we have cloned from remote repository. Let's click here File and choose here Open. Navigate to desktop and click on Hello World folder and click Open. And this project was opened in Visual Studio Code. Here in the left pane you see list of folders and files that exist in this repository. You can adjust font size by clicking Command plus or Command minus like that. Also here you see that VS Code out of the box has fancy icons for different file types. For example, files with MD extension have this yellow icon. But let me make a short break now, and after the pause let's make a short overview of Visual Studio Code and let's try to make some changes into the files and see what we will get in Git repository. Let's do that next. Bye. Let's now have a look at Visual Studio Code in action. We have already opened Hello World project and here you see contents of the working directory. Here are several files and bunch of folders. Let's have a look, for example, at readme.md file. Let's click on it and contents of this file will be opened here. And here you already see difference between looking at file in command line and exploring file contents here in VS Code. You see different colors and that is available out of the box in VS Code. You can easily edit any of the files, but let's postpone it and let's close this file and let's open another, for example contributing.md. And here you can read instructions on how you can contribute to this Hello World project. You can also become a co-author of this project. In one of the next sections I'll demonstrate you how you are able to contribute to such public projects as this one. For now, let's simply try to edit this file and let's, for example, add several new lines here. Notice that immediately you'll see that this file is unsaved and here you see this dot. You can save changes in the file by clicking on File and Save. But also you can use shortcut on Mac, it is Command S. Let's press shortcut, Command S, and file was saved. Notice that here near the lines that I have just added, you see those green marks. And they indicate that those lines were just added and those changes are not yet committed to Git. And that means that VS Code has integration with Git out of the box. Also, you see other signs of that. For example, here you see that the color of the file was changed to yellow. And here you see this M letter. You see it here as well. And if you hover mouse over this letter, you see that this file was modified. Also, we see changes here. One in a yellow circle was added here. And if I'll click on this icon, Source Control pane will be opened. And here you'll see all changes made in your project. And again, I see that file with name contributing.md was modified. Also here in the bottom left corner, you see currently checked out branch in Git. And notice here small star. It means that there are changes in this branch. Okay, let's go back to file view, click on this icon, and let's, for example, open one of the files in folder S. Here you see files with different extensions, and again you see some icons for some file extensions. For example, this file has this icon. Let's open this file, and here are contents of this file. Notice that after opening this file with extension .ss, this notification has appeared. Marketplace has extensions that can help with .ss files. And I can click here Search Marketplace. VS Code will be switched to Extensions Marketplace, and here you are able to search for extensions. And it will automatically search for extension .ss. And here we are able to install syntax support for such languages as COBOL, GCL, and so on. Let's try to install this extension. Click on Install, Installing, and this extension was successfully installed. Here for each extension you see name of the extension, icon for the extension, quantity of downloads for this extension, rating, and so on. Below you can read about each extension as well. And let's again open file with extension .ss. Let me search it. Here it is. If I open it now, you'll see different colors in this output. And those different colors are provided by extension that we have just installed. Okay, let's try to edit this file and, for example, copy this line. You can copy any line by placing cursor on that line and pressing combination Command C on Windows Ctrl C. Let's copy it, make new line and paste copy string, like that. And let's delete this empty line. And here again you see this green line, that means that this line was just added to this file. We can save changes again, Command S, and now you see that two files were changed. Both names are now in yellow and M letter is present for this file as well. Also here you see that count of the files that were changed was increased to 2. Let's click here on this icon, and now I see that there are 2 files that were modified. We can actually quickly revert changes here for any file by pressing on this icon, Discard Changes. Let's discard changes in this file. Let's click on this icon, clicked, and confirm changes by pressing this button, Discard Changes. And now you see that file was returned to its original state, and now only one file is marked as changed. Okay, great. That is a short overview of Visual Studio Code, and notice that it is much more convenient to use Visual Studio Code instead of Terminal for editing files, adding files, and so on. Okay, let me discard changes for this file as well. Click on this icon again and discard changes. And now there are no changes in this project. Okay, now let's proceed, and in the next lecture let's create new branch in this project. And let's make some changes in command line and commit them. And after that, we will do the same in Visual Studio Code. Okay, let's switch to terminal, Clear it, and let's start by creating new branch in this repository in the next lecture. Bye bye.
What a beautiful weather today. It's the best time to subscribe and leave a like.
So far we have cloned a remote repository called Hello World. We have installed Visual Studio Code, and I have made a short overview of its graphical user interface. And in this lecture, let's create a new branch in this project, in this local Git repository. Now it is local. After that, we will make some changes in multiple files. For example, we will delete some files, we will modify some files, and probably we will add new files. And after that, we will commit changes. Meanwhile, I'll show you some useful commands, for example, git diff that shows differences between old and new files. Okay, let's get started. And let's create branch here in command line. Recap that for creation of new branch, you should use command git branch. Let's type git branch, and here let's give name to the branch, for example, new-feature, like that. Enter. New branch was created, and now if I'll enter git branch, I'll see two branches on a list. Master is still current branch, and here you see new branch, new feature. Okay, let's check out this new branch. Git checkout new-feature. Enter, and new branch was checked out. And now if I look at contents of the .git/head file, you'll see pointer to refs/heads/new feature. You know that already. Okay, wonderful. Let's now list files in working directory, ls. And let's first change readme.md file, and let's do that here in command line using nano editor. Nano, readme, let's press tab here, .md, enter. And let's, for example, adjust this line, hello world, in all programming languages, like this. And let's also modify another line, for example, make sure to see contributing md file for instructions, like that. Let's write changes, Ctrl-O, press Enter, and Ctrl-X to exit from editing. And immediately you see here this yellow cross sign. That means that we have modified files that were not committed yet. Now let's try to change another file, but let's do that in Visual Studio Code. Let's switch to it and make sure that you'll click here on file list icon here. And let's, for example, open folder with name H. And here let's find, for example, file hex.hex, this one. And instead of hello world, let's type, for example, this is program in hex language, like that. Let's save the file, Ctrl-S, and you'll see that now we have two changed files, and the Visual Studio Code highlights this here, and also you see here that this file was modified as well. And if I'll scroll down here in the files list, you'll see that Visual Studio Code also recognizes that readme.md file was modified as well. But we did it in command line, but it doesn't matter. Those changes will be recognized by any text editor that supports Git. Okay, we have modified this file. And now let's, for example, open folder P, and let's delete one of those files. For example, let's delete this file parser.p. We can delete it like so, right button mouse click, and here delete. File was deleted, and here you see that there are three changes. Let's click on this icon, and here you'll see all changes made in this repository. Readme.md file was modified, hex.hex was modified as well, and if you'll click on a specific file here in this pane, you may observe changes. For example, here on the left side you see old version of this file, and here on the right side you see new version of the file. And we have replaced hello world with this line. This is program in hex language. Here you see minus, it means that this line was removed, and here you see plus, it means that this line was added. In the same way, you can observe changes in readme.md file. Let's click on it, and here you'll see several changes that we have made. For example, here on this line we have replaced every with all. Also we have added here s at the end of the language. And on this line, line 11, we have added Word file here after contributing.md text. And this is highlighted here as well. And if I'll click on parser.p file, you'll simply see that this file was removed because we have deleted it. Okay, that's are all changes that we have made in this project. And actually you can commit changes directly here in Visual Studio Code. But let's try that later on. Now let's go back to command line and observe changes here. Let's type git status. Enter. And here you'll see all changes that were made on this branch, new feature branch. And we see that two files were modified, this one, and one file, this one, was deleted. Before adding those files to staging area, let's switch to GitHub desktop and observe changes there. And you see all those changes here as well in a changes pane. There were 3 changed files, this one, and this one. This dot means that file was modified and minus means that file was removed. And here you see that all lines in this file were removed as well. If I'll click on hex.hex file, you'll see those changes here. This line was removed and this line was added. Let's click on readme.md file, and here you'll see 2 changes. One change on this line and second change on this line, and all changes are highlighted. Okay, if I click on a history, you'll see that last commit in my case was made by Mike Denagi, and he has merged pull request number 505. In your case, last commit will be more recent than mine. Okay, let's go back to changes and notice also that here current branch is new feature. Let's now return to command line and let's add those changes to staging area. Git, add, and dot. Recap that dot will add all modified, deleted, or newly added files to staging area. Git add and dot. And now let's list files in staging area. Git ls files -s. Enter. And here you'll see a bunch of files, including files that were just changed. For example, we have changed file readme.md, and here it is on a list. And now staging area and working directory are consistent. And if I look at output of git status command again, you'll see that there are changes ready to be committed. 2 files modified and 1 file deleted. Now we are ready to commit those changes. Let's do that. Git commit. Let's add here commit message in line. And commit message will be modified readme, adjusted hex file, and removed parser.p file, like that. Don't forget closing double quotes, and let's press enter. Enter, and changes were committed. Here you see current branch, it is new feature branch. Here you see SHA-1 hash of new commit object. Here you see message for commit. And here you see that 3 files were changed. In total there are 3 insertions, 3 new lines, and 7 lines in total were deleted. And here you see that this file with those permissions was removed. Let's now have a look at output of git status again. Git status, enter, and there are nothing to commit, working tree is clean. And that means that now all areas are consistent. Let's now have a look at git log command, and here you'll see last commit that was just made by me. Here is again SHA-1 hash of this commit, head now points to new feature branch, author of the commit is me, here is date of commit, and here is commit message. But notice here in parentheses there is origin/master, origin/head, and master. How do you think? What does it mean? We have cloned this repository to our local computers from remote repository. And now our local repository is connected to remote repository. And remote repository still has this commit as last commit on master branch. And that's why here you see name of remote origin branch. Here you see name of origin head. And here you see name of your local branch. And that means that this commit is last commit in your master branch and last commit in origin/master branch in remote repository. We will get back to this later on when you will create GitHub account and when you will create your own remote repository. That is the output of git log command, and here you'll see your own commit. Okay, let's close this and let's go to GitHub desktop and observe changes here. We are still on new feature branch. There are no changes to be committed. Here you see that we have committed changes several minutes ago, and here you see commit message. If I'll click on History tab, I'll see here last commit made by me. And here are all changes that were made in this commit. This file was modified, there were changes. This file was modified as well. This single line was modified, and this file was removed. Let's also switch to Visual Studio Code, and here you'll notice that there are no changes as well. All changes were committed. And if I'll click, for example, on this file, you will not see this green line here near changed line. That's because we have committed all changes. Okay, that's how this project was just modified by us, by creating new commit. Let's now proceed, and in the next lecture, I'll explain you what is git diff command and how it works. Now we see here empty output, but when we will make some changes again, you'll see here two versions of every file that was modified. You'll see old version and new modified version, and you'll see differences between those two versions. Okay, let's talk about git diff in the next lecture. I'll see you there. Bye bye. In the previous lecture, we have created new branch in Hello World project, and name of the branch is new feature. We have checked out this new branch, and we have made some changes in several files. After making those changes, we have committed them with git commit command. And now our project doesn't have any new changes. In this lecture, I am going to explain you how git diff command works. Now output of this command is empty. That's because there are no changes. Let's make some changes again. And let's do that in Visual Studio Code. Let me close all files opened here. And let me open file listlangs.py. And let me actually close all those pop-ups. I don't want to install any new extensions. And now we will modify this file. Let's do that. Let's add here several new lines like that. And let's modify this text. Let's remove, for example, this word like that. And let's, for example, add something here. Let's add comment. End of the file. Like that. And let's save those changes. Let's save. And here immediately you'll see that there is a single change ready to be committed. But we will not commit it yet. Let's go back to command line and let's look at the status of our project. Git status. Enter. There is a single modified file listlangs.py. Let's now have a look at the output of git diff command. Git diff. Enter. And here you'll see probably strange output. Here you see two files, file A and file B. This file A/listlangs.py represents previous version of the file, and B/listlangs.py represents modified file. And if I'll get back to Visual Studio Code and click on this file that was changed, you'll see actually those two files here. Here is A file and here is B file. Old file and modified file. For example, here in modified file, you'll see two new lines added here on line 6 and on line 7. Also here you'll see that this line was modified. We have removed currently word. Okay, let's get back to command line. So, A is a previous version of the file and B is new version of the file. Next line, this one. On this next line, you'll see SHA-1 hashes for those files. For this file, Git has created SHA-1 hash starting with those characters, and for this file, Git creates SHA-1 hash starting with those characters. But let's actually have a look at Git repository and let's try to find blobs with such SHA-1 hashes. Let me open new terminal window here, and let's cd to desktop, hello world, enter, and here let's use git cut file command in order to read contents of specific Git object, git cut file -p, and here let's copy this SHA-1 hash and paste here. Enter, and here you'll see contents of corresponding blob, and here are contents actually of this file. But notice that at the end of the file you don't see new comment that we have added in Visual Studio Code. I mean this comment. End of the file. And that means that this is old version of this file. Let's now try to look at contents of object with this SHA-1 hash. Let's copy this SHA-1 hash, go back to this tab, and again use git cut file -p command and paste copied SHA-1 hash. Press enter, and now I see fatal error, not a valid object with such name. And now question to you. How do you think why we don't see any output here as a result of this command? Please pause video now and try to answer this question. Answer is pretty simple. If I'll get back to this tab, I'll see again two versions of the same file. This file, it is old file, and this file, it is modified file. But we have not yet staged those changes, and we have not yet committed them. And you know that Git creates new blobs in Git repository only after committing. And that's why here, at this moment of time, we see provisional SHA-1 hash for this modified file. But object itself was not yet created at this moment of time. Only when and if you will commit changes, those changes, Git will create this object in Git repository, and here you'll see after this command contents of this object. That's how it works. Again, here you see provisional SHA-1 hash for this modified file. Okay, great. Here you see file permissions and it is executable file. Next, here on this line you see that this file with prefix a was modified, it is old file. And here on this line you see that this file is new file, and those pluses mean that here. Next comes very strange line, at -3,6 plus 3,8 at. In order to explain you what this line means, let me switch to GitHub desktop. And here let's click on changes and click on the changed file. And here you'll see same output. Notice at the top you'll see at -3,6 and so on. Also you see similar line here and here. Those lines indicate start of changed section. Git is clever enough and it does not show us entire file and all changes that were made in the file. Notice that we have made 3 changes in different places in the file. And file itself may contain hundreds or thousands of lines. And it will not be convenient if Git will show us entire file here in this pane, or entire file here in output of git diff command. That's why Git shows us only changed sections. And those lines like this indicate start of corresponding section. Let me explain you meaning of this line in GitHub desktop. Okay, here you see 2 adds, then -3,6. 3 is number of the line in old file. And here you see again 2 columns, first column and second column. First column represents line numbers in previous old file. And first line here is line number 3. Let me make it a bit larger actually. And this number matches this first number -3. Next number, number 6. This number represents quantity of lines in this section for old file. And if you count lines here, 3, 4, 5, 6, 7, 8, you'll find out that there are exactly 6 lines from the old file. And here starts second section. Again, -3 is indication of the first line in this section in the old file, and second number after comma indicates quantity of the lines that are printed here in this section. 6 lines. Next after space comes +3,8. And you can guess what this means. Number after plus, in this case 3, indicates first line in a new file, and here you see this line, number 3. And 8 means total quantity of lines that are included in this section from the new file. We have added here 2 empty lines, and that means that in this section, in total 8 lines from the new file will be included. And you can count them here: 3, 4, 5, 6, 7, 8, 9, 10. In total 8 lines. Again, from the old file, here in this section you see 6 lines, and from the new file you see here 8 lines. Minus here indicates information from the old file, and plus stands for new modified file. Or we can say that minus stands for file A in this output, and plus stands for file B from this output. Okay, that is first section. Let's scroll down and let's have a look at the next section. Next section starts here. And in the old file we start from the line 11. And that's why here in the left column you see number 11. Number 7 stands for quantity of the lines that are taken from the old previous file. And here you can count those lines. There are exactly 7 lines. Next, plus 13, 7. 13 is the first line in this section from the new file. That's why here you see it at the beginning of this section. And 7 again is quantity of the lines from the new file. In this section, quantity of the lines from the old file and new file are the same. That's because we have just changed single line of code here in the old file. We have deleted word currently. Also here you see this text that indicates actually start of this section. You can copy this text and go, for example, to Visual Studio Code and open this file again, listlang's.py, and look for this line. Let's press Ctrl F and paste copied line, and here you'll jump to this line of text. Okay, let's get back to GitHub Desktop and let's observe last section in this output. And the last section includes 3 lines from the old file and 5 lines from the new file. And here are those lines. Those 3 lines are from the old file and they were not changed. And in a new file we have added 2 lines, 1 empty line and 1 new line with text end of file. That's why here quantity of the line in the old file is 3, and in new file quantity of the lines in this section is 5. We have added 2 new lines. And again here you see text that appears at the beginning of this section. We can again copy it, go back to VS Code and search for it like that, and here you'll see this line. Okay, let's get back actually to command line and scroll down here. You can scroll down here by pressing down arrow like that. And you'll see here same 3 sections. Here is second section, here is its start, and here is, if I'll scroll down, here is last third section. And now you understand meaning of those lines. They actually indicate how Git should output contents of corresponding files. It takes part of the old file and outputs 3 lines here starting from the line 22, and it takes 5 lines from the new file starting from the line 24. And that is a result of those instructions actually. Okay, that is a result of git diff command. Let's close this output and let's commit those changes. Git commit -m commit message changed list _ langs.py, closing double quotes, and notice that I have not yet added those changes to staging area. And I can do that directly here by adding -a option. With this option, all changes will be added to staging area first, and after that automatically committed. Let's press enter now, enter, and you'll see new commit. Here is its SHA-1 hash, and here is commit message, changed list langs.py. And here you'll see that 1 file was changed, there were 5 insertions, 5 new lines, and 1 line was deleted. Okay, let's have a look at output of git diff command again. Enter, and here I'll see again empty output. That's because all changes were already committed. Recap that we tried to read contents of the Git object with this SHA-1 hash. And at that moment of time, this output was empty. There was no such object in Git repository. Let's now try to repeat this operation and read contents of this file again. Let's go in history one level up and press enter. Enter, and now I see that this file is not empty anymore. That's because Git has already created new blob in Git repository after commit. And here you see that it is new version of our file. Here you see this line, end of the file. We have discussed that before. Git doesn't create new objects until you'll commit your changes. Okay, that's all for this lecture, and you know how to read the output of git diff command, and more convenient is to read it in such programs at GitHub Desktop or other graphical user interfaces for Git. Okay, that's all for this lecture, and in the next one, let's shortly summarize all changes that we made in this Hello World repository. I'll see you next. Bye bye. Let's now summarize what we did in this cloned repository. Again, we have cloned it from a remote repository, and after that we have created new branch called new feature. And in this branch we have committed 2 times. Let's have a look at output of git log command. And here you'll see 2 commits. This one, where we have modified readme file, adjusted hex file, and removed parse.p file. It seems that I made here typo. It's not a problem here. And here is last commit that we have made. In this last commit, we have modified listlang's.py file. Okay, these are 2 commits that we have made in our local repository. But please note that those changes have not affected in any way remote repository. And if I'll go back to GitHub page for this repository and click here on commits, you'll see that those commits have not appeared here. That's because we don't control this remote repository. And if you want to commit to this repository, you need to open pull request, and after that, author may merge your pull request or not. We will discuss what is pull request later on in one of the next sections. For now, please note that your commits were not added to this remote repository. Your commits are only local on your local computer. Okay, let's close this and let's go to VS Code. Here in VS Code, you may observe that now in a working directory we have changes from last commit. If I'll scroll down here in this listlang's.py file, you'll see here line end of the file. That's because we are currently located in new feature branch, and now this branch points to very last commit. We can actually verify that cat.git/refs/heads/new feature, enter. And here you'll see actually SHA-1 hash of the very last commit. It starts in my case with 001b. And if I look at git log command, you'll see same SHA-1 hash here in the last commit section. Okay, that's how project looks like now. We can actually check out again master branch and see what will happen after that. Git checkout master, enter. And let's now go back to VS Code and look at contents of same file, listlang's.py. And you'll see now old, let's say, version of this file. And new line that we have added before has disappeared. That's because now we have checked out another, let's say, commit and another tree with another trees and blobs. And if I'll have a look at output of git log command here, you will not see 2 commits that we have made in EU feature branch. And that is fully correct. We are located in another branch, and this branch doesn't know anything about other commits made in other branches. And now question, how we can take 2 commits from the new feature branch? Let's actually check out it back. Git checkout new feature, enter. Git log again. I am talking about those 2 commits. So how we can take those 2 commits and all changes made in those commits and incorporate them into master branch? For that, we can use another branch merging feature of the Git. And let's discuss this feature in the next section. I'll see you in the next section. Bye bye. Now you know what is branch, why branch is needed, and how to create branches. Also, you know how to check out different branches and how to make changes, commits in different branches. Also, you know what is head, and you know that head moves along with currently checked out branch. But why branches are needed?
Actually, each branch is used for development of specific feature. And when development is completed and you are happy with specific feature, you usually want to apply those changes into main, let's say, master branch or release branch, depending on which branch was chosen as main. And Git is able to perform merging of two branches using two different approaches, either fast-forward approach or three-way merge. With fast-forward approach, Git simply moves pointer of the head. With three-way merge, Git will create new merge commit that will contain all changes. And in this section we will talk about both approaches. Also, I'll explain you what is merge conflict and how to resolve conflicts using either terminal or Visual Studio Code. In this section we will talk about merging branches. First, let's discuss what is actually merge and why it is actually needed. Let's have a look at this diagram. Here you see three branches: master branch, feature 1 branch, and feature 2 branch. We can say that master branch is our main branch, and if we will say that every branch is separate story, let's say that master branch is main story. Sometimes this main branch is called release, sometimes master, it depends on the project. But all branches are equal for Git. You choose main branch that will be used as main story in your project. Why I'm talking about main story? That's because you usually create branches as branches from the main branch. And in this case, main branch is master branch. That's why I have made those arrows and the borders more bolder than in other branches. And you know that new branches are created when you want to work on specific feature, and you don't want to do that on main branch. It's a very common practice when many people are working on the same project and are working on different features. That's why it is not possible to make such distributed parallel development without different branches. And let's assume that at this moment of time we have created a new branch called feature 1 branch, this one. And at this moment of time we have created another branch, feature 2 branch. And parallel, master branch is also being developed and new commits are added here as well. We have tried this approach in previous sections. We have created new branches and we have made some changes in the project in new branch and after that committed those changes. But you also know that if, for example, head is located now here at this feature 1 branch, you'll see this commit, this commit, this commit, this and this commit. You will not see those two commits in master branch and you will not see those 3 commits in this feature 2 branch. You only see project from the point where head is currently located. Same in case when head will point, for example, to master branch. In this case, you'll see only those 4 commits and you will not see commits in feature 1 branch or in feature 2 branch. But what if you want to incorporate changes made in feature 1 branch into master branch? You want to merge 2 different stories, 2 different histories. And that's where merge feature comes in. You can merge any branch into any other branch. But in most cases, when you have main, let's say, branch, in this case this master branch, all other branches are merged into master branch. There are 2 approaches used in merging branches, and they are called fast-forward merge and three-way merge. And let's discuss them in the next lectures, and let's start with fast-forward merge. I'll see you in a bit. Bye-bye.
Hi, is it a marketing company? I have just published a great YouTube video, but it does not have enough views and likes. How could you help me with that? What? $25 per 100 likes? No, sorry, I don't have such money, sorry.
In the previous lecture we have discussed why branches merging is needed. And you need to merge branches when you want to incorporate changes made in one branch into other branch.
And in most cases, this main branch is called master branch or release branch. And all other branches are merged into this main branch. And there are two techniques used in branches merging, and they are called fast-forward merge and three-way merge. In this lecture, I'll explain you how fast-forward merge works. Let's have a look at this diagram. There is main branch called master branch, and there are, let's say, 3 commits here made in this master branch. And at this moment of time, you have created another feature branch, and this commit is parent commit for the first commit in feature 1 branch. And let's assume that you have made some changes in this feature 1 branch and have committed multiple times. In my case, there are 3 commits. And let's assume that at this moment of time, you are happy with changes made in feature 1 branch, and you want to merge changes made in this feature 1 branch into master branch. Master branch in this case is called receiving branch. It receives changes from other branch. And notice that there are commits in feature 1 branch, but there are no other commits after this commit in master branch. And only in such case fast-forward merge is possible. When you want to merge, in this case, feature 1 branch into master branch, you should check out first master branch. And that's why here you see that head is now pointing to master branch. We have checked out this branch. After that, you choose which branch you want to merge into master branch. And if you want to merge feature 1 branch into master branch, Git will check whether there are additional commits in this master branch. If there are no other commits, and this commit that is parent commit for this commit is still last commit in master branch, Git can apply fast-forward merge technique. And all what it does when you merge feature 1 branch into master branch, it simply takes master branch pointer and moves it to this commit, last commit in feature 1 branch. Nothing else. Git doesn't create any new commits, it simply moves pointer, that's all. And after fast-forward merge, picture will be like this. Master branch will point to this last commit, and feature 1 branch will point to this last commit as well. And now those commits from feature 1 branch were incorporated into master branch. And I will change their style like this, because now they are actually commits of master branch. And let me also change thickness of those arrows. Like this. Okay, that's how fast-forward merge works. After moving master branch pointer from this commit to last commit, our history became consistent for both branches, for master branch and feature 1 branch. And actually, at this moment of time, you can safely remove feature 1 branch if you are not going to make any other changes in it. And you can simply use git branch with -d option and delete this branch like this. Okay, that's how fast-forward merge works. It is very simple, it just moves branch pointer from one commit to another commit. In the next lecture, let's actually try fast-forward merge in action. And we will return back to our first project and merge BR1 branch into master branch. Let's try that in the next lecture. I'll see you there. Bye-bye. Before trying fast-forward merge in action, let's quickly overview merging process steps. First, you need to create new feature branch from the main branch. And in most cases, main branch is called master branch or release branch. After that, you need to make changes in a new branch and commit those changes. Of course, you need to test all changes in feature branch, and only when you are fully happy with those changes, you can merge those changes into your main branch. When you are ready to merge changes, you need to check out main branch. And this branch that receives changes from other branch is called receiving branch. This step is very important. You need to check out branch you want to merge to. And when this main branch is checked, you are able to merge feature branch to the current receiving branch. And for that, you need to use git merge command. If you're using command line, you just need to type git merge and name of other feature branch. And after that, merging will happen. Please note that after entering this command, Git will automatically define which merging technique it will use, either fast-forward merge or three-way merge. Okay, in the next lecture we will return back to our first project and try fast-forward merge in action. Recap that the picture in our first project looks like this. There is BR1 branch with single commit, and there is master branch that points to third commit. And we didn't make any other commits in master branch. That's why fast-forward approach is possible here. Let's try it in the next lecture. I'll see you there. Bye bye. Okay, please return to first project folder and make sure that you are located in master branch. Recap that at the moment current master branch points to third commit and picture is like this. There is also BR1 branch that points to first commit in a BR1 branch. And now we will merge BR1 branch into master branch. And in our project, fast-forward merge is possible because there are no other commits made in master branch. Okay, let's first list files in master branch, ls-l. And here you see empty output. That's because in third commit we have deleted all files in working directory. I mean file1.txt, file2.txt, and file3.txt. Let's now list all branches, git branch. And you should see BR1 branch here on the list. Let's check out this BR1 branch. Git checkout br-1. Enter. And let's list files now, ls-l. And here I'll see single file, file4.txt. And that is a single file that we have created in this BR1 branch. Let's have a look at output of git log command. Enter, and here you'll see all commits in our project. Our first commit, second commit, third commit, and first commit in the BR1 branch. That's because head is now located here, and it points at BR1 branch. That's why we see all those commits. But if I'll check out master branch again, I'll see only 3 commits. That's because master branch does not see commits in other branches. Let's verify that. Let's close this. Git checkout master, git log, and yes, here we see only 3 commits. We don't see first commit in a BR1 branch. And notice that there are no other commits after third commit made in master branch. That's why here Git can use fast-forward merge technique. Let's now try that in action, but before let's get back to steps in merging process, this list, and verify what we have done so far. We have created new branch. It is called BR1 branch. And we have created this branch based on main branch, master branch in our case. We have made changes in new branch and committed them. There is single commit in this BR1 branch. Now we have checked out main branch, receiving branch, and now we are in master branch here. And that's why we are ready to merge feature branch to the current receiving branch. And for that we will use now git merge command. Let's do that. Git merge, and here type name of the branch we want to merge to current master branch. Git merge br-1. Enter, and merge was successfully completed. And here you notice that fast-forward merge was applied. And below you see all changes that were made in BR1 branch. We have just created one file, file4.txt. And now if I list files in working directory ls-l, I'll see file4.txt on a list. That's because now master branch points to last commit in BR1 branch. Also here in this output after git merge command you see 2 SHA-1 hashes, this one and this one. And my question to you, how do you think what those SHA-1 hashes mean? Answer is pretty simple. Before merging, master branch was pointing to this commit. And after merging, master branch points to this commit. And we can verify that. Let's first have a look at history of the commits. Git log. And now I see all 4 commits on a list. First, second, third, and first commit in a BR1 branch. And here you see SHA-1 hash of this commit object. And if I'll now look at contents of the git/refs/heads/master file, I'll see exactly same SHA-1 hash, this one. And same hash you see here. And that's how fast-forward merge works. It has simply moved pointer from third commit, from this one, to first commit in BR1 branch, this one. And now master branch points to this commit. Let's actually get back to diagram and reflect changes here. There is still BR1 branch. Let me move it a bit here. And master branch points to this commit. Same commit as BR1 branch. And it is the first commit in a BR1 branch. And head points now to master branch, of course, like this. And it means that master branch sees entire history of all commits. And I can change color of this commit and make it green like other commits in this row, like this. And now after this merge, BR1 branch can be safely deleted. Let's delete it now. Let's get back to terminal and here type git branch -d and name of the branch br-1. Enter, and branch was successfully deleted. And here you see SHA-1 hash of the commit this branch was pointing to. And that is the same hash that you see here. Okay, BR1 branch was deleted and now there is single branch on the list, git branch, and here you see only master branch, that is a current branch. Let's reflect this on our diagram. Let me remove BR1 branch like this. Let me move master branch pointer to the center like this. And now I can move this commit with all pointers to this line, because now we are located in main story of our project. Let me quickly adjust this diagram. And now our history for main master branch is again linear, and it looks like this. There are 4 commits in a row. Okay, you see that fast-forward merge is really easy in action. It simply moves pointer for receiving branch, nothing else. And after merging, you can safely remove branch that you have merged into receiving branch. And at the moment, our project contains only single master branch. Okay, let's go on, and in the next lecture, let's discuss how 3-way merge works. I'll see you in a bit. Bye-bye. In the previous lectures, we have discussed fast-forward merge. We have also tried it in action. Please recap that fast-forward merge is possible when receiving branch does not have any further commits after commit when feature branch was created. And only in such case we are able to simply move pointer of receiving branch to the pointer of feature branch. And we have tried fast-forward merge in our project. And now picture looks like this. There is only single master branch with 4 commits. And when we performed fast-forward merge, Git simply has moved master pointer to the pointer of BR1 branch. And after merging, we have successfully deleted BR1 branch. Now let's proceed, and now let's discuss how 3-way merge works. Let's assume that there are 2 branches, master branch and feature1 branch. And feature1 branch was created at this moment of time, from this commit. This commit is parent commit for the first commit in feature1 branch. And now we are not able simply move master pointer to feature1 pointer, because in such case we will lose those 2 commits. We will lose information. That's why in such case, when you want to merge feature1 branch into master branch, Git applies 3-way merge. How it works? In such case, Git creates brand new commit, and this new commit is based on 3 other commits. This commit and those 2 commits. This commit is first common commit for those 2 branches, for this one and this one. And this commit is called ancestor. Of course, you can say that this commit is also common commit for both branches, because this commit also appears here and here, Same for this commit. But Git tries to find first nearest ancestor. And in such case, this commit is ancestor. It is nearest common commit for both branches. Okay, recap that before merging, you need to check out receiving branch you want to merge to. And on this diagram, you see that master branch is currently checked out branch because head points to master branch. So, Git takes 3 commits, this one, and this one. And after that, Git creates brand new merge commit after this commit, after last commit in receiving branch. And picture will look like this. Let me copy this commit and move it to this place, like this. So, here will be new merge commit with parent pointing to this commit. Of course, after creating this new merge commit, Git will move pointer of the master branch to this new merge commit like this. But this new merge commit will also have another parent. And parent for this new merge commit will be also last commit in feature 1 branch. And picture will be like this. And that is the first time when you see one commit with 2 parents. This parent and this parent. And with such approach, Git has merged 2 history lines. This line and this line. And this merge commit will have all changes that were made in feature 1 branch. All those 3 commits will be incorporated just in a single merge commit here. But please note that feature 1 branch remains untouched. We don't move feature 1 pointer to any other commit. It still points to the last commit here in this feature 1 branch. And those commits were also unchanged. Git has created just single merge commit that has 2 parents. It points to this commit and this commit. Also, it is important to understand that this merge commit is created by Git automatically. You don't need to do anything. You just use standard git merge command. Let me actually highlight that this commit is merge commit, like this. Okay, after creation of merge commit and after merging feature 1 branch into master branch, we can safely delete feature 1 branch. When you remove feature 1 branch after 3-way merge, only this pointer will be removed. Those 3 commits will remain in place. Why? That's because there is a pointer from this commit to this commit. This commit is one of the parent commits for this merge commit. This commit, last one in feature 1 branch, points to this commit, and this one points to this commit. That's why all those 3 commits will remain unchanged and will not be deleted by Git. That's how 3-way merge works. Git simply takes 3 commits, this one called ancestor and those 2 commits, and creates new merge commit based on all those 3 commits. Okay, now it's time to try it in action, and we will try it of course in our first project, and we will create another branch called br2 branch, make several commits there, and also we will make 1 or 2 commits in master branch. And after that, we will try to merge br2 branch into master branch. Let's try that in the next lecture. I'll see you there. Bye bye.
Enjoying this tutorial? Don't forget that it is part of the large complete Git and GitHub course. In that course, I'll explain a lot of other advanced features of Git, like rebasing, working with pull requests, squashing, and many more. I hope to see you in that course.
In this lecture, we are going to try 3-way merge in action, and we will create another branch in first project. Recap that now there is single branch. Let's enter git branch. Enter. Here is only master branch available. And now we will create another branch called br2 branch. Let's create it. Git checkout -b. I'll use shortcut for that. br2. Recap that with -b option you are able to create new branch and immediately check out it. Let's press enter, and we are now in br2 branch. Let's list files here in working directory ls, and there is only single file4.txt. Let's actually open now this project in Visual Studio Code in order to create new files more fast. You can open this project in Visual Studio Code in multiple places. For example, you can simply open Visual Studio Code, choose here File, Open, and navigate to Desktop and choose here First Project and click Open. Also, you are able to open your project directly from GitHub Desktop. Okay, project was opened and now I see only single file4.txt with string hello, git. Let's create, for example, new folder. I'll click on this icon and create folder called new files, like that. And inside of this folder, let's create new file, file5.txt, and let's, for example, enter some text here. It is a new file in the new files folder. Let's save the file, Ctrl S. Let's create another file. Again, click on this icon and let's give it name file6.txt. Another file with file name file6.txt, like this. Let's save the file, Ctrl S, and let's also create one more file in root of our project. And for that I can click outside of the files list and click here on new file icon. And let's create file file7.txt. Just another file in the root of the working directory, like that. Let's save the file, Ctrl S, and now we can close all those files that we have just edited. Here you see changes and there are 3 files, and Visual Studio Code tells us that those 3 files are now untracked. Let's now commit all those changes. We can try to commit changes directly here in Visual Studio Code. Let's click on a source control icon and here you'll see all changes that were made in your project. You can observe them like this by clicking on every file. And here we can type commit message. And let's type message 3 new files were created in the BR2 branch, like this. And let's click here this commit icon. Clicked. And changes were committed. If I'll go back to command line and type here git status, I will not see any changes. That's because I have just committed all of them. Let's have a look at output of git log command. And here I see this commit that I have just made in Visual Studio Code. Here is its commit message. 3 new files were created in a BR2 branch. And now we are still located in BR2 branch. Head points to BR2 branch. And master branch points still to this commit, first commit in a BR1 branch. Okay, let's exit from here and let's make another commit in BR2 branch. Let's get back to Visual Studio Code and go to files list and let's change, for example, file 5.txt. And let me add simply here a new line. File 5.txt was just changed, like this. Let's save changes and go back to command line. And let's observe output of git status here. Enter. And here you see that we are still on branch BR2 and there is single file that was modified. And here is location of this file. It is located in new files folder and file name is file5.txt. And here of course you see this yellow cross sign. That means that there are some changes that are not yet committed. Okay, let's commit them using one-liner. Git commit -a, recap that with this option we will automatically stage files. After that comes commit message -m, and here let's write changed file5.txt, like that. Let's press enter and changes were committed. Here as usually you see SHA-1 hash of new commit object, here you see commit message, and here you see that one file was changed. 3 lines were added and 1 line was deleted. But actually we have added only 2 lines, but you see here that there are 3 new lines and 1 line was deleted. Why is that? Let's quickly switch to GitHub Desktop and observe changes there. Let's switch here to repository with name first project, this one. Here you'll see that we are on BR2 branch and let's click here on history. And if I'll click on last commit, this one with message changed file 5.txt, you'll see that one line was deleted, this one, and 3 lines were added. This line looks similar to the line that was deleted. But in fact, those lines are different because this line didn't have line break at the end, but this line has. That's why in the output of git commit message you see that 3 lines were added and 1 line was removed. Okay, let's get back to command line. And now let's switch to master branch and make some changes in master branch. Git checkout, master, enter. If I'll enter git log command now, I'll still see first commit in a BR1 branch as last commit for master branch. I don't see 2 new commits made in BR2 branch, and that's because we have not yet merged changes from BR2 branch to master branch. Okay, let's now make changes in master branch, and let's again get back to Visual Studio Code. And notice that here file structure was automatically updated. And now I see only file 4.txt, and file 5.txt that was opened in editor is marked as deleted. That's because after switching to new branch, contents of the working directory are automatically updated. And you know that after checking out any branch or commit, Git automatically updates staging area and working directory, and they are consistent after checking out any branch or commit. You can try to change branches actually here directly in Visual Studio Code. Click here name of the current branch and choose here another branch you want to check out. Let's try to check out BR2 branch. Let's click on it. And now you see that working directory was automatically updated and VS Code automatically reflects those changes. There is folder new files with 2 files inside of it, and there are 2 files in the root of our project. Okay, let's get back to master branch and make changes here. And let's add here another file with file name file8.txt. And here let's add text. This file was added in the master branch. Like this. Let's save the file. Here you see that this file is now untracked and there is single change ready to be committed. Let's now actually switch to GitHub desktop and commit changes here. In history here we still see only 4 commits, that's because current branch is master branch. Let's go to changes and observe changes here. New file was added and here you see contents of this file. And now let's add commit message. Actually, GitHub desktop offers us default commit message create file a.txt. Let's leave it unchanged and let's simply press button commit to master. Pressed, and changes were committed. Now you see that there are no local changes and actually we are able to publish our repository to GitHub. And here you see text that this repository is currently only available on our local machine. And that is true, we have not yet published our repository to remote repository. But no worries, we will try that in one of the next sections. Okay, we have made another commit in master branch, and now if I'll click at history tab, I'll see another commit here on the top of this commit. And here I see that file a.txt was just added. Okay, that is the structure of master branch at the moment. There are 5 commits. This commit exists only in master branch and is absent in BR2 branch. If I'll switch to BR2 branch, I'll see 2 another commits, this one and this one, that are present in BR2 branch but are absent in master branch. And that is a good place where we can try to merge BR2 branch into master branch. Let's try that. Before merging, let's switch back to master branch, because master branch is receiving branch in our case, and we will merge BR2 branch into master branch. We can easily perform merging of the branches directly here in GitHub desktop. You can just click on this drop down and click here choose a branch to merge into master. Let's try it. Clicked. And here if I'll choose BR2 branch, I am able to merge BR2 into master. And you'll see that merging is possible and 2 commits from BR2 will be merged into master. But let's actually try merging in command line instead of GitHub desktop in order to see result of merge operation. Let's close this window and go back to command line. And here again ensure that we are in receiving branch. Receiving branch in our case is master branch. And here let's type git merge and name of the branch we want to merge into current branch. And name will be br-2. Let's press enter. And we are immediately prompted to enter commit message that will explain why this merge is necessary. And that's because in three-way merge, Git creates brand new commit object with two parent commits. And that's why we are asked here to enter commit message. We can leave this message default as merge branch br2, but we can edit it. Recap that default editor is vim, and in order to enter insert mode, I need to press I. And now I'm in insert mode, and here let's add text merge branch br2 into master branch, like this. Let's exit from insert mode, escape, and type here :wq, like this. Let's press enter, and merge was completed. Here in this output you see that merge was made by recursive strategy. And that means that Git was looking for common ancestor, and after finding this common commit, it has created brand new merge commit object. And in this new commit object, it has incorporated all changes that were made in br2 branch. Here you see that 3 files were created, and here you see that every file has new lines. This one has 1 new line, this file has 3 new lines, and this file has 1 new line. And in total, 3 files were changed, and there were 5 insertions, 5 new lines. And all those changes were incorporated in single merge commit. Okay, let's now analyze Git repository after this merge commit, but let's do that after the small pause. Okay, we have just made merge commit, and we have merged br2 branch into master branch. Let's now examine structure of our Git repository. Let's first have a look at contents of working directory, ls-l. Enter. And here now I see 3 files in root of our project and new folder called new files. Recap that before merging in master branch, there were only 2 files, file4.txt and file8.txt. But after merging, 3 new files were created, and here you see this information. Okay, let's now have a look at output of git log command. Git log. Enter. And now I see merge commit as last commit in master branch. Head points to master branch, and here is this merge commit with this commit message, merge branch br2 into master branch. Notice that br2 branch still points to this commit, last commit in br2 branch when we have changed file5.txt. That's why I have told you that branch that you are merging into receiving branch is not changed at all. All commits and branch pointer remain unchanged. Okay, that is the last commit in master branch, it is merge commit. Let's have a look at contents of this commit object. Let's copy its SHA-1 hash like this and use git cut file -p and paste copied SHA-1 hash. Enter. And now I see contents of last merge commit object. It has pointer to tree object as every commit has, but now you see that it has 2 parent commits. One from master branch and one from br2 branch. Author and committer are as usually the same, and here you see commit message, merge branch br2 into master branch. That is the first time when you see commit object with 2 parents. In practice, commit objects may have more than 2 parents. It may happen when you perform merging of multiple branches. Let's now have a look at contents of those parent commit objects. Let me copy SHA-1 hash of this first parent and use git cut file -p and paste copied SHA-1 hash. Enter. And now I see commit object with message create file8.txt. And that was last commit in master branch before merging. Let's have a look at contents of this parent. Let me copy this SHA-1 hash, git cut file -p and paste copied SHA-1 hash. Enter. And here I see last commit made in br2 branch. And that's what I have explained you in previous lecture. If Git performs 3-way merge, it creates new merge commit with pointers to 2 parent commits, last commit in receiving branch, and last commit in feature branch. And that's what you see in command line. Let's now observe changes in the project after merging in GitHub Desktop. Let's go there and let's click on History tab. Ensure that you are in master branch now, and here you should see merge commit at the top of commit list. And here in this merge branch commit, you'll see all changes that were made after merging of BR2 branch into master branch. As usually here you see SHA-1 hash of this merge commit, and there are 3 changes. File 7.txt was added, file 5.txt was added, and file 6.txt was added. But we still see all previous commits from master branch and BR2 branch. For example, here is last commit from master branch before merging. We have added file a.txt in master branch. Here are 2 commits from BR2 branch, when we have changed file 5.txt, and before that we have created 3 files in BR2 branch. Here is commit message about that. And Git shows you all those commits here in a list, because this merge branch commit has 2 parents. It sees 2 histories, from master branch and from BR2 branch. That's why again you see here all those 3 commits. Okay, great. That's how merging process works. Now let's try to delete BR2 branch. Let's go back to command line and list branches here, git branch, enter. Here are 2 branches, BR2 and master, and let's now delete BR2 branch. Git branch -d br-2, enter, and branch was successfully deleted. Notice that we didn't see any warning before deletion of the branch. That's because we have already merged this branch into current master branch. Here you see SHA-1 hash of the commit that was last commit in BR2 branch. Okay, but let's now observe whether last commit object, merge commit object, has changed or not. Let's have a look at output of git log command, enter. We still see here this merge commit as last commit in commit history, but notice that pointer to BR2 branch that was here has disappeared. And that is correct, we have just deleted BR2 branch. Let's now quickly have a look at this commit object. Let me copy its SHA-1 hash and git cut file -p and paste copied SHA-1 hash, enter. And I still see same commit object as before. It has 2 parents, here and here. And that means that after deletion of the branch, Git hasn't deleted those commits made in feature branch. They are still in Git repository. And if I'll get back to GitHub Desktop, I'll still see those commits here on a list. Those 2 commits made in BR2 branch. Actually, what I don't like in GitHub Desktop is that it doesn't show us tree of all branches and moments when specific branches were created or merged. Probably in the future this feature will be added, but at the moment it is absent. That's why in the next lecture we will install another Git graphical user interface called source tree. And in source tree you will be able to observe tree with all previous changes. Okay, let's install source tree in the next lecture. I'll see you there. Bye bye. In this lecture we're going to install another graphical user interface for Git. It is called source tree. It is free and it is available for macOS and for Windows. And as you see on this screenshot, we can see here a graph that outlines all changes in Git history. And you are able to see when specific branch was created and when it was merged. Okay, let's download it. Let me click on this button, accept license agreement and click download. Archive was downloaded, let's unzip it. And let me drag .app file into applications folder. And let's open it up. Source tree. Enter. Click here open. And here you can see that source tree is provided by Atlassian and it is free. But they ask you to create an account at Bitbucket. Bitbucket is another hosting service like GitHub, and you are able to host your repositories there as well. So please create a new account at Bitbucket if you don't have one. It will take just a minute or two. Let me create my account as well. Type here my email. Continue. Full name. Bogdan Stashuk. Password. I'm not a robot. And agree and sign up. Let me check my email. Verify my email address. And click here on this button. Okay, account was verified, and here I am prompted to create unique username for Bitbucket Cloud. I'll enter my username, I hope it is available, and click continue. Okay, we are all set, let's skip these questions, and we are ready to work. Okay, let me close this tab, I don't need it anymore. And now I can get back to source tree application, click here Bitbucket Cloud, and here press Grant Access. Open source tree application. And we are all set, registration is complete. It seems that I have made typo in my family name. I'll fix it later on. Let me click continue here. Here you may also set author, email and name for all Git commits, but we have set it already before in global configuration of the Git, that's why don't do that now. And uncheck this checkbox and click done. Okay, finally we are all set, and here in this pane you'll see all remote repositories and all local repositories. At the moment I don't have any remote repositories published at Bitbucket, that's why this list is empty. Let's switch to local repositories here, and let's add our first project repository to source tree. I can simply drag this folder, first project folder, to source tree application like that. And our project was successfully added to source tree. Here you see that current branch is master. If I'll double click on the project, it will be opened in new window. And here you see what I have talked about before. There is entire graph history for all our commits. Let me make short overview of source tree interface and let's observe changes in our project here. But let's do that after the small pause. I'll see you next. Bye.
Just friendly reminder, now it's the best time to become my subscriber, smash a like button and leave a comment under this video.
In the previous lecture we have installed the source tree application and we have created account at Bitbucket. Bitbucket is another hosting service for Git repositories. And in this lecture let me make short overview of source tree. As you may already see here, it shows us graph that represents history of all commits. And the last commit that we made in our project is merge branch commit. And here you see description of this commit, current branch is master. Here you see SHA-1 hash of this commit, author, date of the commit. If you want, you can adjust the size of the columns. But unfortunately, I'm not able to adjust font size of entire application. At the moment, it doesn't support it by source tree. And from my point of view, it's not good. But anyway, let's go on. Here next, you may observe another commits made in your project. Also below here in this pane, you see all changes made in each commit. For example, in this merge commit, 3 files were added. If I'll click on every file, I may read contents of this file here in this pane. And for example, in this file 5.txt, 3 lines were added. And also below here you see description actually or details of every commit. For example, here you see complete SHA-1 hash of this currently selected commit. Here is short version of its commit. Here you see parent commits and actually there are links to those commits and I can click on every link and navigate to specific commit. For example, let's click on this one, clicked, and now this commit was selected. And recap that this commit was made in master branch before merging BR2 branch into master branch. Here again I see changes in this commit, file 8.txt was added, and here is commit SHA-1 hash, here is single parent actually, author and date of the commit. If I'll get back to last commit, you'll see also here labels, and that means that at the moment master branch points to this commit, head points to master branch, and that's why head points actually also to this last commit. Okay, here you also see quantity of the commits made in every branch. For example, you may see that in main branch we have made single commit, here it is. And in feature branch we see two commits, two dots here. And you can observe each of those commits separately. Please note that the main advantage of using three-way merge is that it preserves entire history of all changes. And you may see which author made commits in feature branches, and you may see what exactly was changed in every commit in feature branch. Okay, that's how history of commits looks like here in source tree. Also here in left pane you see list of all branches in your project. At the moment we have only single master branch. Also here in the left section you see other sections such as tags, remotes and so on. Here in the workspace I can select file status, for example, and when any files will be changed you'll see all changes here. Let's actually change quickly some files. Let's get back to Visual Studio Code and change, for example, file a.txt, like that. Changed file a.txt. Let's save the file and go back to source tree, and here you will see changes immediately. File a.txt was changed, here is line that was deleted, and here are 3 lines that were added. Here you can perform some actions with this file by clicking on those 3 dots. You can stage file, you can discard changes in file, you can remove this file or show this file in Finder. For example, if I click on this option, I'll see this file selected in Finder. Also here in this pane you are able to commit changes by writing commit message here down below. For example, modified file a.txt, like that. And let's commit those changes. Press commit button. And changes were committed. Now I don't see any modified files. And if I'll go back to history, I'll see another commit here, modified file a.txt, and master branch pointer has moved automatically to this last commit, and head has moved as well. You can also create new branches by clicking on this icon and type in here name of the new branch. Also, you are able to perform merging of the branches by clicking on this button, and before merging you'll see entire history of all commits. Okay, that's how source tree looks like. At the moment it has much more features than GitHub Desktop, and I can say that it's a full-featured graphical user interface for Git. Let me show you one more feature of source tree. By double-clicking on any commit here, for example this one, I can change working copy and check out actually specific commit. Let's click here OK. I'll move to detached head state, and now you see that head points directly to this commit, but master branch still remains here at this last commit. And if I'll go to terminal and refresh view here, I'll see that I am in detached head state. Here is shown hash of specific commit. And if I list files in working directory, I'll see only file for.txt. And that is a snapshot of our project at the moment when this commit was made. I can go back to last commit simply by double clicking on it, and now we are again at last commit. And if I'll get back to terminal, I'll see master branch here as actual branch, and if I list files here, I'll see several files including new files folder. Okay, that's how source tree looks like in action. Let's now proceed, and in the next lecture we will talk about merge conflicts. I'll explain you what is that and how to solve conflicts. I'll see you in the next lecture. Bye bye. Let's now discuss what is merge conflict. Notice that in our project, when we have merged BR2 branch into master branch, we didn't get any warnings and merge was successful. That's because in 2 different branches we have edited different files. And that's why merge was successful without any warnings and without any conflicts. But merge conflicts may appear when you have edited same files in different branches. Notice that merge conflicts are only possible when there are additional commits made in receiving branch after you have created feature branch. It is not possible to get merge conflicts in fast-forward merge when there are no other commits made after this commit. Recap that in fast-forward merge we simply move pointer of the receiving branch to feature branch and make picture like this. And again, no conflicts may appear in such case. Okay, that's why conflicts may appear only during three-way merge process. Remember that during merge process, Git takes three commits. This one, called ancestor, it is nearest common commit for both branches, and two last commits in two branches. And after that, it processes all commits in feature branch, this one, and this one, and tries to create single commit with all changes made in this feature branch. And this commit is called merge commit. But if during this process Git finds out that there are changes made in the same files in master branch, it will stop merging right before creation of the merge commit, and it will ask you to resolve conflicts. And you need to resolve conflicts manually. And you need to decide which changes you want to keep in merge commit. Changes from master branch, or changes from feature branch, or some other changes. You can edit files that have conflicts in any way you want. After editing files that have conflicts, you need to stage them and commit. And after that, Git will create merge commit automatically. Let's try it in action. And we will get back to our project, recap that our project has single branch, it is master branch. We will create new branch, make several commits in new branch, then return to master branch, make also one or two commits here, and we will edit same files in same places. And after that, we will try to merge new branch, let's say BR3 branch, into master branch and see what will happen. That is the plan for the next lecture. Let's start doing that after the small pause. I'll see you next. Bye. You know what is merge conflict, and now let's try to create conflict in our project, first project, and after that solve this conflict. Okay, we are now on master branch and there are no other branches. If you have other branches, please delete them. Let's create a new branch called BR3 branch. Git branch BR3. Enter, and let's check out this branch. Git checkout BR3. Enter. Let's list files in our project, ls. There are several files in the root of our working directory and there is new files folder. Let's now actually go back to Visual Studio Code and edit files there. Notice that the current branch here was changed as well and now it is BR3. Let's open Explorer with all files in our project and let's, for example, edit file in a new files folder, file5.txt. And let's edit this line, line 3. And I'll add text in the same line. This line was changed in BR3 branch, like this. Let's save those changes here, and let's change file 7, for example, as well. And let's change also this first line, just another file in the root of the working directory, and it was modified in the BR3 branch as well. Let's save and let's commit those changes. Let's go to source control here and let's type commit message directly here in Visual Studio Code. Changes made in BR3 branch. And let's commit changes. Notice that VS Code may ask you whether you want to automatically stage files when you click this icon. If it asks so, please agree. Okay, let's commit those changes. Changes were committed. Let's go to, for example, source tree and observe changes here. And you will see new commit here and you'll see that currently checked out branch is BR3. And here are changes made in BR3 branch. This line was modified and this line was modified as well. Okay, let's now go back to Visual Studio Code and change branch to master branch. I can click here on branch name and choose master. And now in master branch, let's edit same files, file5.txt and file7.txt. And let me modify this line like so. This line was modified again in master branch, like this. Let's save this file and let's modify file7.txt as well. Just another file in the root of the working directory. Let's remove this line completely and let's type line replaced in master branch, like so. Let's save changes, and now there are two files that were changed, and let's commit those changes in master branch. Let's type commit message file7.txt and file5.txt modified in master branch, like so. Let's commit changes. Changes were committed, and let's go back to terminal, for example. Press enter here and let's have a look at output of git log command, and here you'll see this last commit in master branch. If I'll switch to br3 branch, let's do that. Git checkout br3, and let's have a look at output of git log command here. You'll see this commit here in br3 branch. And of course, we don't see this commit from master branch, and we don't see last commit in master branch here. Let's now do merge of br3 branch into master branch. You know already that before merging, we need to check out receiving branch. Receiving branch in our case will be master branch. Git checkout master. Let's clear terminal and let's now do merge. Git merge br3. Let's press enter, and merge was unsuccessful. We see two conflicts. Merge conflict in new files file5.txt and merge conflict in file7.txt. Automatic merge failed, and we need to fix conflicts and then commit the result. That is a process of fixing merge conflicts. And here you see a yellow cross sign that indicates that there are changes in our project that were not yet committed. Let's have a look at output of git status command. Git status, enter, and here you'll see that we are on branch master and we have unmerged path. We need to fix conflicts and then run git commit. We can also abort git merge using this command, git merge and option -- abort. And here we see which files have conflicts. And we see that in both branches file7.txt was modified, and in both branches another file located in new files folder file5.txt was modified as well. And we need to solve conflicts in those files manually, and after that use git add command in order to mark conflicts in specific file as resolved. Before solving conflicts in those two files, let's also switch to Visual Studio Code and observe status there. Here in source control section, I also see two merge changes. And here we see that there is conflict in file7.txt and there is conflict in file5.txt. If I'll click on file7.txt, you'll see here strange picture with such syntax as less than arrows here, equal signs here, and greater than arrows here. And actually you see both versions of specific section in this file. You see section from master branch here, and you see section, this line, from br3 branch. And actually here you see that below. That is a section incoming change from br3 branch, and here is a section of the branch where head points now to. And now head points to master branch. And actually in VS Code we are able to take immediate action. We can either accept current change, we can accept incoming change, this one, or we can accept both changes. You can even delete entire section with conflicts and write some other text. Let's have a look at file5.txt here. And here you see similar picture. Notice that this line, first line in this file, was not changed either in master branch or br3 branch. And that's why we don't see any conflicts on this line and on second line. But we see conflicts on this line, because it was modified in master branch here and was modified in BR3 branch. Notice that in VS Code parts of those lines are hidden, and we can actually show entire lines here on this screen by pressing key combination Alt and Z, like so. And now we see entire text lines. Again, here we see change that was made in current branch, in receiving branch, and here is change made in feature branch. In our case, it is named BR3. And we can choose either this version of the change or this version of the change. And again, in VS Code, we can do that semi-automatic. We can accept current change, this one, accept incoming change, this one, or accept both changes. But it's still not the time to solve conflicts. Let's switch to GitHub Desktop and observe picture there. And here you'll see two conflicts as well. And those conflicts will be shown here in pop-up window. There is conflicted file file7.txt and there is conflicted file file5.txt. And we are prompted to resolve conflicts before merging BR3 into master branch. And if you have installed Visual Studio Code, you should see here direct link to open conflicted file in Visual Studio Code. If I'll press this button, this file will be opened here in VS Code. Okay, that's how GitHub Desktop works. Here we are also able to abort merge if you want. Let's also switch to source tree and observe changes there. So here is source tree, and here I see uncommitted changes. And here you also see that there are two conflicted files, this one and this one. And if I'll go to commit here, I'll see same picture as we saw in Visual Studio Code. Here are contents of file7.txt and here are contents of file5.txt. There are those sections that indicate conflict, and we need to adjust those sections manually before committing changes. But before doing that, let me get back to terminal and let's observe contents of Git staging area. But let's do that after the small pause. I'll see you next. Bye bye.
Don't forget to leave a like under this video, it's free.
In the previous lecture, we have created another branch, BR3. We have modified same files in BR3 branch and in master branch. And after that, we have tried to merge BR3 branch into master branch. And here we see that there are two merge conflicts in two files, in this file and in this file. And we have observed that Visual Studio Code and such graphical user interfaces as GitHub Desktop and Source Tree recognize those conflicts. And we are asked to resolve those conflicts manually. After that, we need to stage files and after that, commit those changes. But before doing that, let me show you how our Git staging area looks like now. In order to list files in staging area, we need to type git ls files command. Let me actually clear terminal first and type git ls files -s, enter, and here we see bunch of files. And I want to show you those sections, this one and this one, where there are three versions of file7.txt and file5.txt. And notice that every version is marked with separate number. There are numbers 1, 2 and 3 for file7.txt, and there are same numbers for file5.txt, 1, 2 and 3. Other files, such as file6.txt and file8.txt, have number 0. And now it's a perfect time to explain you what those numbers actually mean when you see them in output of git ls files command. Let's now use git cut file command in order to read contents of every such blob, because here we see actually blobs. Let me copy this SHA-1 hash and use git cut file command with option -p and paste copied SHA-1 hash, enter. And here you see text, just another file in the root or the working directory. Let's have a look at the next version of this file, this one. Let's copy its SHA-1 hash, git cut file, -p and paste copied SHA-1 hash, enter. And here I see another text line replaced in master branch. And let's finally have a look at this file. Let's copy its SHA-1 hash, git cut file,
-p and paste shown hash, enter. And here in this last blob, we see text that we have added in br3 branch. You can try to guess why we have here 3 versions of the same file. Try to think about that yourself. Okay, what does all of this mean? It means that first version of the file, this version, that was marked with number 1 here in this output, is version of the file that was common for both branches. And if I'll go back to diagram, we can say that this first version of the file was in our working directory at the moment of this ancestor commit. It was initial version of the file for both branches, master branch and feature 1 branch. Next version with number 2, this one, is the version of the file that we got in master branch, in receiving branch, in current branch that we want to merge to. And that is a file that is located in working directory at this moment of time, at this commit. And last version of the file, marked with number 3, is version of the file in feature branch, in our case br3 branch. And based on those 3 different versions of the same file, Git shows us merge conflicts. And it shows us merge conflicts actually in the files in working directory. Let's list files here and let's cut file7.txt. Enter. And here I'll see same picture as we have seen, for example, in Visual Studio Code. We see here version of the file where we need to resolve conflicts. And this version of the file is based on those 3 different versions in staging area. It's a combination of those 3 files. Same applies to file5.txt. Let's quickly have a look at contents of those files as well. Let's quickly clear terminal. Again, git ls files-s, enter. And let's cut file, this one, git cut file-p. And here are original contents of file5.txt. Next, git cut file-p, this shown hash, enter. Here is version from master branch. Here we see this change that was made in master branch. And git cut file-p and this version of the file, third version, like this. And here we see changes made in br3 branch. And again, 3 different versions of the same file, and those versions are located now in staging area. That's why all applications like Visual Studio Code, GitHub Desktop and Source Tree recognize all those conflicts, because they are located in staging area, and files that have conflicts are located now in working directory. Let's go back to terminal and let's have a look at contents of the file5.txt in working directory. And let's use cut command, cut new files/file5.txt. Enter, and here are current contents of file5.txt in working directory. Here you see 2 lines that don't have any conflicts, and that's because those lines are the same in all those 3 versions of the same file5.txt. But last line, third one, has differences. That's why here we see this section where we need to resolve conflicts manually. Here is again version from the current master branch, and here is version from other feature branch, in our case br3. Okay, I hope that it is fully clear now what those numbers in output of git ls files command mean, and here if you have conflicts you'll see 3 versions of every file with conflicts. Now it's time to resolve conflicts, and let's do that in the next lecture. I'll see you next. Bye bye. We have just observed that there are 3 versions of every file in staging area. I mean for file5.txt and file7.txt. And now let's resolve first conflict in file7.txt. Let's again use cut command in order to read contents of file7.txt. Here are those contents, and we need to decide which change we want to keep, either this change or this change. For this file, let's use nano editor and let's modify this file in command line. Nano and name of the file, file7.txt. Enter.
And here we can simply edit this text file. We need to decide which version of this change we want to keep, either this change or this change. Let's suppose that we want to keep this line replaced in master branch. And in this case, all remaining lines needs to be deleted. This first line, this one, and this one. Only one line will remain in file 7.txt. You can easily delete specific line in Nano Editor by using key combination Ctrl-K. Like that. Press cursor at the beginning of the line and press Ctrl-K, and line was deleted. Let's delete this line as well, this one and this one. And only one line will remain here in this text file. Let's also delete this new line like that, and cursor is now here at the end of this line. And let's write changes. Ctrl-O, file name to write file 7.txt, enter, and exit from editing, like so. And now if I list contents of file 7.txt, cut file 7.txt, I will not see any conflicts anymore. That's because we have just resolved this conflict in this file manually. Let's go to GitHub desktop and observe changes there. And here you'll see that there are no conflicts remaining in file 7.txt. It automatically has recognized that we have fixed conflicts in this file. Let's go to terminal, and here let's have a look at output of git status command. Enter, and here we still see that there are two files that were modified. But we have already fixed conflicts in file 7.txt file, and we can safely use git add command in order to mark conflict in file 7.txt as resolved. So git add and type here file name of the file, file 7.txt, enter. Git status, enter, and here we see that there are changes ready to be committed, modified file 7.txt, but there is still unresolved conflict in file 5.txt. Let's solve this another conflict using Visual Studio Code editor. And you'll see how simple it is in comparison to Nano Editor, for example. Let's do that after the small pause. I'll see you next. Bye. We have just resolved merge conflict in file 7.txt. And for that we have used Nano Editor, and in most cases using Nano Editor for resolving conflicts is not too convenient. Because if file is relatively large and there are multiple conflicts in multiple places in the same file, it will be really boring to do that in Nano Editor. That's why in most cases more sophisticated applications are used, like for example Visual Studio Code. And in this lecture I will show you how to resolve conflict using VS Code. But before doing that, let's have a look at contents of staging area now. Let's clear terminal and git ls files-s, enter. And now I don't see three versions of file 7.txt anymore. That's because we have already resolved conflicts in file 7.txt, and all other versions of the file were simply removed. And there is just a single version of this file. Let's quickly have a look at contents of this file. Git cut file, -p, SHA-1 #, enter, and here are contents of the file 7.txt. And that is a version of the file that is now located in working directory. Cut file 7.txt, and here you'll see same contents. And that is a version of the file that we have saved after resolving conflicts. But we still see three different versions of the file 5.txt, and that's because at the moment conflict in this file is not resolved. Let's resolve it using Visual Studio Code. If you're using GitHub Desktop, you are able to open conflicted file directly from here by clicking this button, Open in Visual Studio Code. Or if your project is already opened in VS Code, you can do that directly here. And now we see here that there are merge changes and there are stage changes. File 7.txt is marked as modified and it is already staged, but file 5.txt is located in Merge Changes section. That's why we need to resolve conflicts in this file first and after that stage it. Okay, let's resolve conflicts here in this file, file 5.txt in VS Code. We can simply choose one of options, either accept current change or accept incoming change or accept both changes. Again, please note that current change is change made in current branch, receiving branch, and in our case this branch is master branch. And incoming change is change from feature branch, from the branch we are merging into current receiving branch. And again, you need to decide which version you want to keep, either this version or this version. If you're not happy with any of those versions, you can simply delete this entire section like so, and write another version of the file. For example, something like that. But let's suppose that we are happy with version from the BR3 branch. Let's go back to this section, and here we need to simply click on Accept Incoming Change link here. Let's click on it, and VS Code will keep only this change from BR3 branch. If we are happy with that, we need to simply save the file, Command S, and now we are able to stage this file. But before doing that, let's quickly get back to GitHub desktop and see changes here. And now we see that there are no conflicts remaining, because we have resolved conflict in file 5.txt. And we can commit merge directly here in GitHub desktop. But we will do that in command line. Before that, let's add this changed file to staging area. And we can do that here in VS Code, for example, by pressing this plus icon. Stage changes. Let's click on this icon. And there are two staged files. Let's now go back to terminal, and here let's have a look at contents of staging area now. Git ls files-s, enter, and now there is just single version of file 5.txt, same as for file 7.txt, and that indicates absence of any merge conflicts. And if I look at output of git status command, I'll see that there are changes ready to be committed. All conflicts fixed, but we are still merging. And we need to enter git commit command in order to conclude merge. Please notice that we don't need to add any commit message here. Just enter git commit. Git commit. Enter. And here you are able to adjust commit message for this merge commit. Default message will be like this: merge branch and name of the branch we are merging into current branch. And here you'll see also conflicts that were resolved, conflicts in this file and conflicts in this file. And we have resolved both conflicts. Also, you may see that if you are not going to commit this merge, you need to simply remove file.git merge head. Let's now have a look at contents of this merge head file. Let me copy this path and open new tab in terminal like that. And the cd to our project, cd desktop / first project, enter. And cut, paste, copied path, enter. And here we see SHA-1 hash. It means that merge head file points now to specific commit. Let's have a look at contents of this commit object. Let me copy several characters here and git cut file -p and paste SHA-1 hash, enter. And here we see commit object. And this commit is a commit that was last commit in BR3 branch. It means that during merging process, Git creates another head file called merge_head. And it contains pointer to last commit in a branch, in a feature branch, that you are merging into receiving branch. If I'll have a look at contents of head file cut.git/head, I'll still see reference to refs/heads/master, because currently head points to master branch. You see it here as well. And if I'll have a look at contents of this master branch, cut.git/this path, enter, I'll see this SHA-1 hash. And that is a SHA-1 hash of last commit in master branch, this commit. Okay, that's what merge head file contains. It is simply pointer to last commit in feature branch. Okay, let's close this tab and let's get back to this text. I am happy with this default commit message, merge branch BR3. That's why I'll simply type :WQ. Save changes and exit from editing. Enter. And branch was successfully merged. I don't see any changes. Git status. Enter. Nothing to commit. Working tree is clean. Let's have a look at output of git log command. Git log. Enter. And here I see merge branch BR3 commit. There's a last commit here in this history. And in comparison to other commits, here we see this new line, merge and two SHA-1 hashes, this one and this one. And those two SHA-1 hashes actually represent two last commits made in two branches that were merged. This one is last commit in master branch, here is the SHA-1 hash, and this commit is last one in BR3 branch, here you see the SHA-1 hash as well, and here are changes made in BR3 branch. That's how merge works. We have merged BR3 branch into master branch, and we have resolved conflicts before merging. Let's quickly get back to source tree, and you'll see another branch that was merged here. There was single commit here in master branch, and there was single commit in BR3 branch. And here at this point we have merged BR3 branch into master branch. But notice that BR3 branch still exists, and we still see this branch here on the list. We have successfully merged this branch, that's why we don't need it anymore. That's why we can safely delete this branch. Let's go back to terminal and delete this branch here. Git branch -d br3. Enter, and branch was deleted. Now we have only single branch, and it is master branch. Okay, that's all about merging conflicts. And that's all for this section. In the next section, we will start working with remote repository, and we will start by creating account at github.com. I'll see you in the next section. Bye-bye.
Could you please make me a favor? Please leave a like under this video and share this video with anyone you know.
It's really nice when you have created Git repository locally on your computer and developed awesome features. But what if you want to share your work with others, and what if other collaborators want to participate on development of the same project? In such case, you need somehow to exchange files and folders of your repository with others. And the best way to do that is to use remote repository service. And GitHub is one of such services. I'll make actually a short overview of other hosting services, but GitHub is most popular. And in this section I'll tell you about GitHub, and I'll show you how to create some repositories at GitHub, how to make commits directly at GitHub, and so on. Also, I'll show you how to clone remote repository from your own account to your local computer. In the previous sections in this course, we were using primarily Git, and we have used local Git repository. And we have not yet published our local Git repository to remote service, to remote hosting service. And in this section, it's time to talk about remote hosting services for Git repositories. And before we have discussed that Git is actually distributed version control system, and GitHub is repository hosting service, and you are able to create Git repositories, for example, on your local computer, and after that upload them to GitHub hosting service. If you host your repository at GitHub and the repository is public, it means that any person in the world is able to clone or download your repository and use it locally on computer. Of course, you can create private repositories, and in such case they will be visible only to you and probably to your collaborators. There are also other repository hosting services, for example Bitbucket, and in one of the previous lectures we have created an account at Bitbucket, and we have done that in order to use source tree application locally on your computer in order to manage your local Git repositories. Of course, source tree allows you to manage your remote repositories as well, and we will try that, of course, later on in the course. But again, Bitbucket is one of another options for hosting your Git repositories. There are also other services like GitLab, and all of them allow you to host your Git repositories in the cloud. And when you host your Git repositories using one of the Git hosting services like GitLab, Bitbucket, or GitHub, you actually create backup copy of your local Git repository. And if you occasionally will delete your local Git repository, you will be able to clone it again from remote repository, and you won't lose any information. And of course, such services as GitHub allow you to collaborate with other people and work on the same repositories. And that is actually Git feature, and that's why Git is called distributed version control system. It allows you to perform simultaneous development in different branches in single repository. And of course, you can even create your own hosting service and host your Git repositories there. Git itself fully supports that. But such hosting services as GitHub have many different features. For example, you are able to perform code review, you are able to create pull requests, and you are able, for example, integrate your repositories with automation build systems such as Travis CI. And we will get back to it later on in the course as well. Okay, that is a short overview of repository hosting services, and now it's time to dive deeper, create a GitHub account, and create first repository at GitHub. In this course, we'll primarily use GitHub, and I'll show you how to create repositories there, how to clone repositories from GitHub. Actually, we have tried it before. And also, I will show you how to create pull requests, how to comment pull requests, and how to merge pull requests. Okay, let's get started, and in the next lecture, let's create GitHub account, and I'll see you in the next lecture. Bye.
When this video hits 1000 likes,
Ask for more?
okay. When this video hits 10,000 likes,
Even more? How is it possible?
okay. When this video hits 100,000 likes, I'll publish next 10-hour-long tutorial.
In this lecture, we will start off by creating GitHub account. Please create one account as well, but it would be better to create two GitHub accounts in order to follow me along, because I'll show you distributed development at GitHub using two accounts. Actually, I already have my account and my username is Bistashuk, and I can sign in here, sign in. And after signing in, I'll see here all my repositories. Also, I'm going now to create another GitHub account. For that, I have created another mailbox, and the name of the person will be Mike GitHubber. And now I'm going to create GitHub account for Mike. I'll do that in anonymous window here, github.com. Username will be Mike GitHubber, like that. Email will be mike.githubber@gmail.com. And I'll enter password for Mike. Okay, and let's click sign up for GitHub. It seems that I have entered weak password. Let me adjust password here. And verify account here, click verify, and touch the arrows to roll the image. Let's rotate this image, like so, and let's press done. Again. Like so, click done. Wonderful, I have verified my account. And finally, let's create an account by clicking on this button. Creating account, and here I'm able to choose subscription plan. There is of course free plan available, and it includes unlimited public and private repositories, up to 3 collaborators for private repositories, issues and bug tracking, and project management. There is also Pro plan available with additional Pro tools for advanced development flow, and this plan includes unlimited collaborators and bunch of advanced tools. We can click on this link and open it in a new tab and read about advanced GitHub products. For example, with GitHub Pro, you'll get repository inside graphs like pools, contributors, traffic, commits, and so on. Okay, let's close this and let's choose free plan here. Let's click on it, scroll down and click continue. Here are some questions, I prefer to skip them. Let's simply skip this step. Okay, let me verify email address. Here is verification link. Let me copy this link like so, go back to this tab and paste verification link here. Okay, we are done, email was verified. And now I am able to create the first repository as Mike GitHubber. Notice that now I am able to access a page with all my repositories using such a link as github.com/Mike GitHubber. Enter. And here we are, here is my public profile. At the moment, Mike doesn't have any repositories or projects or anything else. Also, you see that Mike hasn't yet contributed to GitHub. That's because we have just created account for Mike. Okay, let's now get started and let's create a very first repository for Mike. And let's do that in the next lecture. I'll see you next. Bye-bye. In the previous lecture, I have created new GitHub account. And now it's time to create new GitHub repository. And notice that owner of this repository will be you, and here you'll see your username. And let's now create first repository here. And let's give it name, for example, my first GitHub repository. Like that. Notice that I have used lowercase letters and dashes in order to separate different words. And actually it's a common convention to use such repository names. But actually you can use other names, for example, like so, my first GitHub repository, and it will be fully valid. But you're not able to use spaces in the names. If I'll try to add space here, you'll see that your new repository will be created as my dash first GitHub repository. Okay, let's get back to first version of repository name. My first GitHub repository. Like so. Here below you are able to add optional description for your repository. And let's add description, for example, here is my first GitHub repository. Let's get started with GitHub. Like so. Next, you are able to choose type of your repository. You can create either public or private repository. Public repository will be available for anyone in the world, and anyone will be able to clone or download your repository. But of course, by default, nobody except you will be able to contribute to your project. I mean, create commits, create branches, and so on. But of course, you are able to choose persons that will be able to have right access for your repository and make changes there. If you create private repository, it will be hidden from public, but of course you are able to choose persons that will be able to see your repository, clone it, and commit to your repository. Okay, we will create public repository. Let's choose this option. Next, you see that you are able to initialize your repository with README file. And it's a good convention to have README file in any repository. It is a file called README with extension .md, and it should be located in the root of your repository. You can skip this step and don't create README file if you are going to import existing Git repository. But now we are going to create first GitHub repository without importing existing one. That's why let's choose this option, initialize this repository with README file. Also, you are able to add git ignore file. We have not yet actually talked about git ignore, that's why let's don't add it for now. Also, you are able to add license for your repository. And here in a drop-down, you are able to choose one of actually open source licenses like mid license or general public license. We will not create any license file for this repository, we will initialize it only with README file. So make sure that this checkbox is checked and let's create repository. Let's click on this button. And here we are, first repository was successfully created. Here you can see some notifications like this, let's close it. And let's have a look at this window. Here you see username, your username. Next you see name of your repository, and here in a URL you see actually link to your repository. It is actually permanent link to your repository, and you are able to copy it and share with anybody in the world. Let me copy it and, for example, go here and paste link here. And that's how anybody will see your public repository. Here you'll see readme.md file, and here you'll see contents of this readme.md file. Okay, let's close this and get back to our repository. So, here you see that there is single commit. GitHub has automatically committed first changes. Also, you see that there is single branch. There is single contributor, and that is you. Okay, let's click on commits here, single commit. And here you'll see name of the commit, initial commit, author, my GitHubber, time when this commit was made, it was made 4 minutes ago. This commit is verified, and actually this means that GitHub has automatically added commit signature to your commit. If you'll click on this button, you'll see that this commit was created on github.com and signed with verified signature using GitHub's key. And the key ID is here. That is actually additional security measure for creation of commits at github.com, and those signatures are added automatically. Okay, Next, you see type of the commit, and this commit is actually a regular commit, and here you see, of course, SHA-1 hash of this commit object. Next, using this button, you are able to browse your repository at a specific point in a history. Actually, you can jump to snapshot of your project at this commit. We have now only one commit, and if I'll click on this button, I will jump actually to my repository that has only one single file, readme.md. We can get back to master branch by clicking here branches and choose master. Okay, now head points to master branch, and it is actually single branch that exists now in this repository. You can list all branches by clicking here, let's do that. And here you'll see only a single default branch, master. It was updated 10 minutes ago by myself. And here you see tag that this branch is default. Okay, let's get back to code, and here let's examine contents of our repository. Here actually you see working directory, and your working directory contains only single file, readme with capital letters .md. This file was added by first commit, and here you see SHA-1 hash of this commit, and here you see also commit message of this commit. Here below you see contents of readme.md file. It contains text my first GitHub repository, it is actually name of the repository, and here you see description of repository. Here is my first GitHub repository, let's get started with GitHub. And it means that GitHub has automatically created contents for readme.md file. You can actually edit this file, let's click on this pen, and let's add new line, readme.md file was just edited manually, like so. Let's scroll down, and here let's commit changes. And notice that we are doing all of that at github.com. We don't clone repository to our local computers, and we don't use local git. Here we are able to add the commit message and optional extended commit description. And notice that GitHub offers us default commit message like update readme.md. I am happy with this message, and I can choose either I want to commit directly to master branch, that is actually current branch, or you can create new branch for this commit and start pull request. We will try that later on, that's why now let's just commit directly to master branch. Let's commit changes. Click this button, and changes were committed. After committing, you'll see here new updated version of readme.md file. You notice that we are still on master branch, and if I'll click here on code, you'll see that there are now two commits. Let's click here, and now you'll see two commits, initial commit and update readme.md commit. And notice that all commits here are sorted from older commits at the bottom to more recent commits at the top. Here you see again SHA-1 hash of this commit. You can click on this SHA-1 hash, and you will see here details of commit object. Here you see commit message update readme.md. Here is a master branch where this commit was made. Here is the author of this commit. You see that this commit has single parent, and parent for this commit object is actually initial commit in this repository. And here you'll see SHA-1 hash of this commit object. And below you'll see all changes that were made in this commit. There is single file that was changed, and we have added two new lines here in this file. And new lines here are shown in green color, and here you'll see two pluses. You can click here on split view, and in such case you'll see two versions of the file. Old version on the left and new version on the right, and here you are able to compare actually two different versions. Okay, let's get back to unified view. Also here in this header you are able to switch view of specific file, and if I'll click on this button you'll see actually contents of this file, and here with green line you'll see that this line was added in new commit. Okay, that is a view of this commit object, and here below you are able to write comments for this commit. And let's write comment, for example, great job, like so, and press this button comment on this commit. And now anybody will see comment on this commit. If I'll copy again this URL, this public URL for my repository, like so, and go back for example here and paste this URL, enter, I'll see changes in this repository same as I see when I logged in at GitHub. I see two commits here. If I'll click here and click for example on this last commit, Actually, without clicking, you'll see that there is a single comment here. Let's click on it. And here below, I see comment that was just added. And notice that here I am logged into my personal GitHub profile, and that's why I am able to add comments as well. Let's add comment, for example, yeah, great job, indeed. And add comment. Okay, let's close this and let's get back to this view. And here you'll see that new comment was added here as well. It means that any person in the world will be able to add comments here. Now I'll ask you to add here comment as well. Please navigate to this URL, find this commit, or you can find other commit here in this repository and add your comment. Please do that, and after the pause we will continue and create one more commit in this repository. I'll see you next. Bye bye. At the moment there is just a single file in this my first GitHub repository, and name of the file is readme.md. Let's now create new file by clicking here Create New File button. Let's click on it, creating file, and here let's name this file hello-github.txt. And contents of this file will be simply hello GitHub, like so. And below let's commit those changes. And again, I am happy with default commit message create hello github.txt. I'll commit directly to master branch and let's click commit new file button. And changes were successfully committed. Now there are two files, and again notice that here I see contents of working directory at this moment of time. And now head points to master branch, and master branch points to very last commit here in this list. And last commit here is create hello github.txt. Same as for other commits, you see here SHA-1 hash for this commit. Let's click on it, and here you'll see contents of commit object in Git repository. Here is commit message again, here is master branch, here is author Mike GitHubber, here is parent commit for this commit, and it is a second commit in our project, and here is SHA-1 hash for this last commit. And below you'll see that one file was changed and there was a single line added to this file, hello GitHub. Okay, let's go back, and here where we see all commits, let's check out specific commit. And let's check out first initial commit, this one. Let's click on this button here, and you'll see that now we are looking at tree with such SHA-1 hash. And at this moment of time, there was just single readme.md file with such contents. And there was just single commit. It means that now head points to this first commit in our project. If I'll go back to list of commits here and click on this button near second commit, let's click on it, I'll see now two commits in our project. I don't see last txt file that was added in last commit, but I see changed readme.md file. And that's what you actually see when you check out specific commit locally on your computer. Recap that in order to check out specific commit on your local computer, you need to use git checkout command and add SHA-1 hash or part of it of specific commit you want to check out. Okay, let's go back to our project here, and automatically branch master will be checked out. Okay, at the moment there is a single branch in this repository, it is default master branch. And now it's time to try to create another branch using github.com. And let's do that in the next lecture. I'll see you next. Bye bye.
Are you still here, enjoying this tutorial? Then smash a like button and leave a comment. And don't forget to share this video with your friends and coworkers. Let's go on.
So far we have created new repository at github.com, and name of this repository is here. We have committed several times and there are 3 commits at the moment. But there is just a single branch. Here you see list of the branches if you'll click on this link. Let's now create new feature branch in our project. In order to create new branch, you need to click here in this drop down and type name for new branch here in this input. And let's name new branch feature-1, like so. And click here create branch feature 1. And this branch will be created from master branch. Recap that master is current branch. Okay, let's click here. And new feature 1 branch was created. And immediately after creation, this new branch was automatically checked out.
And notice here message that this branch is even with master. And that means that master branch and feature1 branch point to the same commit object. And latest commit has this SHA-1 hash. Here again you see contents of working directory, and of course here you see same files that you saw in master branch. Okay, let's now create new file in this feature1 branch and commit changes. But let's do that next. I'll see you in a bit. Bye bye.
We have created two branches, and at the moment in this my first GitHub repository there are two branches, feature1 branch and master branch. You can switch between branches here. I can switch, for example, to master branch and then switch back to feature1 branch. And at the moment the feature1 branch is even with master, and that means that feature1 branch and master branch point to the same commit. And SHA-1 hash of this commit you see here. And also you can observe that there are two branches by clicking here on this link, and you'll see that there is default master branch and feature1 branch. Here you can click on yours button, and here you'll see only branches that were created by you. If you'll click here on active branches, you'll see all branches that you or your collaborators are currently working on. If some branches were not updated for a long time, they will be moved to stale branches list, and you'll see them here in this list. You can list all branches by clicking here on this all branches list, and here you'll see master and feature1 branch. Okay, wonderful. Let's get back to code and let's update feature1 branch. Make sure that you will choose feature1 branch here on the list, and let's create new file here in feature1 branch. Let's click on create new file button here, and let's now create folder, and in that folder let's create new file. You can simply create folder here by simply typing its name. For example, let's create a folder named feature like that and add slash. And in such case GitHub will create folder feature automatically, and here now in this folder we can create new file. And let's name this file, for example, list.txt, and the contents of this file will be, for example, list of 1, 2, and 3, like so. And let's scroll down and immediately commit those changes. And notice that we will commit directly to feature1 branch. And let's modify this default commit message and write, for example, file list.txt was created in the feature1 branch, like so. And let's commit new file. Pressed. And changes were committed. And notice that now this branch is one commit ahead of master. And that means that changes in this feature1 branch were not yet incorporated into master branch. At the moment we see now contents of feature folder, and this folder contains one file list.txt. You can go to root of your repository by clicking this link, and here you'll see two files, readme.md and hello.github.txt, and feature folder that we have just created in feature1 branch. And notice also this yellow notification that shows us that feature1 branch was just pushed. It is actually new branch here in this repository. And it is really useful notification. You'll see such notification anytime when anybody of your collaborators will push any branches to your remote repository. Also here in this notification you'll see button compare and pull request, where you are able to compare branches and create new pull request. We will create pull request a bit later. For now let's get back to master branch. Let's choose master from this list. And here you'll see that contents of working directory were automatically updated and we don't see feature folder. And that's because feature folder was created in feature1 branch. And again, here you see same notification that feature1 branch was pushed 4 minutes ago, and here we are able to compare and create pull request. Okay, we have successfully created new branch here using GitHub interface. And now let's clone this remote repository to our local computer. And let's do that next. I'll see you in a bit. Bye bye. So far we have created a new remote repository called my first GitHub repository. And in this repository there are currently two branches, master branch and feature one branch. And now feature one branch has some changes that were not yet merged into master branch. And now at this moment of time, let's clone this remote repository to our local computer and observe changes made remotely. And for that you need to press clone or download button here and copy this URL. And after copying URL, let's go to terminal here and let's open new tab. I am prompted to update OMIZH. Let's do that quickly. Updating. Okay, we are good to go. Let's clear terminal and let's cd to desktop. And I'll clone remote repository to desktop. Recap that at the moment on desktop there are two folders. First project, and that is a Git repository we were working on in previous sections, and Hello World project, and this project recap was cloned from other remote repository. But that repository was not owned by us and we are not able to push to that remote repository. That's why now we have own remote repository, and now after cloning our own remote repository, we will be able to update it locally and after that push changes to our remote repository. Okay, let's now clone remote repository to desktop. Let's again clear terminal and type git clone and paste copied URL. Recap that we have copied this URL here by pressing this button. Structure of this URL is following. It contains HTTPS in front of, and it means that we will use HTTPS protocol in order to clone remote repository. HTTPS is secure version of HTTP protocol and it utilizes TLS protocol for encryption of entire communication. Then comes hostname, it is github.com. Then comes username at GitHub, here is my GitHubber as username. And after that comes name of repository, remote repository that is owned by this user. And name of remote repository is my first GitHub repository. And this repository has extension .git. Okay, we are good to go and let's clone this repository to our local computer. Enter, cloning, and cloning was successful. Notice that this repository contains at the moment 13 objects, and those objects were downloaded now to my local computer. And notice this message cloning into my first GitHub repository. What does it mean? It means that Git automatically creates folder on your computer with the same name as your repository. And in our case, name is here, that's why Git has created folder with such name, my first GitHub repository. And now if I list folders here on desktop, ls-l, you'll see this new folder that was created automatically. Now we can go into this folder, let's do that, cd my first GitHub repository, enter, and list files here, ls-la. And now I'll see contents of working directory in this repository. I see two files, readme.md and hello-github.txt. And also I see hidden folder .git. That means that this folder is under git control. And actually I see that this folder is under git control here in command prompt, git colon and name of current branch. And current branch is default branch master. Okay, wonderful. We can have a look at the contents, for example, of readme.md file. Cut readme.md. Enter, and here you see contents of readme.md file. And notice that this file is up to date with version of the file in remote repository. Let's get back to remote repository, and here you'll see contents of readme.md file. I can actually click here and you'll see raw contents in text format. And those contents are the same as you see here. Okay, we can also read contents of another file, hello-github.txt, this one. Cut hello-github.txt. Enter. And contents of this file, of course, match contents of the same file in remote repository. Let's go there, go back and click on hello-github.txt file. And here you see same hello GitHub text. Okay, great. That's how you can clone remote repository to your local computer. And after cloning, we will be able to make any changes in this repository locally, and after that update remote repository using git push command. But before doing that, let's discuss how actually your local repository is connected to remote repository and how Git knows that there is a remote repository for this local repository. And let's discuss this after the small pause. I'll see you next. Bye bye.
Are you already a subscriber? If no, please subscribe. I publish a lot of tutorials like this one.
Okay, we have just cloned remote repository to our local computer. And now there is a remote repository and local repository. And at the moment our local repository is connected to remote repository. And now we can interact with remote repository. Notice that remote repository is actually the same as local repository in terms of structure. There is working directory, staging area and Git repository, same as on your local computer. There is working directory, staging area and Git repository. But now when you have two repositories, remote repository and local repository, there are multiple questions that should be answered. First, what happens when you update your local repository? Does remote repository update itself automatically or not? Answer is no. You need to push your changes from local repository to remote repository. Another question. What happens when remote repository updates? Does your local repository update automatically or not? Answer is no. You need to download all updates manually from remote repository. If you use any Git graphical user interfaces like GitHub Desktop, SourceTree or Visual Studio Code, you are able to semi-automate this process. What does it mean? You may see which changes were made in remote repository, and after that you can decide whether you want to download those changes or not. Another question. Who has rights to update your remote repository? I mean, make changes locally on computer and after that push changes to your remote repository. Answer is following. Of course, not anybody in the world is able to do that, is allowed actually to do that. You need to grant access for writing to your remote repository. And last question here. Who has rights to read your remote repository? Answer is following. If your repository is public, anybody in the world is able to read from your repository. And actually in the previous lecture we have cloned remote repository. And Git didn't ask us for any username or password. We have simply used URL in order to clone a remote repository. And that can be performed by any person in the world. Again, that is possible when your repository is public. When it is private, only selected people can download your remote repository. Okay, that's our key points regarding remote repository. But I have not yet answered main question. Why do we actually need remote repositories? And let me answer this question next. I'll see you in a moment. Bye bye. Let me now explain you main idea behind using remote repositories. Let's suppose that there is my computer, there is a remote repository hosted for example at GitHub or Bitbucket or GitLab or any other hosting service, and there is Mike's computer, that is another person that works on the same project as me. And let's suppose that we have created our remote repository, and after that we have cloned remote repository to our local computers. And now at this moment our repositories are consistent. There is same repository on my computer, on Mike's computer and on remote server. And let's suppose that at some moment of time I have decided to update repository. And for example, I have created new file here, I have added it to staging area and I have committed changes. And that means that now my repository is different from remote repository and of course is different from Mike's repository. If there would be no remote repository, I could actually be able to send updates directly from my computer to Mike's computer. I can say, hey Mike, there are some changes, here is new file, please update your repository as well. If there are only two collaborators, of course, such approach is possible. But if there will be tens or hundreds of collaborators, it would be really difficult to manage such updates. And that's where such single point of interaction as a remote repository comes in. Now all communication happens through the remote repository. And when I have made some changes in my Git repository, I can push those changes to remote repository. And now new file will be created here as well. And now my repository and remote repository are consistent. And now when Mike will see that his repository is inconsistent with remote repository and that there are some changes that were not yet downloaded to his computer, he will pull this remote repository and update his local repository. And now this new file will be created here on his computer as well. And now all three repositories here on Mike's computer, on my computer and on remote server are consistent again. That's how updating process happens. But of course, for that I need to have right access to remote repository, and Mike simply needs to have read permissions in order to take those updates and download them to his local computer. But of course, when Mike wants to make some changes and update remote repository, he needs to also have right permissions. Okay, that's how interaction happens. And again, same approach applies when there are more computers than just two, as in this example. When there are hundreds of computers, then my update that was pushed to remote repository should be downloaded by all other collaborators in order to stay up to date with remote repository. Okay, that is the main purpose of using single remote repository for every your project. It is a single point of interaction between all collaborators. So far you know how to update your local repository, I mean how to make changes in your working directory, how to add those changes into staging area, and how to commit changes to your local Git repository. But if you want to interact with remote repository, another Git commands should be used. And those commands are git pull, git push, and git fetch. And let's discuss those commands in the next lecture. I'll see you there. Bye bye. For this section you require a GitHub account, and in the previous section I have shown you how to create new GitHub account and how to create new remote repositories. Also you know how to clone remote repository to your local computer. I will use basically two different accounts, my personal GitHub account and the new account that I have created specifically for this course, account of Mike GitHubber. In this section we will dive deeper into relations between local repositories and remote repositories, and I'll explain you how to connect local and remote repository and how to synchronize changes. We will use such commands as git pull, git push and git fetch. And you'll understand that git pull operation is actually git fetch plus git merge, and we will try to perform same operation as performed by git pull manually using first git fetch and after that git merge. Also I'll explain you what is tracking branch and how to create new tracking branches. You'll also understand how to list remote branches and local branches. When you work with a remote repository, it is possible that merge conflicts will appear during, for example, git pull or git push operations. And in this section I'll also explain you how to resolve conflicts while working with a remote repository. And finally, you will fully understand how to make local and remote repository fully synchronized. We have just discussed that the main purpose of using remote repositories at one of hosting services like GitHub or Bitbucket is to exchange updates between different collaborators through one centralized point. And now let's discuss Git commands that are used for interaction with remote repositories. And those commands are git push, git fetch and git pull. I have added those actions on this diagram, and we have discussed it before in the course, and such commands as git add, git commit and git checkout are used in local Git repository, and you know what they actually do. Let's quickly recap them. If you make any changes in working directory, for example add new files, modify files or delete files, you can stage those changes and add the changed files into staging area or index, and for that you should use git add command. After that, when files are in staging area, you can commit changes by using git commit command. And after committing changes that you have made in your project will be written to Git repository. And at any moment of time, you can check out specific version of your project by using git checkout command. And you can check out either specific branch or specific commit. And when you check out a specific commit, you move into so-called detached head state, when head points to specific commit instead of pointing to specific branch. Okay, now let's add the commands for interaction with remote Git repository. And first command will be git push. Notice that I have added this pushing to remote step after commit step. It means that usually you push to remote Git repository changes that were already committed in local Git repository. It means that you take some of the features in the project, you work on this feature, add new files, modify files, delete files, and so on. After that, when you are happy with those changes, you add them into staging area and commit changes. Of course, you are able to commit changes and stage them in one command using git commit command with -a option. And when changes are committed and are located in your local Git repository, you are able to push those changes into remote Git repository. Of course, for that you need to have right access to this remote Git repository, and not anybody in the world is able to push to your own remote repository. You as owner of your Git remote repository are able to grant access for writing to your repository. But please note that it's a good convention to push to remote repository only changes that were fully tested locally on your computer and when you are 100% sure that your changes will not break anything in a project. Okay, so that is a git push command. If remote repository was updated and you want to get those changes and apply them to your local Git repository, you could use other commands like git fetch and git pull. So what is the difference between those two commands? As you may see here on this diagram, git fetch command doesn't update your local working directory. It also doesn't update staging area. It means that files and folders you are currently seeing in your project will not be affected by git fetch command. That's because git fetch command only updates your local Git repository. It doesn't touch staging area or working directory. For example, if new branch was created at remote Git repository, of course it will not be created automatically in your local Git repository. You know that every branch is actually just pointer to specific commit, and all branches are located in .git folder in refs/heads subfolder. And that means that using git fetch command, your local refs/heads master folder in your local Git repository will be automatically updated, and you will be able to see new branches that were created at remote Git repository. That's git fetch. Now let's discuss what is git pull. As you may see, this command will write changes into your working directory. Actually, under the hood it is two-step process. First, Git performs git fetch and downloads updates from remote repository to your local Git repository, and after that it merges changes, if any, into your local working directory, and of course changes are applied to your staging area. What does it mean? For example, if currently checked out branch in your local Git repository is master branch, and in master branch in remote Git repository, for example, new file called newfile.txt was created, after git pull command, this new file will be created in your working directory as well. And certainly staging area will be updated as well. That's how git pull works. It is actually destructive, let's say, operation that will write files into your working directory. Okay, again, git fetch will just update your local Git repository and will not affect in any way staging area and working directory, and git pull will write changes to your staging area and working directory. But now question, how actually your local Git repository knows where to push and where to pull from. How your local Git repository is connected to remote server. Let's talk about it in the next lecture. I'll see you next. Bye bye.
Still watching? I suspect you have not smashed the like button right under this video. Please do that right now.
We have discussed what is remote repository and what is local repository. And you know that such commands as git pull, git push and git fetch are used for interaction with remote repository. And in one of the previous lectures, we have cloned remote repository from our own GitHub account to our local computers. And now let me answer the question how actually our local repository is connected to remote repository. By default, when you clone remote repository to your local repository, Git automatically creates binding between remote repository and local repository. And it creates default remote repository for your local repository. And default name of remote repository is origin, like so. You can actually connect your local repository to multiple remote repositories, and in such case, every remote repository will have different name. And when you perform, for example, push, pull or fetch operations, you actually choose which remote repository you want to interact with. And by default, if you, for example, just write command git pull, you will pull from origin, from default remote repository. Let's now actually jump into command line and verify how list of remote repositories looks like there. Okay, let's go to terminal and let's verify list of remote repositories here in cloned repository. Recap that we have cloned this repository in one of the previous lectures, and name of this repository is my first GitHub repository, and remote repository is actually located at our GitHub account. And now using command git remote, you are able to list all remote servers for your local Git repositories. Let's press enter, and here you'll see default name of remote server, origin. You can add here -v option, and in such case you'll see two lines. Origin, then URL of your remote repository, and in parentheses fetch. Let me make it a little bit smaller, like so. And next line will be the same with same URL, but here in parentheses you'll see push. And that means that the same URL will be used for fetch and push commands. Okay, that's how default Git remote repository looks like in our cloned repository. Let's now actually get back to our first project and recap that we have not connected this project to any remote repository. Let's clear terminal here, and let's use git remote command here. Enter, and of course we see nothing here. There are no remote servers for this project. Okay, let's now go to, for example, Hello World project. Recap that we have cloned this project from one of public Git repositories. Let me clear terminal here, and let's type same command git remote. It actually doesn't matter in which branch we are currently in. As you may see here, we are in new feature branch. Let's press enter here, and you'll see again same default name for remote server, origin. Let's add here -v option like so, and again you'll see two lines. Origin, then URL we have used to clone this repository to our local computer, and here you'll see again fetch, and on the next line with same URL you'll see push. Okay, let's go back to our project. And let me list here branches using git branch command. And here I'll see only one branch master. But remember that in our remote repository at GitHub, we have created another branch called feature1 branch. But here I don't see this branch on the list. And that's because by default git branch command lists only your local branches. And by default Git will not create corresponding local branches for all remote branches. And now it's time to answer the question how you can get list of all remote branches and how you can actually see all branches including local and remote. Let me answer this question in the next lecture. I'll see you next. Bye bye. At the moment, in our remote repository called My First GitHub Repository, there are two branches, master branch and feature1 branch. And we have committed already changes in feature1 branch. After that, we have cloned repository to our local computer, But if I list branches here using git branch command, I see only default master branch. And that means that by default, Git will not create local branches for every corresponding remote branch. And now let me answer the question how you can actually list all branches available locally and on remote server. For that, you can use git branch command with option -a. Let's press enter here, and now you'll see all local branches and remote. And notice that every remote branch has prefix remotes, and that is an indication that this branch is actually a remote branch. After that, after slash comes name of remote Git server. And here you see name of default remote server, and we have talked about that in the previous lecture. This default name is origin. And after origin comes name of the branch. But you see here that on first line there is actually head pointer, and it shows us that head now points to origin/master branch. And it is actually indication for our local Git that master branch is default branch in remote Git repository. That's why after checking out this project, we have automatically switched to master branch. It is default branch for this remote repository. Next, you see list of all branches, and here you see feature1 branch and master branch. And again, both those branches are located at remote Git repository. Actually, you are able to get list only of remote repositories. Let's close this, and for that you can type git branch with option -r, like so. Enter, and now I see list only of remote branches located at remote Git repository. And notice that this list doesn't contain remote prefix because I have used -r option, and in such case you'll see only actually name of remote Git repository. Okay, let's close this list, and again please notice that if you just type git branch like so, you'll list only local branches. If you want to see all branches, please add -a option like so. Okay. That's how you can list remote and local branches. Now it's time to explain you what is tracking branch. And in our case, there is a single tracking branch called master, and our local master branch tracks remote master branch. Let's discuss what is tracking branch in the next lecture. I'll see you next. Bye bye. Now you know how to list all remote branches and local branches. For that you should use git branch command with -a option. And now it's time to discuss what is tracking branch. Tracking branch is your local branch that is connected to specific remote branch. And by default, when you clone any remote repository, Git creates only one tracking branch locally in your local Git repository. And name of this branch matches default name of the branch in remote Git repository. And if I'll go to our repository to branches list here, you'll see that master branch is tagged as default branch. And you actually can change your default branch by clicking on this button. Change default branch and choose your new default branch. For example, you can change default branch to feature1 branch and then click button update. Okay. That's default branch in GitHub repository. And this default branch, in our case master, will be automatically created in your local Git repository, and Git will automatically check out this branch. And this will be first tracking branch created after cloning of remote repository. But let me actually proceed with explanation what is tracking branch. Again, tracking branch is your local branch in your local Git repository that is connected to specific remote branch in remote Git repository. And on this diagram you see three tracking branches: master, release, and br2. All those branches are present in remote repository and in local repository. Also notice that in this diagram there is br1 branch that is present in remote repository but is absent in local repository. And that means that there is no local tracking branch for br1 branch. Also, you may notice another branch called temp that is present locally in local repository, but there is no corresponding branch in remote repository. And that means that this temp branch is not tracking branch. Of course, you can create remote tracking branch for this temp branch by creating remote branch in remote repository. Same for BR1 branch. Simply by checking out remote branch, you will create corresponding local BR1 branch in your local repository, and this local branch will be automatically connected to remote branch. And this branch will be tracking branch as well. And we will try that in the next lecture. But please note that after cloning, Git will create only single tracking branch. And in our case, picture looks like this. Let me remove all those branches and those two branches. And in our case, there are two branches in remote Git repository, master and feature 1. But after cloning, Git has created only single local branch called master. And this branch is tracking branch. Let me actually show you how you can verify which branches are tracking branches and which are not. Let me get back to terminal and clear terminal here, ensure that you are in this repository that we have cloned from our remote GitHub account, and here type git branch -vv, like so. Enter, and here you'll see all local branches including corresponding remote branches. Here in brackets you see origin/master, and that means that your local master branch is tracking branch, and it tracks origin/master branch. And here actually you see message of the last commit made in this branch. And here you see actually SHA-1 hash of last commit object in Git repository. And if I'll go back to remote repository, click on code here and click on commits, you'll see that this commit with commit message create hello github.txt is last commit in this repository, in master branch. And here is SHA-1 hash of this commit. And this SHA-1 hash with commit message are the same as you see here in this output. Again, using git branch command with option -vv, you'll see information about tracking branches. And now there is only single tracking branch in our local repository. It is master branch. And remote corresponding branch is origin/master. Okay, wonderful. Now let me show you how you can actually create another tracking branch in this repository. Recap that there is another branch called feature1 branch, and now it's time to create our local feature1 branch that will be tracking branch for this remote branch. Let's do that in the next lecture. I'll see you next. Bye bye.
Hey, did you see my new YouTube video about Git? What? It is piece of what? You didn't like it? What?
In this lecture, we are going to create another local tracking branch for remote feature1 branch. Recap that there is already a single tracking branch in our cloned repository, and the name of this branch is master. Let's now create another tracking branch feature1. Let's switch to terminal, and here again you see that master branch has remote tracking branch origin/master. But if I'll use git branch command with option -a, enter, I'll see that there is another feature1 branch in remote repository. And I can pretty easily create local tracking branch for this remote branch. Let's do that. And for that we should simply use git checkout command. Let me clear terminal and type here git checkout and type name of the branch, simply without any prefixes, remotes or origin. Let's press enter, and command was successful. Here you see message that branch feature1 was set up to track remote branch feature1 from origin. And this new local branch feature1 was automatically checked out. And here you see this information as well. Okay, let's now enter git branch command with option -vv. Enter. And now here we see two branches, feature1 and master branch. And notice that master branch still tracks remote origin/master branch, and feature1 branch now tracks remote origin/feature1 branch. And that means that now we have two local tracking branches, feature1 and master. Let me reflect this change in the diagram. Let me switch to it, and here now we have two local tracking branches. Let me copy this, move here, and now here we have local feature1 branch. Let me adjust color of this branch as well, like so, and that's it. Now we have two local branches and two remote branches, and our local branches are tracking branches for remote branches, master and feature 1. Let's get back to terminal and let's try to delete local feature 1 branch. Let's close this and let's type git branch -d feature 1. Enter. Of course, I'm not able to delete branch that is currently checked out. Let's switch branch to master. Git checkout master, like so. Enter. And let's try to delete feature 1 branch again. Enter. And branch was deleted. But please remember that Git allows us to delete the branch using -d option only when branch was merged already. But this branch feature 1 was not yet merged, either locally or remotely. But this branch exists in remote repository, and here you see warning that this branch was merged to refs/remotes/origin/feature1, but not yet merged to head. But Git has allowed us to delete local branch because there is corresponding feature 1 branch in remote repository. Let's now list local branches again. Git branch. Enter. And now I see again only single master branch. And this branch is still tracking remote origin/master branch. Okay, that's how you can remove local tracking branch. Now let me clear terminal and let's create a local tracking branch for feature 1 branch again. Git checkout feature -1. Enter. And branch feature 1 was created again. Now let's proceed, and in the next lecture let me demonstrate you another way of obtaining information about tracking branches. I'll see you next. Bye bye. Now we have two local tracking branches, feature 1 branch and master branch. And if I'll type git branch, you'll see this information here. There are two branches. And with option -vv, you'll see that feature 1 branch tracks remote origin/feature 1 branch, and the master branch tracks origin/master branch. And recap that origin is simply default name for remote repository. Okay, now I'll show you another way to see information about tracking branches and remote repository. Do you remember command git remote? This command will show us list of remote Git servers. And with option -v, you'll see actually two URLs for fetching and pushing, and in this case, those URLs match. But there is extension of this command, and if you'll type git remote show and then name of the remote server, origin, enter, you will see not just URLs that are used for fetch and push. Instead, you will see also additional information, such as head branch, in our case it is master, and it is a name of default remote branch in remote repository. Here you see list of all remote branches, feature 1 and master, and now both branches are tracked because we have two corresponding local branches. Here you see them. Local branches configured for git pull and local refs configured for git push. And that means that now our local branches, feature 1 branch and master branch, can be used for git pull and git push operations. That's because those branches are tracking branches and they have corresponding remote branches. And when you'll enter git pull command, feature 1 branch will merge with remote feature 1 branch. Same for master branch. We will take remote master branch and then merge it into local master branch. When you'll perform push, your local changes from feature 1 branch will be pushed to corresponding remote feature 1 branch. Same for master branch. When you make changes in your local master branch, you will push them with git push command to remote master branch. And you'll see here in parentheses that both branches, feature 1 branch and master branch, are up to date. And that means that remote branches and local branches are in sync. There are no changes either in remote branches or in your local branches. Please remember this command, it is really useful and it shows us actually entire information about connection between your local repository and remote repository. Now let's proceed, and in the next lecture we will try to create new remote branch and observe whether we will see this remote branch in git branch-r list. Let's do that in the next lecture. I'll see you there. Bye bye.
You know what? Watching long videos here at YouTube is not really convenient. That's why I recommend you to enroll to the full-length course, link is up in the description below. And in this course, all lessons are split into different videos and are organized into different sections. I'll see you in that course.
Let's now create new branch in remote repository and observe whether we will get information about this new branch in our local repository. In order to create new branch, please click on this button and type here in this field name of the new branch, and let's name it, for example, temp branch. Let's click create branch temp, and new branch was created. Now this new branch is even with master, and that means that temp branch and master branch point to the same commit, and here is SHA-1 hash of this commit. Okay, wonderful. Let's now get back to terminal and let's try to list remote repositories now. Git branch -r, enter, and now I still see only two branches, feature 1 branch and master branch. I don't see temp branch on this list. And that's where git fetch command comes in. With this command, you will be able to fetch remote changes and download them into your local Git repository. But recap that this operation is not destructive, it will not modify your working directory or staging area. It will not merge any remote changes to your local changes. Okay, let's now enter git fetch command. And please notice that you can enter this command independent of the branch that is currently checked out. You can enter it either here or when you will check out other branch, for example, master branch. Okay, let's type git fetch. Git fetch, enter. And you'll see that this fetch was performed from this URL. And remember that this URL is configured here in this list, git remote -v, and you'll see this URL here. It is configured both for fetch and push for default origin server. And it means that after entering git fetch command, Git looks for default origin remote server and takes URL that is configured for fetch here. And here you see on this line that new remote branch called temp was created on remote server origin. Let's now try to look at list of local branches again. Git branch -vv, and I still see only two local branches, feature 1 and master branch. But if I'll enter git branch -r, remote branches, I'll see temp branch here on the list. And that means that after git fetch command, Git has not created automatically any local branches. And we still need to check out remote branch if we want to create corresponding local tracking branch. Let's now do that. Git checkout temp, enter, and only now local temp branch was created, and now it tracks remote branch temp from origin. And we were automatically switched to temp branch. And now we should have three local branches, git branch -vv, enter, and yes, here they are, feature 1, master and temp, and currently checked out branch is temp. Let's close this and let's type also git remote show origin, enter, and here you'll see same information as well. Okay, now let's try to delete this temp branch in remote repository. Let's go here and let's click on branches list here, go to all branches, and delete here temp branch by clicking on this icon. Let's delete branch, and branch was deleted. Let's go back to terminal and try to enter same command again, git remote show origin, enter. And now we will see here in this list of remote branches that remote branch origin/temp is now stale. And we can use command git remote prune in order to remove this branch from this list. Let's use this command, copy it, paste here, and add here origin, like so. Enter. And this branch origin/temp was successfully pruned. Let's go back to this output, enter. And now I'll see only two remote branches, feature 1 and master branch. But I still see here local temp branch. Let's have a look at output of git branch with option -vv, enter. And I'll see now that there is local temp branch that is configured for tracking of remote origin/temp branch, but this remote tracking branch is gone. And that means that remote branch temp at origin server, that is tracking branch for this local branch, was removed. But of course, you are able to create this remote branch again by using, for example, git push command. When you will make any changes in this temp branch and decide to push them to remote server, remote branch will be created in such case again. But for now, let's simply remove this local temp branch. Let's close this, let's check out, for example, master branch. Sorry, typo, should be master. And now let's type git branch -d and type here name of local branch, temp. Enter, and branch was successfully deleted. Let's list branches now, git branch -vv, enter, and now temp branch is absent here on the list, and if I'll enter git remote show origin, I will not see temp branch here on this list as well. Okay, wonderful. Now you know how to fetch changes from remote repository. And now it's time to proceed and talk about git pull operation. Please notice that in this output you don't see pull URL. You see only fetch URL and push URL. And that's because git pull operation is performed partially, only locally in your Git repository. And git pull is actually two-step process. First, you fetch remote changes, and after that, merge them into your local changes. Let's discuss git pull in details and try an action in the next lecture. I'll see you there. Bye bye. In the next few lectures, we will discuss git pull. And git pull actually combines multiple concepts that we have discussed before. First, in order to perform pull, we need to have local tracking branch. Next, you need to know how merge works, and recap that we have talked about merge in one of the previous sections. And the merge of the branches can be performed either using fast-forward approach or three-way merge. And also you need to know how git fetch works. We have tried actually git fetch in action in one of the previous lectures, and we will try that also in those lectures. And you need to know what happens when you perform merge in your local Git repository. Actually, after merge, Git updates your local staging area and working directory. But there will be some things that are new for you. For example, I'll explain you what is fetch head. Okay, let's have a look at this diagram in details, and here I'll explain you how actually git pull works. In several words, git pull merges remote branch into current local branch. And of course, current local branch should track remote branch. And under the hood, git pull is actually two-step process. First step, Git performs git fetch and fetches all updates from remote repository and writes them into local repository. For example, all new branches, all new commits that were created in remote Git repository will be also created in your local Git repository. And we have tried git fetch in action in one of the previous lectures. After Git has performed git fetch, it performs git merge. But notice that git merge is performed locally in your local Git repository. For that, we don't invoke remote repository. All is performed locally. And you know that in merge process there are actually two branches. And the receiving branch in this process will be local branch. And let's say feature branch will be corresponding remote branch. And Git will merge remote branch into local branch. But interestingly that actually Git uses such name as fetch head instead of name of remote branch. And we will explore contents of fetch head in the practice section where we will try git pull in action. And after git merge, remote branch is merged into local branch. And merge process is exactly the same as we have discussed before. If it is possible, Git applies fast-forward merge. If not, Git applies three-way merge and new merge commit will be created in your local branch. And after merge, if it was successful, Git updates, of course, staging area and working directory. And that happens automatically because the currently checked out branch is actually the branch in which we have merged remote branch. That's how git pull works. But please note, we use here under the hood git merge. And we can merge only into one branch, into receiving branch. That's why git pull operation updates only single local branch that is currently checked out. It doesn't update any other local branches, only just one that is currently checked out. Please keep that in mind. Okay, let's now actually discuss step by step what you need to do in order to pull updates from remote repository. And let's talk about it in the next lecture. See you next. Bye. Okay, git pull is actually two-step process, and we first fetch changes from remote repository and after that automatically merge changes into locally checked branch. And notice again that after git pull you will update only one single locally checked branch. Let's now explore this process step by step. In order to perform git pull, you need to first check out local branch. And of course, you need to make sure that this branch is tracking branch and it has corresponding remote branch. As in previous lectures, you can use git branch -vv command in order to verify that local branch has corresponding remote tracking branch. If you have verified that and the local branch is actually tracking branch, you can enter git pull command. You don't need to add any arguments, just git pull. And after entering this command, Git will automatically perform under the hood git fetch and download all updates from remote repository and write them into local Git repository. And after that, Git will update special file called fetch_head. This file is located in the root of .git folder that is of course hidden, and we will explore how this file will be changed actually during this process. And inside of this file, there are actually references between remote branches and SHA-1 hashes of the last commits those branches point to in remote repository. Sounds complicated, but in fact it is pretty simple. And after updating this fetch_head file, Git merges remote branch into current branch using such command as git merge fetch_head. Under the hood, this command looks into fetch_head file, finds their reference for specific remote branch to last commit in remote repository, and merges changes starting from that last commit in remote repository to local branch. And if there were changes both in remote branch and in local branch, then Git will perform three-way merge. And in such case, Git will create new merge commit locally in your branch. If there were no changes in your local branch and there were changes in remote branch, then Git will apply fast-forward merge. And we have tried both types of merges in one of the previous sections. And of course, after merge, Git will automatically update local staging area and working directory for specific currently checked out branch. That's how git pull works under the hood. And please again note that there is no pull operation from remote repository. There is just fetch operation from remote repository. Remaining job is done only locally using git merge command. And again, this happens under the hood, and you can just observe this process if you'll enter git pull command with -v, verbose option. Okay, that's how git pull works. Let me also show another diagram which we have actually discussed before. But now you may see here differences. And there are actually two same branches, but one branch is local branch, it is feature1 branch. Let me actually change its name to feature-1. And there is corresponding remote branch, feature-1. But this branch is located in remote repository. That's why here you see prefix origin, it is default name for remote Git repository. And here you see now two heads, local head that points to feature1 branch and origin/head that points to remote branch, origin/feature1 branch. And when you perform git pull, I have told you before that you need to first check out local branch. And this branch will be receiving branch. Again, please note, your local branch is receiving branch in this process. And on this diagram you see that there are actually changes both in local feature 1 branch, here you see those two commits, and there are changes in remote corresponding branch, here you see also commits. And in such case, when you will want to merge changes from remote feature 1 branch into local feature 1 branch, Git will perform three-way merge. But let me stop now here and dive into the practice and try git pull in action. And after that we will get back to this diagram and complete it. And you'll see how it will look like after git pull operation if there are changes both in local branch and corresponding remote branch. Okay, let's go back to terminal, clear it and go on after the small pause. See you next. Bye bye.
Still watching? Please leave a like and don't forget to subscribe and leave a comment.
Let's now try git pull in action. And first let's verify list of remote and local branches in our repository. Git branch -a, all branches. And now there are two branches remotely, feature 1 and master, and there are two corresponding branches locally, feature 1 and master. And if I'll enter git branch -vv, I'll see local branches with corresponding remote branches, and now feature 1 branch and master branch are tracking branches because they are connected to remote branches. Also we can see the same in git remote show origin command, and here you see that there are two local branches configured for git pull and there are same branches configured for git push. Okay, wonderful. Let's clear terminal and let's now do following. Let's now try to perform git fetch with verbose option. Git fetch -v, enter, and I see in output that Git has fetched updates from this URL, but there is nothing to update locally because both branches feature 1 and master are up to date, and you see this information here. Let's now also try to enter git pull here in feature 1 branch. Git pull, enter, and you'll see that you are already up to date. Let's enter git pull with verbose option -v, enter, and here additionally to this message already up to date, you'll see actually process of git fetch, and this block is the same as you see here. That's why I have told you that git pull actually performs git fetch first, and after that, if there are some additional changes in remote branch, it will try to merge them into your local branch. Okay, let's now switch to master branch. Git checkout master, enter, and let's enter git pull -v here. And you see here same process. First we fetch remote updates, and you may notice that order of branches here is opposite to the order here, and first git fetches changes from currently checked out branch, that is master now, and in previous fetch Git has first checked for changes in feature 1 branch, currently checked out branch at that moment of time. And also you see here that master branch is also already up to date and there is nothing to update locally. And that's why git pull actually didn't perform any merge actions. Wonderful. Let's clear terminal and now let's observe contents of the fetch head file. Let's cd to .git folder, recap that this folder is hidden, and here let's list files with options la, ls-la, and here along with head file you'll see fetch head file and also you'll see orig head file. We will get back to this file later on. Now let's have a look at contents of fetch head file. I will not show you contents of head file because you know that actually head file contains pointer to currently checked out branch and now it is master branch. Okay, let's now use cut command in order to read contents of fetch head file. Enter, and here you see actually two lines. Here is first line and here is second line. Let me try to fit it into the screen and make it a bit smaller like so. A bit smaller again. And now you see that actually every line contains SHA-1 hash, here and here, name of the branch, and here you see names of remote branches, master and feature 1. And here you see actually URL pointing to remote repository. And also you see that first branch here in this list is master branch, and second branch is feature 1 branch. And when you perform git fetch, we have noticed that git first tries to fetch changes from currently checked out branch. Here we saw that. And that's why first branch here in this list will be actually currently checked out branch, and now it is master branch. If I'll get back to feature 1 branch, git checkout feature-1, sorry, I need to go out of .git folder like so, and then run git checkout feature-1. And now if I'll enter git fetch, and again read contents of the .git/fetch head file, enter, I'll see that first branch in this list is currently checked out branch feature 1. And notice here near the next branch, in this case master branch, not for merge tag. But you don't see such tag near the first branch, feature 1 branch. And that means that when you will perform git pull operation, let me actually make it larger again. When you will perform git merge operation, Git will execute under the hood command git merge fetch head. And after this command, Git will find here in this list single branch, it is actually first branch, that doesn't have not for merge tag. And it will find this SHA-1 hash. This is actually SHA-1 hash of the last commit in this feature 1 branch, and we will verify that now. And then merge this commit and all previous commits, if any, into local branch. Let's now actually read the object with this SHA-1 hash. Let me again make it a bit larger, like so. Copy this SHA-1 hash and enter git cat file -p. Let me actually clear terminal first. Clear git cat file -p and paste copied hash, enter. And here you'll see actually commit object. And here is commit message. File list.txt was created in the feature 1 branch. Let's go back to our GitHub repository. And here let's try to find same commit. Let's click here on commits. And of course we need to switch here branch and jump into feature 1 branch. And here you'll see the same commit with the same message. And notice here SHA-1 hash of this commit. It starts with CCC in my case. And if I'll go back to terminal, you'll see same SHA-1 hash of this commit here. We have actually read contents of this commit object. And that means that now in fetch head file, this SHA-1 hash points to very last commit in remote repository. And if I'll try to have a look at output of git log command, you'll see same commit here at the top. And it means that my local feature 1 branch is in sync with remote feature 1 branch. And actually you see this information here in parentheses. Local head points to feature 1 branch. And the remote feature 1 branch located at origin server points to the same commit. And we have actually verified just now. Here you see this information. Here is last commit in this feature 1 branch. And same information is located in this fetch head file. Here is this SHA-1 hash. And that's why when we perform git pull operation now, let's enter this command again, you'll see that we are already up to date. Git simply compares SHA-1 hashes of last commits in local feature 1 branch and in remote feature 1 branch. Okay, I hope it is clear what is fetch head file and what data it contains, and how actually Git compares whether there are any changes between local branch and remote branch. And now let's actually make changes in remote branch and try to perform git pull operation after that. And let's try that next. I'll see you just in a moment. Bye bye. Now our local feature 1 branch is in sync with remote feature 1 branch. And if you'll enter git pull -v command now, you'll see that we are already up to date and there are no changes in remote feature 1 branch. Now let's go to our remote repository and make changes there. Ensure that you are in feature 1 branch, go to code here and click here create new file. And let's create a new file in feature folder. Let's type feature and slash here. And let's name file another file.txt. And contents of this file will be just another file created in the feature one branch, like so. And let's commit changes. I'm happy with this commit message, and you see here that commit will be performed in feature one branch. That's what we actually want. And now let's simply press commit new file button. Changes were committed, and now if I'll click on code and go here to commits, you'll see this new commit here on a list. Create another file.txt. And here notice SHA-1 hash of this commit. It starts with 6F. Let's now go back to terminal and let's try to pull changes now. Please ensure that you are now in feature one branch. It is receiving branch, and now changes from remote branch will be merged into our receiving branch. Let's clear terminal, and now let's enter git pull command, and don't forget to add -v option in order to observe entire process of pulling updates. Enter. And now here I see completely different result. Actually, notice this section here. It matches with output that we have seen after git fetch command. But notice that before this output, Git performs some other actions. And in fact, Git uploads local changes in this feature one branch. And in fact, before fetching, Git uploads local objects from local feature one branch to remote repository. And remote Git compares its objects in feature one branch with yours that you have just sent to remote Git repository in a compressed format. And here on this line, you'll see that actually remote does not see any new files that are absent in remote repository but present in your local repository. And only after that, Git performs git fetch and downloads actually updates from remote repository. And here you'll see that the master branch is up to date, but there were changes in feature one branch. And feature one branch was pointing before to this commit, but now it points to this commit. And if I'll go back to GitHub, you'll see actually two those commits here. Here was previous commit starting with 3C, and last commit is here. It starts with 6F. And that's why here you see this transition from this previous commit to current commit. And that's why local Git decides to update your local feature one branch. Because now at this moment, local feature one branch still points to this commit, but remote branch points now to this commit. And that's why we update local feature one branch. And here is this section related to update. It is possible to perform actually fast forward update in this case, because our branch was not changed after this commit. We did not perform any changes and we have not committed anything in local feature one branch. That's why in this case, fast forward merge is possible. And below you see changes that were made in our local repository after this fast forward merge. And new file, another file.txt was created. And if I list contents of working directory now, ls-la, you'll see feature folder here, and I can actually list contents of feature folder like so. ls-la, feature, enter, and here you'll see this new another file.txt. And that's exactly what we have discussed on this diagram. After git pull, Git performs git fetch, then git merge, and after git merge, it automatically updates staging area and working directory. And now small task for you. We have just verified contents of working directory. Please now yourself try to verify contents of staging area and find this file in staging area. I wish you good luck. Okay, let's now explore contents of staging area together. Git ls files -s, enter, and here you'll see 4 files. And here on the second line you'll see this newly added file, another file.txt. Okay, wonderful. Let's lastly enter git log command and observe output. And here at the top you'll see last commit in our current local feature one branch. And the SHA-1 hash of this commit matches SHA-1 hash of the last commit in remote feature one branch. Let's get back to GitHub And here you'll see same SHA-1 hash. And that's how fast forward works. It has just moved pointer of local feature1 branch to this commit. And no new commits were actually created. Let's now actually quickly outline this in diagram. Let's go back to diagram, this one. Let me copy it actually, like so. Make it smaller a bit. And let's actually remove those commits in receiving branch, like so. And let me delete this. And now let's move this feature1 pointer along with head to this location. And also let me remove those commits because we have made only one commit in remote branch, and move this commit here. And after git pull operation in our case, Git has seen that there are no other commits in local feature1 branch. That's why in this case it is possible to perform fast forward merge. And in fast forward merge, Git simply moves pointer of the branch to last commit in the branch we are merging into receiving branch. And all what Git actually did is, let me make this commit larger and move this to here. And all what actually Git did in this case, it has just moved the pointer of local feature1 branch to last commit in remote feature1 branch. And now remote feature1 branch and local feature1 branch point to the same commit. And in my case, this last commit starts with 6F23. Okay, wonderful. That's how Git has performed the git pull operation when there were no other commits after this last commit. Okay, now let's perform the same operation, but after we will make some new commits both in remote feature1 branch and in local feature1 branch, and we will see what will happen. I'll see you next. Bye bye.
Hey, are you still here enjoying this tutorial? Then smash a like button and leave a comment.
We have just successfully performed git pull operation and pulled changes from remote feature1 branch and applied them into feature1 branch, local feature1 branch. And it was possible to perform fast forward merge. That's why Git has simply moved pointer of local feature1 branch to the same commit as for feature1 branch in remote repository. Now let's make some changes both in remote repository and local repository, and after that we will try to perform git pull operation once again. Okay, let's go to terminal, and here in terminal let's make changes in feature1 branch, and for that let me open Visual Studio Code and open repository here. File, open, and here go to desktop and choose my first GitHub repository. Open. And my repository was opened here. Okay, wonderful. Here I see two files in root of the project and two files in feature folder. Another file.txt and list.txt. Now let's modify another file.txt. And let's add another line. This file was modified locally. Let's save changes and let's commit them. Go to source control here and type commit message. Modified another file.txt locally. And let's commit changes. Press this icon and changes were committed. Please notice here this small one. And that means that there are changes ready to be pushed. But now we won't push anything to remote repository, we want to pull changes. But before doing that, let me switch back to remote repository and make changes here. Let's go to code. And let's create another file here in feature1 branch. And let's again create another file in feature folder. And let's name this file one more file.txt. And contents will be this file was created in the remote repository. And let's commit changes. Leave commit message by default and commit new file. Okay. Now there are changes both in remote repository and in local repository. And if I'll go to code here and click on commits, you'll see 6 commits in feature1 branch. And last commit is this one, create one more file.txt. And here you'll see SHA-1 hash of this last commit. And of course there is no such commit in local branch, and vice versa. In local branch we have created another commit. Let's have a look at contents of this commit. Here is SHA-1 hash of this commit, and here is message modified another file.txt locally. And this commit is absent in remote repository. And here actually you see information that the current head points now to feature1 branch, and remote feature1 branch points to this commit. And notice that at the moment we have not yet fetched changes from remote repository. And that's why here you see actually outdated information. Notice SHA-1 hash of this commit object. It starts with 6F23. And if I'll go back to remote repository, you'll see SHA-1 hash, same SHA-1 hash here. It is previous commit. And that's because, again, we have not yet fetched changes from remote repository. Let's close this output and let's actually perform git pull operation manually. And first we will fetch changes, and after that perform git merge fetch head operation. Let's do that. Let's clear terminal and first enter git fetch with -v option. Enter. And here you see similar output, and actually on those lines you see result of git fetch operation. Again, master branch was not changed, it is up to date, but remote feature1 branch was changed, and now last commit has this SHA-1 hash. Before, remote feature1 branch was pointing to this commit, and now it points to this commit. And if I'll get back to GitHub, you'll see those two commits here. Here was previous commit and here is last commit. Starts with D0. Okay, but remember that in remote repository we have created new file called onemorefile.txt. And let's actually try to list contents of staging area now. Git ls files -s. Enter. And here now I don't see onemorefile.txt. That's because we have not yet merged any changes from remote repository. But let's now examine contents of the Git repository and have a look at contents of the objects folder in .git folder. ls-la.git/objects. Enter. And here let's have a look at folders that were just created at 10:50. And there are three folders: D0, this one, A1, this one, and 6C, this one. And you can guess that actually in this folder Git has created object for remote commit, last commit in remote repository, this one. Let's now list files in this D0 folder: ls-la.git/objects/D0. Enter, and here you'll see single file with this name. And it starts with 7.3, and if you look at this commit SHA-1 hash, you'll see same start here, D073. And we can be sure that this object contains actually commit from remote repository. But please note that at the moment this commit was not merged into local feature1 branch, but it already exists in our local Git repository. We can actually use git cut file command and read contents of this commit object, D07324. Enter, and here we see this remote commit, and here is message create onemorefile.txt. Same message as you see here. Okay, let's also have a look at the other objects that were just created. Let's list again objects in .git folder, and let's examine object in this folder, A1. Let's list contents of this folder, ls-la.git/objects/a1, enter, and here you'll see single file, and let's enter git cut file command -p, and let's actually have a look at type of this object, -t, and enter A167AE, enter, and here you'll see that it is actually blob, and it seems to me that this object contains actually contents of this new onemorefile.txt that was created in remote repository. Let's use -p option here, like so, and yes, it is exactly the same file that was created in remote repository. And if I'll go there, go to code and click here on contents of onemorefile.txt, here it is, you'll see the same line. This file was created in the remote repository. And again, it proves that after git fetch, Git has automatically created all missing objects in local Git repository. And now actually our local Git repository contains same objects as remote Git repository. Let's finally have a look at contents of the last file that was just created, and it is located in folder 6c. Let's ls-git/objects/6c, enter, and let's git cut file -p 6c10 enter. And here I'll see contents of the tree object that points to 3 files. Another file.txt, list.txt, and one more file.txt. And this object contains actually pointers to all files in feature folder that was created in remote repository, this folder. Here you see same 3 files as you see here. Okay, now you understand that after git fetch, Git creates locally all missing Git objects that were created in remote repository. And that's why after that you are able to perform any actions, for example merge changes, locally without interaction with remote repository. Okay, wonderful. Let's clear terminal and let's now proceed and actually merge changes into local repository, but let's do that after the small pause. See you next. Bye bye. We have just verified that after git fetch operation, Git has created several objects in local Git repository. And now we can actually perform git merge of the fetch head. But before doing that, let's have a look at contents of the fetch head file. cut.git/fetch head, enter. And here we see pointers for remote branches, for feature 1 branch and master branch. And now after last fetch, feature 1 branch points to this commit with this SHA-1 hash. And it matches with SHA-1 hash of the last commit here in remote repository. Let me go to commits, and here is this SHA-1 hash. And it means that data is recent, and now feature 1 branch locally and remotely are in sync. Same relates to master branch, and you can verify yourself that this SHA-1 hash actually matches with SHA-1 hash of the last commit in remote master branch. Okay, now we can actually perform merge of the fetch head into local feature 1 branch. But let's enter last command before that, git log, enter. And here now we see that local head points to feature 1 branch, and local feature 1 branch points to this commit, starting with F1. But this commit recap is absent in remote repository. And you don't see actually pointer to last commit in remote feature 1 branch. That's because we have not yet merged remote changes into local feature 1 branch. That's why you don't see this commit here on this list. Let's now perform git merge of the fetch head. Let's close this and let's clear terminal and type git merge fetch _ head. Enter. And now we are asked to add text for merge commit. And it is a sign that Git tries to perform 3-way merge. And that happens when there are changes both in local receiving branch and in other branch we are merging into receiving branch. I am happy actually with this commit message merge branch feature 1 of remote repository URL into feature 1 branch. And if you are happy too, you can type just :wq, write changes and quit. Enter. And merge was successful. Merge was made by recursive strategy. It is a sign of actually 3-way merge. And locally, one more file.txt was created in the feature folder. And now if I list contents of the feature folder in local working directory, ls-la feature, enter, you'll see this one more file.txt that was just created. And same file you'll see in Git staging area. Let's type git ls-files-s, enter, and here you see this file as well. Okay, Git has successfully merged changes from remote feature 1 branch into local feature 1 branch. And let's actually now clear terminal and try to pull updates again. Git pull, enter, and now we see that we are already up to date and there is nothing to pull. And if I'll enter git log command, enter, you'll see that now local head points to feature 1 branch, and here at the top you see this new merge commit. And here is SHA-1 hash of this new last merge commit. And this new commit now points to two parents. Here is first parent and here is second parent. But please notice that remote feature one branch still points to this commit. It doesn't point to this merge commit. Why is that? How do you think? That's because we have not yet pushed our updates. And recap that we have actually updated another file.txt locally. But if I'll go to remote repository and have a look at contents of another file.txt, let's open it. It is located in feature folder, another file.txt. You will not see this another line. This file was modified locally. That's because those changes are currently located only in our local feature one branch. They are not incorporated into remote repository. But all changes from remote repository are now incorporated in our local repository. And that's why here you see this merge commit. Okay, wonderful. That's how git pull works. And if I'll go back to diagram, this one, we can modify it and add here new merge commit. Let me copy this commit, move it here. It will be merge commit actually. Let me make it a bit larger. And now local feature one branch points now to this new merge commit, like so. And this merge commit also has pointer to this commit in remote repository. Here we saw that there are two parents. Actually, we can take SHA-1 of this commit and use gitcat file -p and paste SHA-1, enter, and here you'll see those two parents. One parent is last commit from remote repository, and another parent is last commit in local repository. And now picture looks like this. But please notice that remote feature one branch still points to this last commit here, but local feature one branch points to last merge commit. Okay, wonderful. That's how git pull works when there are changes in remote repository and local repository. Now it's time to move on, and next we will try to change same files in same places, both in remote repository and local repository. And you may guess what will happen. We will get merge conflict, and we will see how we will be able to resolve such merge conflict. I'll see you in the next lecture. Bye bye. We have just successfully performed merge of remote feature one branch into local feature one branch. And in fact, we have performed git pull manually in two steps. First, we have fetched updates from remote repository, and after that we have merged fetch head into local feature one branch. And now feature one branch and the feature one branch in remote repository are in sync. But actually there are changes in local feature one branch that were not yet pushed to remote repository. We will push those changes to remote repository in the next lecture, and in this one we will try to create merge conflict during git pull operation. And for that we will make changes in remote feature one branch and in the local feature one branch in the same file in the same place. And after that we will try to perform git pull operation. Okay, let's try that. Let's go to GitHub and ensure that you are here in branch feature 1, and let's adjust readme.md file, this one. Let's go to this file and click on edit this file icon here, and let's edit this line number 4. Currently contents of this line are readme.md file was just edited manually. And let's edit here dot and type one more edit at GitHub, like so. And let's save those changes, I mean commit them. Let's scroll down and commit message will be update readme.md file, I am happy with that. And let's commit directly to feature one branch. Press button commit changes, and changes were committed. And now here you see this updated line, one more edit at GitHub is visible here. Okay, wonderful. Let's now go back to terminal and let's edit readme.md file here as well. Let me clear terminal and let me edit readme.md file directly here in terminal using nano editor. Nano readme tab.md. Enter. And let's modify the same line and also add the change dot and this file was modified locally. like so. Let's write changes, Ctrl O, press Enter, and exit, Ctrl X. Okay, wonderful. Now I have one change that should be committed now. Let's enter git status, enter, and here is this change. readme.md file was modified, and now let's commit this change. Git commit. I'll also add -a option to add this file to staging area automatically, then -m option and write here commit message, modified readme.md file locally, like so, and press enter. And changes were committed. If I'll enter git log command now, you'll see this last commit here. But of course, this commit is absent in remote repository, and last commit from remote repository, let me go to this commit, click here on code and click here on commits. I'm talking about this commit. This commit is absent in local repository. And now let's try to perform git pull operation. And again, notice that we have modified same file in the same places in remote repository and in the local repository. Let's close this and now let's enter git pull. Let me clear terminal and enter git pull, and let's add option -v verbose. Enter. And now here I see merge conflict. You may notice that git fetch has shown us that feature one branch in remote repository was updated, and the previous commit it was pointing to was this one, and now it points to this commit. But during automatic merge process, Git has discovered that there are conflicts, namely single conflict in readme.md file. And here you see this information. And you see also message that automatic merge failed and you should fix conflicts and then commit result. Let's go to GitHub desktop and observe status of repository there. GitHub desktop, and let's open here project. Actually, we have not added it. Let's add it quickly. Click add and click add existing repository. Choose here path, and repository in my case is located on desktop, and here it is, my first GitHub repository. Let's click open and add repository. Okay, and after adding repository, you'll immediately see that there is conflict in feature one branch. And namely conflict is in readme.md file, and you can as usually open this file in Visual Studio Code or other editor you are using and resolve conflict manually. Let's also go to Visual Studio Code and observe status of repository there. Ensure that your project My First GitHub repository is opened here, and if you'll click here on source control, you'll see that there are conflicts in readme.md file. You see this small c here. And if I'll click on this file, you'll see this conflict here. And we can either accept current change, this one, or accept incoming change, this one, or accept both changes. And you know that current change is change that was made in receiving branch. In our case, this feature one branch in local repository. And you see this text that we have added locally. This file was modified locally. And this section is from remote repository. In our case, from feature one branch in remote repository. And here you see this change that was made remotely at GitHub. One more edit at GitHub. Also here you see actually SHA-1 hash of remote commit where this change was introduced in remote repository. And the reason why you see here this hash here instead of the name of the branch, as usually when you see merge conflicts, is that under the hood, git pull operation performs merge of the fetch head. And inside of the fetch head, there is simply reference to specific commit that should be merged into receiving branch. That's why here you see this SHA-1 hash of this commit. Please again notice that we are merging remote branch into local branch. That's why local branch is receiving branch, and you see this change here first, and remote branch is feature one branch that is merged into local branch. That's why remote changes you see here after local changes. Okay, before resolving this conflict, let's quickly get back to terminal and observe status of the staging area. And type git ls files -s, enter, and now we see three versions of the readme.md file. And we have talked about that before. When you have conflicts in your repository, Git will create three different files for each file with conflicts in staging area. And first version with number 1 here is file that was actually common for both branches before any change. Next one is changed file in receiving branch, and finally comes version of the file that exists in feature branch that is merged into receiving branch. And actually we can quickly observe contents of this file. Let's take file with number 3 and let's type git cat file -p and paste copied hash. Enter. And here you see a version of the readme.md file that exists now in remote repository. And you see here this line that was added there, one more edit at GitHub. If you want, you can also read contents of readme.md files with numbers 1 and 2. Okay, that's our conflicts that exist now in staging area. And of course, if I'll try to read contents of readme.md file here in working directory, I'll see this conflict here. And you could resolve this conflict in any editor you want. We will do that in Visual Studio Code. Let's get back to it, and now let's suppose that we are not happy with any change, either this one or this one. And in such case, I can simply remove this entire part, like so, simply select and delete, and type another version of this line. And let's suppose that I want to type simply this line was modified manually during conflicts resolution. Like so. Let's save this file. Save. This file was saved, and now let's go back to terminal. And let's enter git status again. Enter. And here we still see that there are conflicts. And we have actually already modified readme.md file and saved changes. And now we should add the changed file to staging area, and after that type git commit. But before doing that, let's enter git ls files -s in order to observe status of staging area, and we still see 3 different versions of readme.md file, and that means that we have not yet committed changes. And now let's commit changes after resolution of the conflict. And we can simply type git commit with option -a. It will automatically add all changes to staging area, and after that commit them. Let's press enter. And here we see default commit message, merge branch feature 1 of remote repository into local feature 1 branch. And you also see that there were conflicts in readme.md file, but conflicts were resolved. And if you are happy with this commit message, you can simply type :wq and press enter. And now you see that merge of the remote feature 1 branch into local feature 1 branch was successful. And if I'll enter git log command now, you'll see this last commit here, merge branch feature 1 into local feature 1 branch. And this commit also has 2 parents. That's because, again, we have merged remote branch into local branch. And notice that below you see last commit that was made locally, but if I'll scroll down a bit, you'll see commit that was made in remote repository, update readme.md file. And SHA-1 hashes this one and this one are actually parents for this last commit message. And you see 2 SHA-1 hashes of those 2 commits, this one and this one, here on this line in the last merge commit. But please note that remote feature 1 branch still points to this commit. It hasn't incorporated either this merge commit or this commit. That's because we have not yet pushed our changes from local repository to remote repository. And if I'll go to remote repository and go to code and open here readme.md file, you'll see that there is still version that was modified remotely at GitHub. But locally in local Git repository, this line was replaced with this text. This line was modified manually during conflicts resolution. And now it's finally time to try git push operation in action. And we will push all changes made locally to remote branch in remote repository. Let's try to do that in the next lecture. I'll see you there. Bye bye. In the previous few lectures, we have performed git pull operation several times. And during git pull operation, you actually fetch changes from remote repository and after that merge them into local repository. And pull operation actually writes changes into single locally checked out branch. And we have merged remote changes from remote feature one branch into local feature one branch. And if I'll enter git pull command now, you'll see that local feature one branch is already up to date. And please notice that during git pull operation, Git hasn't asked us for any credentials, I mean username or password. That's because our remote Git repository is public and anybody in the world is able to fetch updates from remote public repository. And if you'll enter git remote command with option -v, you'll see actually two URLs that are used for git fetch and for git push. And now it's finally time to try git push operation in action. And now at this moment of time, there are changes in local repository that are absent in remote repository, and some changes in some files are different. And that's why now we can try to perform git push operation in action. Notice that in order to perform git push operation, you need to have write access to remote repository. In our case, we will write changes into our own remote repository called my first GitHub repository, and during git push operation, Git will ask us for username and password at github.com. Okay, as you see now, there are no changes in remote repository that we should pull, we are already up to date, and the URLs for fetch and push are set correctly. Now we can try to push changes. But before doing that, let me go to GitHub desktop and observe changes here. And you will notice that if you will select my first GitHub repository here, you will be able to push origin. And you'll see here that there are 4 commits available for pushing. And that means that in your local repository, there are 4 commits that are absent in remote repository. That's why you are able to push them to remote. Also, if you'll go to Visual Studio Code, you'll see this information here as well. You'll see here 0 and 4. This 0 means that there are no remote changes that you should pull to your local repository. But there are 4 local changes that you should push to remote. Okay, let's go back to terminal. And let me enter here git log command and I'll show you something. Please notice that there are different authors in different commits. For example, in this merge commit, author is me, Bogdan Stashuk, and my email. But if I'll scroll down, here in this commit, for example, you'll see that author is Mike GitHubber. And that's because this commit was made in another account by another user, Mike GitHubber. Also, if I'll scroll down again, you'll see another commit that was made by me. And this commit was made again locally during pull process. And it means that in my case, author of local commits is me and author of remote commits is Mike GitHubber. There are 2 different authors. And in your case, if you have created GitHub account for yourself with your name and your email, you should see same information here and here. But actually it is not a problem for remote repository. I can easily push local changes with such author to remote repository, and remote repository will accept those changes. But let me actually try to perform git push operation now. Let me close this and clear terminal and type git push with -v option. Enter, pushing. And here in my case you see this prompt. In your case, you may not see it if you have not performed any remote Git operations before. But before, on the same computer, I have pushed changes to my own GitHub account, bstashuk. And that's why username and password for this GitHub account were stored in my local keychain. And if I'll enter here my login keychain password, operating system will try to retrieve username and password from local keychain store. And if I'll click here allow, you'll see that permission to this remote repository, my GitHubber / my first GitHub repository.git denied to bstashuk. And I get fatal error and HTTP response code 403. And that means that I'm not able to write to remote repository under username bstashuk. And the reason for that is that this username is already stored in my local keychain access. And please note that you will not see this error if you have not yet pushed to any other GitHub accounts. But let me now fix this issue. Let me open keychain access and go here to all items and filter by GitHub, like so. And here let me find account with access control git credential OS6 keychain. And now I'll simply remove this account with password. Let me close this and right mouse click and click delete github.com and confirm deletion here. Click delete button. And this record was deleted. Let me get back to terminal and let me do one more thing. In order to avoid further discrepancy in this repository, I mean difference with authors in local repository and remotely, let me set up a custom username and email for this local repository, my first GitHub repository. And for that I need simply type git config user.name and here type my githubber, like so, and enter git config user.email and type here Mike's email, mikegithubber@gmail.com. Enter. And after this change, author of all local commits will be Mike GitHubber. Okay, great. Let's now try to perform git push operation once again. Let me clear terminal and enter git push -v. Enter, pushing, and now I am prompted to enter username for github.com. And I'll enter username of Mike GitHubber, enter, and password, Mike's password, and press enter. And finally, you'll see here process of pushing changes to remote repository. And now we see that remote feature 1 branch now points to this commit with this SHA-1 hash. And also Git has updated local tracking reference for refs/remotes origin/feature 1 branch. And now remote feature 1 branch and local feature 1 branch should point to the same commit. Let's verify that. Git log, enter. And now I'll see that local head points to feature 1 branch and it points to commit with this SHA-1 hash, it starts with 6b, and remote origin/feature 1 branch also points to the same commit with the same hash. Let's verify this in remote repository. Let's go there and ensure that you are in feature 1 branch. And let's click here on commits. And last commit here will be commit with this SHA-1 hash. It starts with 6b, same commit as you see here. And that means that all changes from local repository were incorporated into remote repository. And here you see several new commits, for example this one, and those 2 commits. And all those commits were made by me. Author is Bistashuk. And also you see that GitHub has automatically retrieved my photo from my profile at GitHub. And that's what I have told you before. You can push to remote repository changes with any author. And author of this commit is me. And you actually now see this commit with same SHA-1 hash here on the list. Here it is. But again, it doesn't matter for Git. As long as you have permissions for writing changes to remote repository, you will be able to push such commits to remote repository. But recap that in this lecture I have actually modified the author and email for this local repository. And actually I can read contents of config file, let's do that, cat.git/config, enter. And now here at the bottom you'll see new author and email for this local repository. And let's now actually try to commit other change locally and push it to remote repository. But let's try that after the small pause. See you next. Bye bye. In the previous lecture, we have successfully pushed changes from our local repository to remote repository. And now you see here all commits that were missing before. But in my case, author of those commits that were just pushed to remote repository is different from the author of other commits. And actually in the previous lecture I have modified the local name and email specifically for this repository. And now let's try to make another change here and push this change to remote repository. Let's try that. Let me open Visual Studio Code and let's change, for example, readme.md file once again here locally. Let me add new line was added locally, like so. Let's save this file, go to source control here, and let me type here commit message, another
local change and commit this. Wonderful. And immediately here in Visual Studio Code, you'll see that there is single change ready to be pushed. Let's do that in the terminal. Let's go there and type git push -v. Enter. Pushing. Please notice that I'm not prompted for username and password anymore. That's because they were stored automatically. And now changes were successfully pushed. Let's go to remote repository and refresh view here. Click refresh. And now I'll see here another local change. And now this change was made by my GitHubber. And if I'll go back to terminal and enter here git log, I'll see same information here in last commit. Author is Mike GitHubber and email is mike.githubber@gmail.com. And that means that local settings for username and password have more priority than global settings of username and password. Okay, wonderful. That's how you can easily make any changes locally and push them to remote repository. And now our local feature1 branch is in sync with remote feature1 branch. They both point to the same commit. In my case, SHA-1 hash of this commit is here. And same commit you'll see here on the list. It starts with 3EFC. Okay, that's how git push works. Now you can try to experiment yourself, make some new changes in your project, commit them, and push them to remote repository. In the next lecture, we will verify that our local feature1 branch is fully in sync with remote feature1 branch. See you in the next lecture. Bye-bye.
Still watching? Please leave a like and subscribe, and make sure to leave a comment. In the previous lectures, we have tried in action git pull and git push operations. And we have pushed some local changes, and for example, in my repository, you see this commit and this commit that were made locally on my computer under actually other user, and here you see my username. And after that, I have pushed those changes to repository owned by my GitHubber. And for Git, it's actually not an issue at all. And as long as you have actually credentials for writing into your remote repository, you are able to push commits made by any author. And now actually remote repository and local repository are fully consistent, and there are no changes locally that are absent in remote repository, and vice versa. There are no any changes in remote repository that are absent in local repository. And we can prove that, for example, using GitHub Desktop. And make sure that you have chosen this repository here. And if I'll click this button, Fetch Origin, you'll see that after fetching, you will not see any new updates, and that means that you are in sync with remote repository. Also, you see that there is nothing to push, and there are no local changes. And that again proves that remote repository and local repository are fully in sync. I can also switch, for example, to Visual Studio Code, and you'll see here in the bottom left corner that there are no remote or local updates. And you can sync changes, click on this button, click OK here, and again you will not see that Git will either push or pull any changes. And here actually you have seen a message that we are able to enable automatic periodic fetch. And the Visual Studio Code will fetch from time to time remote repository and will notify you when any changes will be made there. Okay, let's go to terminal as well, and let's try to enter here git pull with option -v. Enter. And here you'll see that we are up to date in both branches, feature1 branch and master branch, and there is nothing to pull. Also, if I'll enter git push -v, enter, you'll also see that there is nothing to push, and remote feature1 branch is up to date with local feature1 branch. And actually we can observe reference for remote feature1 branch and compare it with reference for local feature1 branch. Let me actually take this path like so and use cut command here, type .git / and paste copied path like so. Enter, and here you'll see this SHA-1 hash of the last commit in remote feature1 branch. And if I'll have a look at file .git /refs/heads/feature1, it is actually local feature1 branch, enter, I'll see same SHA-1 hash. And that means that remote feature1 branch and local feature1 branch point to the same commit. Okay, now we are ready to proceed, and next we will try to create new local feature2 branch, make some changes in the repository in that branch, and after that we will try to create remote feature2 branch based on this newly created feature2 branch. Let's do that next. See you in a moment. Bye bye. At the moment there are 2 branches in remote repository and 2 branches in local repository. And you can see list of all branches in remote repository here by clicking on this button, and you see feature1 branch and master branch. And if I'll go to terminal and type here git branch, enter, I'll see 2 local branches here as well, feature1 and master. Also I can type git branch -vv, enter, and here you'll see corresponding remote branches for every local branch. Okay, wonderful. Now let's create another local branch named feature2. Then we will make some changes in project and commit those changes locally. And after that we will create remote branch with the same name, feature2, and push changes to this remote branch. Okay, let's do that. Let's create new branch simply typing git checkout -b, and name of the branch will be feature-2, like so. Enter. And new branch was created, and we were automatically switched to this newly created branch. Let me type git branch command, enter, and now I see 3 branches on the list. But if I'll type git branch -r, that will list remote branches, I will not see newly created feature2 branch here on the list. And that means that when you create any local branch, new remote branch will not be created automatically. You need to do that manually. Okay, and if I'll type git branch -vv, enter, you'll see feature2 branch here on the list, but there is no corresponding remote branch here. And that means again that there is no corresponding remote feature2 branch. And local feature2 branch is not now tracking branch, it is just regular branch. Okay, let's close this and let's make some changes in our project in this branch. Let's go to Visual Studio Code and notice that here in a corner you'll also see currently checked out feature2 branch. Okay, let's click on Explorer here and let's change, for example, another file in feature folder. And let me add here new line. This line was added in feature2 branch. Also, let me replace this first line and I'll type simply this line was replaced in feature2 branch, like so. And notice that VS Code highlights different lines, and a green color is used for new lines and this color is used for lines that were modified. Okay, let's save changes and now let's commit those changes. Let me click here on source control and type commit message. Another file.txt was modified in feature2 branch, like so, and commit changes. Wonderful, changes were committed. Let's go to terminal and type here git log command, and here I'll see this last commit. And notice that local head points to feature2 branch and the feature2 branch points to this last commit. But remotely in remote repository, this branch of course is still absent. And there is feature1 branch that points, for example, to this commit. Okay, if I'll type git branch -a now, I'll still see feature2 branch only locally and there is no corresponding remote feature2 branch. Okay, great. Let's now create a new remote branch with the same name, feature2, based on newly created local feature2 branch. For that we need to use git push command, but with specific option. Let me first clear terminal and type git push command without that option. Let's type git push and add option -v. Enter, and now you'll see fatal error. Current branch feature2 has no upstream branch. To push the current branch and set the remote as upstream, use this command. And here you see this option, -- set upstream. And after this option, you need to specify name of remote server. Here you see default name origin. And also after name of remote server, you need to specify name of new remote branch. And in this suggested command, name of remote branch matches with the name of local branch, feature 2. Okay, let's type this command git push -- set upstream origin feature -2. And actually, instead of this option, you can use shortcut, simply remove this option like so, remove one dash as well and type simply -u. And let's also add -v option like so. Enter, pushing to remote repository, enumerating objects, and remote feature to branch was successfully created. And here you see that this branch is new branch. And now local feature to branch is set up to track remote branch feature 2 from origin. And now our local feature to branch is tracking branch. Okay, great. We can actually verify that quickly by typing git branch -vv, enter, and now I see that local feature to branch has corresponding remote feature to branch. And after this point, when you will make any new commit, you need to simply enter git push command in order to push changes to newly created remote feature to branch. Let's now actually try that quickly. Let's go to VS Code and let's modify this another file.txt, add new line, another modification in the feature to branch, save the file, go to source control, type commit message, another change in feature to branch, and commit this change. And now go back to terminal and enter git push -v, enter, sorry, typo, git push -v, enter, pushing to remote. And notice that we are not prompted to enter name of remote branch. That's because local feature to branch is already tracking branch and there is already corresponding remote branch for this local branch. And changes were successfully pushed. And now remote feature to branch points to this commit. And this commit is actually last commit in this local feature to branch. Here you see the same SHA-1 hash. And also here in parentheses we see that local head points to feature to branch and remote feature to branch located at origin server points to the same commit. And now we can go back to remote repository and observe changes here. Let's refresh, click on list of the branches, and here you'll see newly created feature to branch. Let's click on it, go to code, go to feature folder, and click on another file.txt. And here you'll see those new lines that were added in local repository, and after that push to remote repository. Let's go back to code, click here on commits, and here you'll see last commit made in local repository. And notice that author of this commit is my GitHubber, not Bistashchuk. And the reason for that is that I have modified local configuration of Git. Let me show it quickly to you, cat.git/config, and here you'll see name and email that will be used for all commits made locally in this repository. And if I'll enter git log command now, you'll see actually those records here, author name and author email. Okay, that's how you can create remote branch based on local branch. And for that, you need to use git push command with option -u upstream. Let me clear terminal and enter this command again, git push -u. After that comes name of remote server by default origin, and then comes remote branch name, like so. Okay, that's all for this lecture, and in the next one, I'll show you another thing. And I'll show you case when, for example, one of the branches is deleted in remote repository. And I'll show you how to update tracking statuses for such case. I'll see you in the next lecture. Bye bye. In this lecture, I'm going to show you how to update tracking statuses for branches if specific branches were deleted in remote repository. And plan for this lecture is following. First, we will create a new branch called temp in the remote repository. After that, we will check out this newly created branch locally using git checkout temp. And you know that after this command, if you check out remote branch, corresponding local branch will be created with the same name. And this newly created branch will become automatically tracking branch. After that, we will delete remote temp branch in remote repository. And after deleting, we will fetch changes. And after fetching, we will observe tracking statuses for all branches in local repository using git branch -vv command. And you'll see that local temp branch will still track remote temp branch, even after deletion of the remote branch. And if you want to avoid such situation when any local branches will still track remote branches after deletion of those remote branches, you can update tracking statuses for branches using such command as git remote update origin --prune. And after this command, we will enter again git branch -vv command, and you will see how tracking statuses will be changed for local branches. Okay, let's get started. And let's start by creating a new temp branch in remote repository. Recap that there are already 3 branches, feature 1, feature 2 and master, and we can create new one by simply typing its name here, and let's give it name temp, and let's click create branch temp. Okay, new temp branch was created, and now it is currently selected as current branch. Let's go now to terminal here, and let's list all branches here. Git branch -a, enter. And now I don't see actually this remote branch on a list, and in order to see it, I need to perform actually git fetch first. Let's close this output and let's enter git fetch, enter. And you'll see that there is new branch called temp in remote repository. But if I list branches now again, git branch -a, I'll see this temp branch at origin, but I will not see this branch locally. And that is logical. You know that fetch operation only writes remote changes to local Git repository. And in such case, just a new reference file will be created in .git/refs/remotes/origin folder. And that will be remote temp branch. But corresponding local branch will not be created automatically. And we need to do that manually if you want to create corresponding local branch. And for that, we need to simply check out newly created remote branch, typing git checkout temp, like so. Let's press enter, and now new local temp branch was created. We were switched to this newly created temp branch, and now this temp branch tracks remote temp branch at origin. And if I'll enter git branch -a command now, you'll see now local temp branch, and this branch tracks remote temp branch. I can verify that by typing git branch -vv, enter, and now you'll see that local temp branch is tracking branch and corresponding remote branch for it is origin/temp. Wonderful. Let's now go to remote repository and let's delete remote temp branch. In order to delete a remote branch in remote repository, you need to click on branches list here, find temp branch that we want to delete, and click here this icon, delete. And now this branch was deleted. But if I'll go back to terminal and enter git branch -a, you'll still see temp branch here on the list. And if I'll enter git branch -vv, you'll still see that local temp branch tracks remote origin/temp branch. And that's because we have not yet entered git fetch command and we have not yet fetched changes from remote. Let's fetch changes. Let me actually clear terminal and enter git fetch -v, enter. And you'll see that updates from 3 branches were fetched, from feature 1, feature 2 and master. But there is no temp branch here on the list. Let's now enter git branch -vv command, enter, and you'll still see here that local temp branch tracks remote temp branch. But now this remote temp branch is absent, it is deleted. And if I'll go back to remote repository and click here on all branches, you'll see now that there are only 3 branches, master, feature 1 and feature 2. There is no temp branch. But again, local temp branch still tracks remote temp branch. And that's where this command git remote update origin --prune comes in. Let's try to enter this command. Go back to terminal, git remote update origin -- prune. But let's actually first try without this option, like so. Let's press enter, fetching origin, and if I'll enter git branch -vv now, you'll still see that local temp branch tracks remote temp branch. And now if I'll enter same command git remote update origin, but now with option -- prune, enter, you'll see that origin/temp branch was deleted. And if I'll enter git branch -vv command again, you'll see gone here in this list. And that means that now local Git repository knows that remote temp branch is gone. It is not available anymore. And for example, if I'll go now to GitHub desktop, you will see that we are now able to publish our branch. Git automatically recognizes that there is no corresponding remote temp branch, but we are able to create remote branch again by publishing our local branch. And that's because we have just updated tracking statuses for branches. Now Git knows that there is no remote temp branch, but there is still local temp branch. And if you want to remove local branch, you need to use git branch command with -d option. Let's try that. Let's check out another branch, git checkout master, enter, and now let's enter git branch -d temp, enter. You'll see now error that the branch temp is not fully merged, and that's why it wasn't deleted. And if you want to force delete it, even if branch was not merged, you need to use -d, capital D option, enter, and now branch temp was removed locally as well. And if I'll enter git branch -vv command again, you'll see that there is no temp branch anymore, either in local repository or in remote repository. Okay, wonderful. That's how you can update tracking statuses for local branches. You need to use this command. Notice that in this lecture we have removed remote branch at GitHub, but it is possible to remove remote branches from local terminal. And in the next lecture I'll show you how to do that. See you in the next lecture. Bye-bye.
Just friendly reminder, now it's the best time to become my subscriber, smash a like button and leave a comment under this video.
We have tried to delete branch in remote repository at GitHub, but now I'll show you how to delete remote branch from local terminal. And for that, let's create again branch temp, and we will do that in local repository. After that, we will push this branch to remote repository, and after that, remove this branch from remote repository. Okay, let's get started. Let's create a new branch called temp. For that, I can simply type git checkout -b and name of new branch, temp. Enter. And new branch was created and we were automatically switched to this new branch. And now if I'll enter git branch, I'll see this new temp branch on the list. But if I'll add -a option like so, you'll see that temp branch is absent in remote repository. Let's now create corresponding remote branch in remote repository. Git push -u set upstream. It will create new remote branch, and after that type origin, name of remote server, and the next comes name of remote branch, in our case temp. Let's press enter. And new branch called temp was created in remote repository, and our local temp branch is now set to track remote branch temp from origin. And now if I'll enter git branch -vv, I'll see that there is corresponding remote branch for local temp branch. We can verify actually that new branch was created by going to GitHub and refreshing page here. And new temp branch has appeared here on the list. Notice that GitHub also shows you differences in every branch. For example, this branch is up to date with master branch. And if I'll hover mouse over those icons, you'll see that this temp branch is even with master. But if I'll hover mouse here for feature 1 branch, you'll see that this branch is 9 commits ahead of master, and feature 2 branch is 11 commits ahead of master. Okay, great. Now let's delete this remote temp branch from local terminal. Let me clear it first, and now simply type git push origin,
-d and name of remote branch. Remember that with -d option we are able to delete local branch using git branch -d command. If you want to remove remote branch, you need to use git push command with name of remote server with option -d and name of remote branch, in our case temp. Let's press enter. And remote branch called temp was removed from remote repository. And now if I'll enter git branch -a command, you'll see local temp branch, but remote temp branch was removed. And if I'll go back to GitHub and refresh view here, I will not see temp branch here on the list. That's how you can pretty easily and fast remove remote branch from local terminal. Let's close this and let's remove local temp branch as well. Let's go to master branch for that, git checkout master. And now let's use git branch -D and name of the branch we want to remove, temp. Enter, and branch temp was removed. And now if I'll enter git branch -a, I will not see temp branch either in local repository or in remote repository. Let's now proceed, and next I'll show you another useful command that can be used when you work with remote repositories. And this command is git show ref. Let's talk about it in the next lecture. See you next. Bye bye. Now let me show you another useful command for checking remote refs and local refs. And this command is git show ref. If you simply type this command and press enter, you'll see all references, local and remote. There are actually 3 branches locally in local repository: feature 1, feature 2 and master. And here you see those references. And there are 3 branches in remote repository with same names. And there is also remote head, and you see reference for head here as well. You can actually find those references in .git folder. For example, if I'll list files in .git/refs/heads, you'll see 3 files here on a list for each local branch. And if I list files in .git/refs/remotes/origin, like so, I'll see here remote references. But with this command you can see all local and remote references much faster. And for example, you can compare references for a specific branch. What I mean? Let me clear terminal and type git show ref and type here master, like so. Enter. And now you'll see references only for master branch. Here is reference for local master branch, and here is reference for remote master branch. And you can quickly compare whether references are the same or not. And for example, in our case, references are the same. Remote and local master branches point to same commit with same hash. Same output you can get for any other branch. For example, I can type here name of other branch, feature-1. Enter, and now I'll see references only for feature 1 branch. Again, here you see that there are same hashes for both branches. Local feature 1 branch and remote feature 1 branch. Same for feature 2 branch. Let's have a look, enter, and now you see here similar picture. That's how you can pretty easily and fast compare different branches in local repository and in remote repository. And for example, if I'll try to change something in, for example, feature 2 branch locally and commit changes, you'll see here different hashes. Let's try that quickly. Let's check out feature 2 branch, git checkout feature-2, enter, and now open VS Code and edit one of the files, for example this one, edit in the feature-2 branch. Let's save the file and commit changes. Changes in feature-2 branch. Let's commit, go back to terminal, and now if I'll enter same command, git show ref feature-2, enter, I'll see here 2 different hashes. And that's because now feature-2 branch points to another commit, and this commit differs from commit that remote feature-2 branch points to. And if I'll enter git log command now, you'll see this information here as well. Here is pointer for local feature-2 branch, and here is pointer for remote feature-2 branch. And those commits are different. Let's close this and let's now quickly push changes to remote. Git push -v, enter, pushing.
And now remote feature to branch will point to the same commit as local feature to branch. And now if I'll enter same command git show ref feature to, enter, I'll see same hashes here. That's because now remote feature to branch is in sync with local feature to branch. Okay, please use this command git show ref if you want to quickly compare specific branch in remote repository and in local repository. That's all what I wanted to show you in this section, and here we have tried to use git pull, git push operations. You know what is git fetch, and you know that git pull actually consists of git fetch and git merge fetch head to be specific. And now it's time to move on to next section, where I'll show you what is pull request, how to create pull request, and how it is actually used at GitHub. I'll see you in the next section. Bye bye.
Sad to say, but this tutorial is over. If you liked it, please smash a like button, leave a comment below and subscribe to my channel. Also, don't forget to share this video with anyone you know. And I hope to see you in the next tutorials. Bye bye.